Okay, so hopefully we got some audio here. Just give us a moment here. I'm just testing. We had to do some bunch of unnecessary setup, so we're just figuring this out. Okay, I think I can just crank up the mic here, and I think we'll be good. So hi everybody, as I wear my dev shirt. Welcome to the DCG201.org channel as our first instant reward pops up. Um, For all of you who are wondering out there, a couple of things. One, I'm known on the interwebs as Side Pocket. I'm one of the two co-founders. I'll repeat that. I'm one of the two co-founders from Side Pocket. I'm one of the two co-founders of DCG 201, formerly known as DEF CON 201 and DC 201. We are, and beware, I'm on a lean mixture, and I'll explain why in a moment. We normally, oh, hi, Dark Arts. I guess we're on your time schedule now, so that's kind of great. But we normally, we're a computer hacker tinkerer meetup group that normally meets once every third Friday of the month. Normally we physically meet at this awesome place in Jersey City called Subculture because we are the New Jersey, um, currently the New Jersey DCG or DEF CON group, one of the many across the United States around the world. But we've been doing virtual stuff and hybrid of in-person and streaming during the pandemic. And if you want to know more details about us, even though we are currently doing some restructuring right now when it comes to websites, I can't even brain the military time or the UTC. So I'm just going to take your word and just think that it's like 2 p.m. where you are or something like that, Dark Arts. But I'm going to post the link to our website in the chat. You can also find us on so many different platforms. We are on Twitter at DEFCON201. And Jay, we're on DEFCON201 on Instagram, and I almost said Spotify just because that's been in the news. That's, again, I'm going to explain why I'm going to lean picture in a moment. GitHub and all sorts of things like that. If you want a master list of that as well as all the stuff we're streaming on, I just posted that in chat. And finally, as I said, we're streaming on a lot of different services, our main ones, and you can feel free to like, share, and subscribe on Twitch, DLive, and YouTube, especially on YouTube. If you do subscribe to us, it's completely for free. Click that bell and turn all notifications on because YouTube is the notoriously sucky platform. But we're also streaming to a couple of different services, including Facebook, which is kind of ironic because we're going to be looking at free and open source software, and I can't think of anything that's more opposite of that than Facebook. But we do stream to there, so our condolences. Yep, so it's normal time where you are in Australia. We're running on, normally FOSDEM takes place in Brussels. So we're running on, as I've come to call it, not only just a lean mixture, but we're running on torture level worse than Chaos Computer Congress time, as I've kind of gone to call it. But if you are on Facebook and you do want to chat with us, and by the way, I completely encourage chatting with us, especially to keep me awake. So if you're on chat, speak out. I will always read the chat, even if the camera is not on. I always respond to things. Otherwise, as always, keep lurking, keep learning. There is a way to talk to us, and I just post that link where you can talk to us on Facebook. So you're probably wondering why I look very dead right now. Well, first of all, the weather's been crazy in New Jersey, even more so than normal. We had freezing rain earlier. I know this because I went to my local 2600 meeting that's out in New York City, and it was brief because transit was down. So I think it was the only like one of the few regulars that actually showed up. It was a decent amount of people. It was like I want to say like 10, 12 people, which is really small for a NYC 2600 meeting, but that's my phone. But considering all the weather conditions and the fact that we're still in the pandemic, that's kind of something. And if I had known certain other factors, because I went home early, I would have gotten a lot more sleep. The next stream on Sunday, I'm going to be a lot more awake, so don't worry about that one. But basically, it is 4:33 a.m. in the morning, so you're probably wondering, why are we up this early or why are we up this late? For me, it's early. This is the transition part to me between hacking up late at night and early in the morning, especially with the lack of sleep that I got. Because also I had work Friday. This is like the crazy stream. But what we're going to do, and I'm going to switch over to the screen cam here, is we are taking, well, first of all, that's our awesome website that I posted a link in earlier. but we are checking out a major convention that's called FOSDEM. I forget what it stands for, actually. Let's click the About page. I could read it a bit. But basically, FOSDEM is imagine the Libre Planet that Free Software Foundation does, but way better, and way more organized, and not doing other stupid crap and everything actually interfacing with browsers properly and everything. It normally takes place physically in Belgium. Uh, did my chat just go crazy here, or is that just the stream? No, that's just the stream. Um, because I have it on the TV as well. Normally takes place in Brussels and Belgium, but for the past, because of the pandemic, 2 CODs, it's also just been live streamed and just everything done online. And it is a venue for people who work in free and open source software to kind of show off. I just realized I have to do some adjustments here. To kind of talk about FOSS or free and open source software, services, applications, coding and development, what sort of projects people are working on, what sort of issues and complaints people have, and just also overall discussion about these sort of topics. Think of very GitLab, GitHub, GitPia, lots of Gits, let's put it that way. Pushing code upstream, that sort of stuff. Really nitty-gritty stuff, as well as a lot of community things. Let's see, it originally stood for Open Source Developers European Meeting. Got changed to FOSDEM, which they still haven't explained what the acronym means. But I'm so dead tired. I have like a giant Danish I'm going to be eating over the course of the day, as well as the hacker staple drink. Uh, Monster Energy. This is actually, in my opinion, the best version of Monster. It's the only drinkable one. It is the Monster Energy Zero Ultra, Zero Sugar. Let's see, I'm trying to find, because it doesn't have a flavor. I just know it as the white can. It's the white can that's Zero Ultra, Zero Sugar. Um, and it's the best ones. I have 2 of these, one for each day, night, day. So we're going to be doing all that. And we have a pretty packed schedule here now. Of course, because it's not a DCG 201 meeting until it's late. We might have already missed the current talk, which I already saw pieces of, which is about SGX enclave exploit analysis and considerations for defensive SGX programming. I have no idea if that is still going on. But before we get into what I think is, we're going to check in on that. If not, we're going to immediately go to our second topic, because there's one. Basically, we're going to be seeing something every half hour. And this is the cross-platform, cross-hypervisor, Vito, vstock use in Go. Because, nothing starts off in the morning for me than Go lang. It's not the worst. We could be looking at stuff in Rust, which we will be later, but, you know, yay for languages that I'm unfamiliar with and annoy the crap out of me when it comes to certain things like cryptocurrencies. I like Mother better than Monster. I have no idea what Mother is. Unfortunately, as an American, when I think of Mother, the only 2 things I think of is Mother Brain from Metroid, as well as the memes about Mike Pence. And it doesn't help that he's been recently in the news, our former vice president. Not sure much how of an improvement he is over the current vice presidents, but American politics, it's either at best it's broken, at worst it turns into Germany from the 40s. And before we continue on, I do want to point out something really big. Um, I am literally torturing myself. I'm gonna be streaming my time to 4 a.m. in the morning to around 12 noon. That's ridiculous. I'm literally I thought Chaos Computer Congress was nuts, where their stuff starts at 6 a.m. and ends around 4 p.m. This is unbearable, okay? You can probably hear it in my voice. You can see it in my face. And the reason why I'm doing all of this is, normally I would just check off FOSDEM whenever I'm awake, but I'm doing it this year because we're trying to raise money for a good charity cause. And this will actually be the final 2 days that we're going to be raising funds before we send all the current stuff in, which we've currently raised. We're trying to get to $600. I don't know if we'll make that, but someone might be able to prove me wrong. We currently have $308.50 towards the Children's Miracle Network Hospitals. They're an amazing organization. I bring up the Wikipedia page because it's here on their website. Where any money that gets donated towards them basically goes to various children's hospitals and pediatric centers across the United States and Canada to help out sick kids. Um, and I'll put it this way, as an American, I can tell you right now, things were already awful enough, pre-COVID. In America, we're like a third. We're basically the way we used to make fun of third world countries in the 90s. Well, I didn't, but the country did. We are what Trump once called a shithole country. We have no health insurance. I literally just got my health insurance reinstated. And what's nuts is recently I went for something where um, it covered, I went to actually a high-end hospital just to test it out. My insurance covered everything. They sent the medication to the Walgreens that's a couple of blocks away. Didn't accept it. My insurance, which is like a wide level, like government level insurance. Like the only thing above this insurance is veterans insurance. Apparently, in the past 3 years, which means starting the pandemic, dropped Walgreens, and the rumor is because they dropped it because of how Walgreens dropped the ball with the COVID-19 response. So you know how bad you have to be to drop my insurance? Is ridiculous. So I'm one of the very few. I'm literally the caviar and steak 1% of Americans that actually has insurance. It's even worse during the pandemic. Again, I just got mine completely reinstated, and so most of these pediatric and children's centers are understaffed, funded, um, undersupplied, and under the thumb of a lot of bureaucracy that gets in the way of helping sick children. So we thought, hey, if we donate money, we can help these kids start a better year than we all have, especially me, because January was crazy. There's 3 different ways you can donate, and I'm going to be reminding throughout the stream during these reactions. And I also want to do a heads up. Sometimes, especially during the beginning of this, particularly today, the camera might turn on and off. That's fine. I'm still watching. I'm still reading the chat. I'm listening to the talk. I might be running around doing stuff, particularly a little bit later when stores open up and I can get proper breakfast. So, just warning, if you don't see the camera in my mug, don't worry, everything's completely normal. But there's different ways you can donate for this cause. Again, this is going to be the last 2 days we're going to be pushing this. If you are on Twitch, you can scroll down. There's a little widget where you can donate. You can donate anything. I would love if someone donated like $300 right now and ended this charity. We would still do the stream, but I would basically worship that person and send them like samples of my DNA through the mail, things like that. But even if you have $1 or $3 or $5, because I know how broke we are during this pandemic, all of that is how we got to the $308.50 in the first place, including our current top sender, which has been the entire time for a month and a half, Feel One Dead, who has donated 69 nice dollars and has been haunting the leaderboards since then. But there's 3 different ways you could donate. You could either use we're all using Tiltify, so we don't touch any of the money. And even if we don't make the $600 by tomorrow at 1 p.m., all the money still goes to sick kids. The whole money goes in, whatever was donated and whatever you donate. So don't worry about missing stuff. But anyhow, you can either use the widget that is through Tiltify in Twitch. I finally fixed the QR code after a while, so you can scan the QR code with your phone, and which I'll be doing all stream, all chat. I will be constantly putting the direct link to donate to the charity drive. So there it is. And now we're going to get on with actually watching FOSDEM. So again, unfortunately, and I'm going to check in, I think we unfortunately just missed the SGD enclave exploit analysis, which sucks because I heard really good things. I might be a couple of minutes or an hour off, so let me just double check here. You know what? I think it's still going on. So I guess we'll watch this for a bit. All I know is after this one, we're then going to look at the cross-platform, the cross-hypervisor vSock using Go. So when this is done, we're going to go jump over. I'm trying to see what I'll look it up. But we're going to be like hopping around a lot, like almost every half hour. So this is going to be interesting. The camera's going to be on during this first part, like for the first half hour or so. Camera might blink off after that again. I'm like Big Brother. I'm Big Fro Brother. I'm watching you. So I'm still on the camera. But let's jump in and let's oh, it's still going on. Let's look at SGX, where's the link? SGX enclave exploit analysis and considerations for defense SGX programming as I drink a monster and try to keep my eyes open. So here we go.
Attestation flows. On the other hand, this interface requires modifications to the application. So there is a mid-level interface that provides the array.tls library shipped together with Grameen. This library provides an abstraction of a secure TLS channel, but with specially crafted X509 certificates that embed the SGX code. Array.tls uses raw dev attestation pseudo-files under the hood. And finally, there is the high-level interface, the secret provisioning library that is also shipped together with Grameen. This library can be preloaded to move the secrets such as private keys and passwords into the SGX enclave without any modifications to the application itself. Secret provisioning library uses array.tls under the hood. To gain more understanding into this topic and the provided interfaces, we recommend to read Grameen documentation on attestation and also look at our examples that can be found in the Grameen GitHub repositories. We have two examples that show how the mid-level and the high-level interfaces can be used by applications. We also have an example with Azure Kubernetes Service deployment. Additionally, we are happy to mention the Ageless Marble Run project that seamlessly integrates with Grameen to provide a secure service mesh. Ageless Marble Run provides remote attestation and secret provisioning services not to just one SGX application, but to a set of SGX applications, constituting a service mesh. Until now, we discussed how to enable standalone applications in Grameen. This process requires writing a manifest file. To write a manifest file, the application developer must know the exact requirements and dependencies of the app. In other words, the application developer must manually describe the packaging of your application in the manifest file. However, there are already application packaging solutions that solve this problem. One of them is Docker. Therefore, we provide a tool called Grameen Shielded Containers, or GSC for short. GSC takes a base Docker image with the application to protect and a tiny abridged manifest that contains only the SGX-specific manifest options that cannot be deduced from the base Docker image. GSC creates a Gramineized Docker image from the base Docker image in two steps. The first step is GSC build, which combines the original Docker image and the Grameen-containing Docker image into one, scans the entire image, and adds all detected files to the user-supplied abridged manifest, generating the final manifest. The second step is GSC sign, which simply signs the Gramineized Docker image with a user private key. This is done as a separate step to have more flexibility. Typically, signing happens on a separate system than building. After that, the Gramineized Docker image can be distributed to SGX-enabled platforms and the Gramineized Docker container can be run. Note that with GSC, the application runs inside Grameen inside Docker, not that Docker engine runs inside Grameen. Therefore, GSC provides an easy option to run already existing Docker images in Grameen SGX enclaves. Here's an example of how GSC can be used to transform an application Docker image to a Gramineized Docker image. As an example, we will use a public Docker image of Python available on Docker GitHub. To build the unsigned GSC image from the base Python image, we run the GSC build command. It takes two inputs, the base image called Python and the abridged manifest, which contains only two lines, the SGX enclave size and the number of SGX enclave threads. Out of these two inputs, GSC produces a new, but not yet final Docker image that contains Grameen files and the original Python files. In the next step, to finalize this Docker image, we run the GSC sign image command. It takes two inputs, the intermediate Docker image of Python and the private key with which to sign the SGX enclave. Now GSC produces a final Docker image called GSC Python, note the GSC prefix. The work of GSC is done, we have a Gramineized Docker image. Now it can be run as normal via the docker run command. The Gramineized Docker container runs Python in the SGX enclave, and that's it. Some other important features of Grameen include exitless or asynchronous sockles, fully featured multiprocess support with encrypted inter-process communication, support of both glibc and MASL standard C libraries, and some other features. We would also like to highlight performance of Grameen. We tested Grameen on many real-world workloads and we benchmarked Grameen extensively. We cannot yet share the detailed information, but we typically observe performance overhead of less than 20%, with some workloads exhibiting the overhead as low as 2%. Grameen is currently used in several projects. Unfortunately, many of them are under development and they have no public releases yet. The only project we can mention is the OpenVINO Security add-on plugin for trusted machine learning training. There are also projects on trusted federated learning, trusted analytics, secure virtual network functions, and databases that utilize Grameen. We also have a web page of users of Grameen that contains a list of startups and companies building their use cases with Grameen. If you use Grameen in any of your projects, we encourage you to write to us and you'll be added to this list. There is a lot of ongoing work on Grameen. We continue to add support to Grameen to enable new runtimes and new workloads, as well as make them more stable. Actually, a lot of current work in Grameen is centered around rewriting and refactoring old subsystems that contain bugs. We also explore possibilities of integration of Grameen with confidential container solutions. One prominent example is Kata containers. As for plans that stretch far in the future, end of this year and beyond, we plan to support more TE backends. One particular TE we plan to support is Intel TDX to run small Graminized applications in trusted domains. We also hope to add support for communication with hardware accelerators, such as GPUs. And we also want to add a form of coarse-grained partitioning of applications to enable use cases like DPDK, where the core of the control plane is executed inside the enclave and the data plane is executed in untrusted world. If you want to learn more information about Grameen, please visit our Grameen project official website and our GitHub repository. Thank you for attention.
Yeah, I was hearing pieces of this earlier. Really good in-depth stuff. Like one of the things I like about FOSDEM is that they explain it to you like there's some talks that are just community stuff, some talks that they explain to you like they're nine, and then there's stuff where all they speak is in pure bytecode. So now we're in the Q&A.
Currently support 167 system calls. Sometimes we add a couple more, but quite rarely these days. The paper talked about those 224 syscalls for all kinds of applications, including applications that, for example, do some administrative work or do some kind of like file system partitioning. And these types of administrative tasks are not supposed to be run inside SGX enclaves. And so Grameen does not support these applications, and thus Grameen doesn't implement this subset of system calls that are used more for direct communication with hardware or working with like doing something like a ptrace on another application. So we don't need to support these system calls. And another important thing is that it turns out that many system calls may be simply disabled, unsupported, and then most applications, because they support legacy systems, like they can run on something as old as Linux 2.6. These applications will simply fall back when they fall back to another syscall implementation when they see that some syscall is not implemented. So it seems that 167 is like more than enough to run applications that are typically need to be run inside SGX enclaves.
What is the most complicated in terms of syscalls application you run on top of your system?
In terms of syscalls?
Yes.
Oh, good question. I guess Python and Microsoft.NET is the most interesting one, I guess. Yes, we can now run the .NET framework, at least some workloads on it. And .NET actually required, we needed to implement file system locking, like flock, and we needed to implement like memory pages locking, stuff like this, because this was required by the .NET framework. So this was pretty, yeah, I guess this framework is the one that requires the most system call implementations. It doesn't have any like fallbacks.
Okay, thank you very much. Very interesting. There's another question is from Yo. It's a quite long question. So paraphrasing, he asks, you're using your custom ABI interface between SGX enclaves and your host system, which is probably can be prone for errors or can be buggy, or you might not be very skilled in writing your own interfaces. So do you consider using existing, probably cleaner, safer frameworks and systems like SGX SDK or Open Enclave SDK?
At this point, no. So the short answer is no, we don't consider using some low-level primitives from SGX SDK or Open Enclave. We thought about this about 2-3 years ago, and I guess a simple answer is that we didn't want to like take this upon us, and we were pretty confident in our low-level assembly code. And like with time, we just don't see that much other than that part, other than the like low-level assembly code to enter and exit the enclave. We don't see what else.
And he just blinked out of existence. Okay. I guess that can also happen. I guess. Okay. Let me move the logo here. Since now I know they put FOSDEM up there, so I'm actually going to probably put it in the lower right corner in the meantime. But, yeah, I'm going to give it a couple of seconds, and I think if it's not a glitch, that was, the end of that. I have no idea what happened. Like, for real, I have not, like, that was just, dude, there was just like, your question, and just blinked out. Anyhow, actually, one of the things I should check, let me actually go into face mode real quick. Let me just check here. I just want to check to make sure that a setting that I have on Twitch, because I always keep forgetting to check to see if the mature content filter is on or off. Have you tried turning your Twitch on and off again? Let's see. It's right there. Here we go. Hopefully this won't like chug the system too hard or something. Because I just need to get to settings. 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 She love modern computing. Stream. Okay, we are good. So we're not going to actually watch this talk. We're going to go into something completely different. Our next thing here is actually, what the hell are they talking about? WebAssembly. Yeah, I don't want to look at WebAssembly. Between Go and WebAssembly, I'd rather check this out. So let's go and look at the schedule here. Get rid of that for now. Oop. Let's see. There we go. There we go. That's it. All right. Now, this might just be a video stream, so we're gonna find out in a bit. Just go to home. So this one, just to quickly read, it should be on now, is code-ready containers run an OpenShift cluster on a laptop or a workstation using, let me actually flip it back over because I'm a genius. There we go. Code-ready containers run an OpenShift cluster on a laptop workstation using virtualization. I love how we're starting off the day with all the terms that I love. Kubernetes, Docker, WebAssembly, virtualization. Fun! At 4:58 in the morning. Is written in Go and uses KVM, Hyper-V, or HyperKit depending on the operating system it's running on. External network access is done through gvisors, userland TCP/IP stack, which virtual machine uses over Vitro vStock. This talk will be a short presentation of what code-ready containers is, why it's needed as a userland TCP/IP stack, but its main focus will be around Vitro vStock, how to use it from Go, and differences to expect on different hypervisors. So if the talk hasn't ended yet, we're going to take a peek in here. If not, then our next talk is going to be the math behind ImuDB, and then there's going to be a really awesome talk that I actually can't wait for, which is about how Steve Wozniak, the good Steve, designed the operating system of the Apple I and sort of the whole digital forensics and archiving around that. So let's go check out this Virtuo. I keep saying Vito like it's Ghostbusters 2. I am Vito, but let's go check out Virtuo vStock in Go. Good old video feed. Provided if it's even running. Is it running? Hello? Hello? Let's do the video with chat just to see if it's working. Because again, we also might just be like off slightly. Or their players might not be running properly and things like that. Okay, so I think let's see. Yeah, I think the talk just ended. Because I know it was a shorty. Yeah, it just ended. Okay, so unfortunately, so I guess fortunately for me, we're not going to see this stuff in Go. Yay, I guess, because Go drives me crazy. So what we're going to do instead is we're going to go to the next thing on our list, and the next thing on our list is ImuDB. I'm sure that DB stands for database because I don't want to think about, because there's DB and DP. And I am so tired at this point that I am way too afraid to find out to mix up those two terms because I'm not going to explain what DP is. You should probably know. And if you're mature like me, you can probably snicker and laugh at it. But what we're going to do, and actually, let me double check something here when it comes to the schedule. All right, so we're going to kind of cut out in the middle of that. Yeah, we're going to cut out in the middle to check out the Steve Woz talk. But this is called Don't Trust Us, Trust the Math Behind IMMUDB, and how IMMUDB, or IMUDB, I guess, protects safety critical data with math and cryptography. Immunity is a powerful concept. Without it, we would just let me actually zoom in a bit more for you guys. We wouldn't be able to rely on bank transactions, medical records, or even some of our private data. That is a creepy blue woodchuck right there. I'm assuming that's a woodchuck. Either way, it's eating into my soul. And we usually take for granted that our data is safe somewhere out there in the cloud. And remember, the cloud is just someone else's computer. But what is it? There's a well-known multi-billion-dollar stories where attackers were able to break into well-secured systems and modify data stored in databases. What if there was a way to protect the immutability with math? What if, in a world, if any attempt of historical data manipulation could easily be detected? In this talk, they're going to show us how to do it in ImuDB, a new database built on a zero trust model. We talked about zero trust stuff on Crypto Barons before. That actually exists when it's not being used for snake oil. So let's go and check out what the math hubbub is about here. And remember, we're going to cut out in the middle of it at 5:30ish a.m. to go see the Woz talk. So just be aware, we're probably not going to get through the whole thing, but here we go.
And direct S3 storage support, and a few more. And all products currently running in Code Notory are based on ImuDB. So let me right now have a deep dive into internals of ImmuDB, and I will try to show you how we can use mathematics to prove that some data was not tampered with. So in order to understand much higher concept, let's start with something simple. Let's imagine there is a system which just one value. Here we have an example of a hello world. So what we can do with this value is we can apply some kind of cryptographic hash function like SHA-256 here, and then we get this hash value somewhere. And let's say that this hash value is the state of the system, something that we can very easily watch, observe. And this whole system would have this property that if the value changes, we can very easily spot that the value was changed by just observing the state. And because this is hash function, cryptographic hash function, this state actually does not reveal anything about the value. So the value is safe, but also it cannot be faked. So the database cannot say that my state is some different value. Why? Because then we ask for the value itself and we see that the value does not match the hash. So the database cannot easily fool the user, claiming that it contains a value different than what the state exposes. And of course, this is a very, very simple, very simplified view. And in standard database systems, we don't work on one value only because we have multiple values. So let's add some more to the picture. Like here, we have two strings, hello world and hello FOSDEM. For each of them, we calculate the state separately. So we have the hash of the hello world string and hash of the hello FOSDEM string. So right now we have two values that we should observe. So we can still observe two values, but if the database grows and has millions of values, observing millions of hashes will be, of course, impractical. It won't scale. So instead of watching separate hashes, what we can do is we can concatenate those hashes and hash them once again to have one cumulative hash. And we can add more values to the picture. Like right now it's February 2022. So let's also add those values into the system, hash them, concatenate those hashes, hash them again, and then we have those parent hashes of both, let's say, parts of the system, halves of the system. And we can apply this rehashing recursively. So we take left hash, right hash, concatenate them into one value, rehash them, and we come up with just a single value, which is a global state of the database. And you can already see that this looks similar, and this is a well-known structure called Merkle tree, known for many, many years already. Just one warning, you have to watch for something called second preimage attack if you work with Merkle trees, because that may reduce the security of the system. And what properties does this Merkle tree give us? So each value contributes to the hash in equal manner. So any change in any of the value would just completely change the hash, because it will start, if let's say change the hello world, it will change the intermediate hash, then the parent up to the root. So there's no way to change the value without changing the root hash. So if we observe the state, we can very easily say if something has changed inside the database. Also, it's important to note that the value order is important. If we, let's say, swap hello world with hello FOSDEM, many parts of the tree will be the same, but at some level.
Yeah, no, we're running on normally FOSDEM takes place in Brussels. So we are running on their time schedule, which is even worse than the Chaos Computer Congress. So we're running on Belgium time, meaning their conference, which is normally 9 a.m. to 6 p.m., is 3 a.m. to 12 noon our time. So that's what we're running on. So yes, it is very early, which is why I have this energy drink here. So the camera might turn on and off occasionally because I'm going to be running around, but yeah. So let's go back to how we're using cryptographic hashes and the tree system for it.
Producing the same state, that means that you have basically broken the hash function. You found the collision. And we assume that finding collisions in very good cryptographic functions is not practically possible. There's one extra property, because if the database ever claims that the state is of given value, and if we know that some value like this February contributed to the state, it can never deny existence of this value. So the database cannot say that, no, this value was not here. So it's a proof that the value is here, and this proof can be done for each of the values. And let's take a look at an example of such proof. So how database can mathematically prove us that the value is inside its state. So database claim is year 2022 because that's the last value in its state. Yeah, but we say we don't trust you. Prove it to us. So the database gives us some kind of weird formula, some calculations, and calculates the root hash. And yeah, the question is, where are those different hashes from? So they are built based on the Merkle tree itself. So we want to prove that given value 2022 contributed to the root hash. So what we can do is we can start with the value and try to reach the root from that value. If by applying multiple hashes, multiple recursive hashes can get to the root, that's a proof. Database then cannot deny that this value was not inside the state. We then basically prove that the value is inside the state of the database. So let's try to do this. We start with 2022, we hash this value, we have the hash, and now we want to move one step upwards. So in order to calculate the hash, we also need to have the left sibling. So the database actually have to provide us explicit value for this left sibling hash. So we get this from database, we get the right one from the previous hash calculation, we concatenate those values, hash them again, and we come up with the next level. And we recursively repeat this process. So the database has to give us this left sibling hash. We concatenate those hashes, hash them again, and we come up with the root. So the proof, what actually is the proof? The proof is the set of these hashes, this green one and this red one, which let us come up from the value up till the root of the tree. Okay, so this proves that the value contributed to the root hash, and also this proves that the value was at a specific location in the Merkle tree, because if it was in different tree, we would have to swap the calculation of the hashes so we can check if this formula is actually correct to also validate the position. So we trust the database, and we know that the current state is 104 or something. And we say, yeah, we trust it, but only this time. Why? Why is it important that only this time? Because, of course, our databases are changing, the values are changing, and the root hash will just change over time. It will not stay the same. Once we do even smallest update to the database values, it will be just completely different. So let's try to think about how we can make this Merkle tree something that can be dynamic. And there is a very interesting structure called appendable hash tree, which is a specific subtree where there's only one operation available, which is appending new values at the end. So we come up with first version of the tree. We have three values A, B, and C. For simplicity, those will already be hashes of those values. And we know that when we calculate the root hash, we come up with value RH1. And we can do append operation and come up with a little bit different Merkle tree that is built on top of values A, B, C, and D. And this ends up with root hash 2. Right? Important thing to notice here is if you take a closer look, you can figure out that majority of the tree is shared between those two Merkle trees. So the H1 and everything below is exactly the same in both trees. And of course, if this tree will be huge, we will have very big part of the tree shared between those two states. Okay, so let's see how the database can prove that those two trees are consistent. So database claims that the current state is RH2 after the change. And let's say that, yeah, but we know that the state just before was RH1, this root hash 1. So database, please prove to me that RH2, that the Merkle tree, the newest one, is consistent with the old one. And what does it mean that it is consistent? It means that all the values I've seen before, I could see before in this root hash 1 Merkle tree, are still in root hash 2. Yeah, and database, yeah, just says to us, yeah, here's the proof. Okay, so this is not as simple as with the proof for the value. So let's get a little bit deeper dive into this. So this is what the database gave us. So let's think for a second, what's the most primitive way of proving that those three are consistent? So what we could do is we could ask the database, please give me all the values you had since the beginning up till the current state. And the database gave us A, B, C, and D. We know that the previous state was made when there were only 3 values. So we take the first 3 values and build those, the root hash only from those 3 values. And it's exactly this first calculation. RH1 is, so we calculate left subtree, left subhash, calculate it with C, and calculate the cumulative hash. And also we do the same for this root hash 2. So the new root hash that the database claims is the current state. We take those values, build the hashes recursively, and finally we get to the root hash 2, right? And what you can observe here is that there are certain parts of those calculations that are equal. And this is exactly what we've seen before, that the parts of the tree are equal in both states. So instead of asking the database to give us all the leaf values, we can say, yeah, database, give me only the C and only this H1, because this H1 proves me that A and B are inside the database. So we can just basically extract those common subtree hashes into a specific values. And when we do this replacement, we end up exactly with what the database gave us. So both for the root hash 1 and the root hash 2. So what the database gave us, it gave us formulas to calculate both hashes for the old and the new tree and prove to us that the old state is what we knew and the new state contains all we had before. So it's like basically just calculating the root hash from scratch, but with some optimizations. Okay, so let's say that database has proven to us that the new state is consistent with the old one. So we remember the new state right now because we have proven the new state is valid, and we store it and say that we trust this new state. But next time we do any operation with the database, we will check again. So the normal flow over time is like that. Each client must have some kind of, must remember the old state that it knew from the database. And when there's new operation, we say that we know that the state was valid on that transaction at that time. And the new state has to be proven that it is consistent with the old one. And each verified operation needs to then ask for the next proof. And on every such operation, we basically just prove that the new state is still consistent with the whole history. And there are maybe multiple clients which do this operation independently. And if there's any corruption in the database, then the database won't be able to prove that the state is consistent. Yeah, and this is exactly how ImmuDB looks like under the hood. Here I will show you a simplified view because this is only for a single database and ImmuDB can have multiple databases in one process. But it's more or less the same because databases are totally independent. So each database has its Merkle tree root to be able to prove, to perform the proofs. And of course, things are not that simple as with just a simple Merkle tree because it's a transactional database. So each transaction may add multiple entities into the database. So here we have n entries. Each one is key, metadata, and value. Key, of course, and value, we know what it is. Metadata is some kind of extra information that we use to mark things like deletion of a record. And we want to add a set of values into the database, and so we could just add them one by one into the main Merkle tree. But this causes some issues when we talk about transactional databases, because it's very hard to implement something that will be ASIC compliant, that you either commit all or none. So what we do instead is, for each transaction, we build a small static sub-Merkle tree, which has exactly the same properties. So it can prove existence of each entry inside the tree. And out of that tree, we have the root hash, and this root hash is only the input for the main Merkle tree. So now if we ask for the proof from ImmuDB, more or less what ImmuDB is doing is just takes the key, this low-level entry. For this low-level entry, builds a proof inside this subtree. From this proof, we know that it contributed to the subtree having given root hash. And for this root hash of the subtree, creates a second proof that it is consistent with the main Merkle tree. So we can, from the value, go through the subtree and up to the root of the main Merkle tree. This is all not everything inside the database, because if we have key value, we may want to have a quick lookup for keys. So give me value behind that key. And to do this efficiently, we also need some kind of index, and ImmuDB has built-in B-tree for that. And also the B-tree is not only tell us what the current value is, but it also can give us a history of given entry. Because we can easily add multiple entries with the same key as before. And this may be a little bit confusing for people, because we usually say that ImmuDB is an immutable database. And this immutability is applied onto the history. So once you add something into the history, it is always a part of the history of this database. You cannot wipe this history, you cannot erase it. And the main Merkle tree proofs are actually built on top of the whole history of those entries. And this part that I've shown you so far, it's something that we call embedded ImmuDB. And this is a Golang module. You can easily just take it, embed it into your own application, and have ImmuDB built into your own process. It's very simple. But also you can run ImmuDB as a standalone server. And this server provides two APIs. Like there's a key value API, and there's also an SQL API. And let's take a look at those APIs quickly. Okay, so first is the key value API. And this is pretty low level API and has very low overhead. And so because of that, it's very fast. It's very close to the low level disk operations, and it's very stable and battle tested. So because we used it at coordinatory projects, but also there are fintech and government and community projects that are currently using ImmuDB key value interface. It may be a little bit hard to work with, because key value interfaces, basically they don't have many robust functionalities. Like it's very hard to index data using multiple properties. Or if you want to ensure that there's data, the data is consistent, you have to do this validation by yourself. There's no foreign keys, and there's no schema. It just bytes, key and value are just raw bytes. So we have simple functionalities like get and set value. We have a scan operation that can scan over a range of values with given prefix, for example. We have also something called references to other keys, where you set a value that is referenced to something else. Could be also referenced to something else in given point in time in the history. That's a very interesting property. And then when you try to read it, you will get the referenced value instead of the value directly written. We also have sorted sets, which help creating indexes. Also for each key, you can create the history of a key. And also we have verified operations like verified get and verified set. And you can easily use this key value API by just using our dedicated SDKs for a few languages. We have them. Contrary to a key value API, we also have SQL API, which is pretty robust as an SQL standard. It has tables, it has indexes, typed columns, null values, so everything that you would expect from SQL. Also supports standard operations like insert, update, delete, select. We also have one weird operation which is called upsert, which is a mix of insert and update. And it was initially done for performance purposes, so you could either insert new record or update existing record, but all counts at once. And this SQL API is something that we still actively work on, so from time to time it may become unstable. And some features are still missing, like altering table foreign keys or adding index to data to the table that already contains some data. We are actively working on that, so things should change over the next months. But if you require those features, you maybe want to wait a little bit for them. So in order to use SQL API, you can use dedicated SDK and directly talk to ImmuDB, but you can also talk using Go standard SQL libraries. And also we've implemented PostgreSQL binary protocol compatibility, so you can easily talk to ImmuDB by connecting with already existing PostgreSQL connectors and just use our own dialect of SQL for that. Yep. We also have a full roadmap ahead of us of new features that should come in the next few months. So we think about physical deletion of the data, and it's a very interesting problem because we have to, if there's data that you actually want to wipe from the database to free this disk space, we have to guarantee that we can still prove the consistency of the history. And we also work a lot on SQL right now. That's, I would say, our major point of focus. So we work on alter tables, creating indexes for tables that already contain data. We also want to add more types to our ImmuDB, like float. We work also on exposing database schema in SQL so that you can, let's say, query what are the column names of given table. We also want to support common SQL and ORM libraries like GORM in Golang, and want to keep improving compatibility with PostgreSQL protocol. On the key value level, we want to improve transactions so that they are much easier to work with. And also we want to let people mix key value and SQL within one transaction. And of course, we constantly work on performance and scalability improvements. So the major goal actually is to make sure that ImmuDB could be used as a primary database. So if you create a website or a small application or also larger deployment, you should be able to consider ImmuDB as the primary database for your data. Okay, so now let's do a quick demo of how we can talk to ImmuDB server. So for that purpose, let's start an ImmuDB server in the background. ImmuDB is distributed as a single binary, so running it is trivial. Just execute this binary and that's it. We have ImmuDB running in the background, and now we can start coding. So here I have an example project. It will be written in Golang. So there's an SDK for Go, which I already downloaded. So first thing that I need to do is to create a client object for this SDK. And within this client object, I need to open a session to the database. And I need to also provide a context. That's something that Golang requires. Here I specify username. By default, it's ImmuDB. I also specify password, which is also by default ImmuDB. And also I have to specify the name of the database, which is by default DB. Yeah. Of course, we need to check if it errors out. I have a trivial method to check and panic basically if the error is not null. And also we want to be a good citizen, so once we're done with everything, let's just close existing session so that ImmuDB can just clean up everything. And once we've done, let's say that we want to say connected. Okay, very simple code, just few lines of code, and that's all you have to do to connect to ImmuDB. So let's see how it works.
Shockingly elegant and simple.
We successfully connected to ImmuDB database. So let's do a few operations, like let's set some value. The key would be FOSDEM, and value, let's say it is, of course, 2022. So what we do is take the client object and set the value.
After this, we're going to switch over to the WASM.
It's very simple. Of course, let's check if there was error. And if there was no error, let's just print line. What was the transaction ID? So talking to the database is very simple. The API is very trivial. Let's see how it works. So it added a value to the database, and the current transaction ID is 2. If you run it again, it will create new transaction with this value, and we see that it's just constantly increasing. So now let's try to read the value from the database. So instead of the get, we use the instead of set operation, we use get operation. And let's see what the database returned to us. Okay, so here's a simple example how you can read the value from the ImmuDB database. Let's save it and run it. Let's see what it gives us. Yeah, and it correctly said that the value was 2022, so exactly what we've specified. So we may also extend this get into a verified operation, which is actually asking the database to give us not only the value, but also the proof. The simple get will be a little bit faster, of course. So if we don't need a proof that the value is correct, we can just use that one. But if we want to have the proof and want to be sure that the value is correct, we can just use the verified operation. So if I run this, everything is fine. It looks like exactly the previous example, but we want different, one difference. So if we take a look at local files, you can see that there's some kind of state file that we did not create that appeared here. And that's exactly how by default the Golang SDK is persisting the state of the database over time. So it stores this onto local folder with into those files, and on next operation, next verified operation, it will just read this file and ensure that the database can prove that this new state is consistent with the old value. Okay, I will finish my demo here. And now let's move back to slides. So let's think about where actually ImmuDB could be used. So it's very good as a content-specific database. Like if you want to store some documents or maybe users or some configuration of a system, that's a very good fit because ImmuDB would protect this data information. So every data that you have to protect, basically, that you have to make sure that nobody is messing around. Also, if you want to have a history of changes into the database, that's where ImmuDB shines, and you can query the history of given key. And also, if you need to have some kind of audit trails, some kind of reliable ledgers, maybe logs of important actions in your system, that's where you can use ImmuDB because it will store this in a secure manner. But there are also use cases where ImmuDB is not a good fit actually. So things like counters, things like change frequently, it won't be a good use because on every such change, ImmuDB will create a new entry So the database will grow over time and it won't be able to reclaim the space. Also, if you have some kind of temporary data, you should not use InBDB, because right now there's no way to get rid of that data once it's removed. Of course, we are working on that. And also right now, because it's not yet implemented, we cannot change SQL schemas. So if you want to have migrations in the future, you may wait a little bit. But we hope to change this really, really soon.
So that is the immune DB. And we're going to go out of this, and we're going to go into the in progress talk, talking about the Apple One and how Steve Wozniak designed the operating system. I'm going to turn the camera off for this, and because I have a couple of things to do. So the camera's going to be off, so it's going to be Woz, and then we're going to do back to direct FB. The camera will be back on when we get to our favorite topic of all time, which is Log4j. So we will, that's when the camera goes back on, which will be at 7:30. But the stream will still go on. It's going to be Woz, and then at let's see. Oh, I'm sorry. Sorry, the next one. So actually, sorry, Woz, then designing a new language for safety. I'll have the camera back on. Probably turn the camera off again until Java. So camera will be off until 6, and then it'll be off again at 6:30, back on at 7:30, and then I think I'll have it on the rest of the time. Okay, let's go check out how Woz designed the OG Apple One here. See you in a bit.
To be executed and some data also, and
Please
sure
donate
it
to
needs to be
Children's Miracle
stored in
Network
memory,
Hospitals.
and we've done it on the previously we've done it by typing this using keyboard, and then we have it in our memory. We've checked it with the examine mode. We see that all bytes are on their places, and then we start to run. What is exactly done when you run? You need just, and what do you need? What argument, what parameter you need to run a program? Well, basically it is just address of memory where the first instruction of this program is located. And so, yeah, you type this, for instance, if you want to run this VOSFace program from our RAM, from SmartKit RAM, you can just type F000, add R letter, which means run, and hit enter, and that's it. You just gave this command to VOSOS, and in this case, what it does, it just jumps to the address you've typed in. So it converts this address to, it saves it in memory, and then it just jumps there for the first instruction at this address, and that's it. In operating system of OS, you can't really quit this program if it doesn't have any option. It can if it would ask you something. You would input something like "I want to quit," or it asks you yes or no, and in this case, it could jump itself to the first line of code of VOS, so at FF00. But by default, if program do just summon like this test program just prints all the ASCII letters, ASCII symbols, it doesn't have any exit. So the only way to stop it is just to press reset when you just send this signal to CPU, and it starts again from the, it reads this reset address, and then it goes there. It starts this WOS operating system once again from the very beginning. So running, it's a kind of a, in WOS OS is a kind of a hard running. Yeah, you cannot really GUID. Yeah, but anyway, it restarts very fast. It's not like Windows right now when you need to wait for a few minutes when it loads and then download some updates. It just like would take you like less than a second. So that's why I think it was not a problem that time to reset if you want to stop some program. And what functions are really hardware specific for WozOS? Well, basically there are like 3 of them. The first one is initiation. So in the very beginning, it needs to work with this input-output chip, and it's to set it up. And then you have 2 main things left. It is working with the display. That is, in this case, it's just terminal. So it just gets char by char, and then just like scrolls down by itself. And here, yeah, you need a function that really sends something that is really chip specific. And in WozOS, this function called echo that prints a char stored in a register of CPU. And this is hardware specific, but then as a programmer, you just can load something to a register and just call echo, and you got it on display. You don't really care how it's done. The second hardware-specific function is the one that is working with the keyboard. The same is here. You first set it up on the first step on the setup, initial setup, hardware setup, and here what this code does on this getLine function is you wait for a specific flag to be set up when char key, char of the that is corresponds to a pressed key would be ready to be read by CPU. So CPU waits when it can read something, and this is very hardware specific. If keyboard would use some kind of different, like for example, if it would be a USB keyboard, not PS2 or something, then for sure it should be some this simple driver would be much more complex, and you would need much more code to work with this protocol, with this USB protocol, in order to just get this code and get it ready to be read by a CPU. So this get char function is really hardware specific. But anyway, then if you write some code, write some program for WozOS, you just can call this, and you don't really know how it's done, but then you got this char in the register, and you can use it in your own code. You don't really care about chips and protocols of the keyboard, and that is the main feature of operating systems. So they create their own layer for helping you not to care about what is on this silicon. So you just like work with this software layer. Yeah. So for like summary for the WozOS, there are 3 main things. Like you initiate everything, set up everything in the beginning after the reboot, and then you have hardware-specific echo function and hardware-specific get char from keyboard function. And then they're used in user programs written by programmers. Now we're going to check this Python code we have I have written to simplify the explanations, because 6502 assembler is kind of not so easy to understand, because it's a lot of instructions, but it's not so easy to see the whole picture. So I simplified everything. It's just very simple, but I wanted to create 2 classes in order to show that there is one distinct part that is related to UI user interface, and the second is hardware specific. So I've created 2 of them. And then basically the flow is very simple. In the beginning, you just have some hardware initiation. So you set up this hardware specific stuff, and then you enter infinite loop. In Python code, sometimes I use this limitation of loops because I just don't want to press Ctrl+C too often. I just want to stop it by itself. But anyway, just in real life, it enters infinite loop. When the first part is to get some user input, so it gets a line from you, then it parses this line, and depending on what it's found, it runs some command, either checking some memory cells, either writing to them, either running some program at an address it found in this line. And if it runs something, as I've said already, just like it never goes back in the program. There is no any jump back to the starting point of the operating system. But if it runs some examine or store program subroutine, I mean, it just gets back and starts over again the new iteration, waiting for you to input something else to parse. And so I would say final destination for this operating system is to finally run some program and stop, and then give control to this program and forget about everything. If it wouldn't ask this operating system again, wouldn't jump back. So yeah, you can check this code, you can download it, you can run it, and you can play with this. And for sure, you can see this assembler source, but it's much more complicated to understand what's going on. Yeah, so please check this Python code and run it on your own.
View of our Python code, a high-level view on what's going on with WOS operating system. So basically, I have created this class hardware interface that is related to everything this needs to be done with the hardware. It's not so much. So first of all, we need something. We execute commands like writing something to memory, and we have 2 functions, echo and getLine, get user input char and to print something. And it goes user interface, so it has like 3 modes. It saves user input. It saves like address to examine and store address. And basically it starts with the examine mode. And it creates user input. Here it's like some dummy, here some plug. And the main function is used is parse input. So it checks what user had, if it sees the dot. So it's entering some block mode, examining block. If it sees column, it just needs to store something. And if it sees R, so it needs to run something. Then after the declaration, we have 2 instances, hardware and UI, just very simple ones. And here's what is already executed. So we set up is very simple. It is just hardware init, very specific stuff, and then we enter the infinite loop. But in this case, I just wanted to start it just for 5 times. But anyway, I could change for a while for infinite loop. Read user input, action, hardware. That's it.
How WOS operating system communicates with the user? So for sure, user is like the king. He's the one who is like the reason why everything was done. So he needs to communicate somehow with the system, give some commands and get some results. And so WOS OS has very simple user interface that now we know kind of a shell in the Linux or Mac OS or in Windows. But this shell is it has not so many commands as we used to. There is no any ls or any kind of rm or something like this. Everything you can do is just all these three main things, which like examine memory cell, examine memory block, and store memory cell or memory blocks. And that's basically it. The other thing, you can just run some program, and then it covers everything you can do with this operating system. So yeah, it's just a shell. So you type something as a string, then it parses this string, and it just like prints out something back. So inside there is very simple algorithm that takes this string from you. It has some text buffer where it stores all these chars that were inputted, and then this algorithm just checks char by char what is inside. If it's some hex or number, it's okay. If it is some divider, it just skips it. If it is point, it knows that it needs to change mode to block 1, because it means like in the first it was some address, then you put point, and then you have the second address, and you need to examine if it finds column, then it means that it needs to enter store mode to save something in memory. And if it finds R letter, it means that it should run something. And yeah, when it just like it has some sort of a switch case structure, but written in assembler. So it checks it step by step, so it branches out depending on what it has found. And then it just do this simple work, saves in a variables these addresses, parses these chars to get hex numbers, 4-digit hex numbers for address, into chars for bytes, 4 linear bytes as data. And yeah, that's pretty much it. And it is very, very simple shell that you can type and you get the result with just very, very reduced set of commands. There is no and there is no any kind of a help command where you can see all the commands you can use. You just need to go to this operating manual. You can check it out in our Discord too, to see all these commands it has with the demos. Yeah, so basically it is very, very simple shell. No any GUI or something like this. Just the shell, but remember it was 1976. It was just the very, very beginning of personal computing. Well, it's all for now. A quick summary what we're discussing here. Well, every operating system is a kind of a program that do two main things. It needs to provide some interface for the user programs and to communicate with hardware, and the second is to manage these hardware resources, laying many programs to run simultaneously and do all this stuff with memory and so on. FOSS operating system is a very simple one. It doesn't have many features of the modern ones, like file system, like networking. Yet it shows main features that are very common to all the operating systems that we really know. Well, it has hardware-specific functions to communicate with the display and keyboard that give interface to user programs, and it has some user interface simple shell with commands to examine memory and to write to it. The main option to enter some programs to run them on this computer, on this Apple One, and it's very simple. It's just the main loop is very straightforward. It gets one line of user input and process it, and then checks like in switch case operator, just what needs to be done. And you can find all these materials not only as links to this video, but also in our Discord. Would love to answer your questions. And for sure is a great engineer, and he started this era of personal computing, mass personal computing, with this very simple and nice operating system of just 256 bytes. Just incredible. Was really great. So hope you just know much more about this, about the first computers and first personal computers, and you can use something from this at work too, because now you know more about algorithms that were used that time. Bye guys.
So that was the OG operating system. There's going to be questions next, and then we will switch over to the Fusion talk, and I will be back on at the camera will be back on at 7:20. So there we go.
And he is back again. At least I hear him. Hi, Sergey.
Hi. Do you hear me?
I hear, but we don't see your video picture now. Ah, there it is. Very good. So thanks for the great talk. You already answered some of the questions in the chat. I have collected some additional questions. Do you hear me?
Let me check. Thank you.
So Sergey, do you hear me?
Yeah.
Okay, very good. So one of the questions I have is, what can WASP can teach people today? What do you think is the benefit of looking into this?
Yeah. I hear you. Yeah.
Technical difficulties.
First of all, WASP operating system can teach you kind of the two main parts of every operating system. That there is something that is kind of a user interface and something that is related to hardware. And for every programmer,
In about 3 minutes, we'll switch over to the Fusion talk.
Because this is really crucial to understand, because we all write programs right now, and we basically work with this application layer. We just use some functions that were already done by the other programmers, and the system how it's translated to hardware.
Good old airplane quality Jitsi, ladies and gentlemen.
Okay, I have another question here.
Sure.
Do you think it's a useful exercise to port WasOS for modern architectures like ARM or RISC-V or even the Arduino?
Yeah, I think it's a good exercise.
I will also repeat one of the questions that we have seen in the chat for people who haven't seen the chat and looking for the recording. The code you showed, the assembly code, was that the original code that Steve Wozniak wrote back in the 70s?
Yeah, it was.
It's dead, Jim. But that's fine. We're going to go over to the next topic. And then again at 7:20, I will be back. And that is going to be, if I can exit out of here, I'm going to go over to here. Designing a new language for safety, Fusion, a minimal language for safety critical systems. Fusion is a modern general purpose programming language that unifies concepts found in structured, function, and object-oriented programming languages. The cursed 3 words, object-oriented programming. There's no objects, nothing's oriented, and barely programming. Combines powerful syntax and safety features based on the design by concept principle. It's simple, intermediate representation that enables powerful optimization, compilers, and stack awareness tools. So let's look at this programming language that's apparently designed for safety and thus security in mind.
For safety critical systems. Some of my background, you can read that from the slides. I have done a lot of stuff in the programming languages and compilers area. The motivation for Perfusion is we see that more and more languages are getting more and more overloaded with more concepts like classes, methods, interfaces, constructors, traits, records, structs, packages, values, and so on. And that makes it harder to work with those languages and harder to verify their correctness. So Fusion started from the idea to introduce a single concept to cover the features of most what these other languages features provide. And instead of having the developer choose what construct to use, it should be the compiler or static tools that have become more powerful that can make these decisions for the developer. And furthermore, more and more systems nowadays are safety critical, so we need to ensure the correctness of these systems. A short summary on the Fusion language. Fusion uses the concept of a Fusion feature as its main concept. It is statically typed. It is object-oriented. It has inheritance and redefinition. It uses value types by default, but it also has dynamic reference types. And it encourages immutability. And it tries to offload tasks and decisions from the developer towards automatic tools. Fusion is backed by a small company, Tokiwa, based in Karlsruhe, Germany, where currently we have a small team of 3 working on the language. We are hiring and of course also searching for funding. Let me give you a short introduction to safety critical systems. Here, just taken from Wikipedia, a safety critical system is a system whose failure or malfunction may result in death or serious injury to people, loss or severe damage to equipment or property, or environmental harm. And very often such safety critical systems, if software is involved, require certification towards standards like IEC 61508 or DO 178C and so on, depending on what domain they are used in. But there are many applications like a simple messenger that would not need any certification, but you can very easily imagine situations where the proper functioning of something as simple as a messenger app becomes safety critical, and someone's life might depend on the proper functioning. So we are more and more depending on safety critical systems, even though they are not all classified as safety critical systems that require certification. What certification usually means for the software is that we have a very defined software development process. In particular, we need traceability from system requirements that need to be broken down into smaller sets of requirements down to the level of code of individual functions, and we need a mapping from these requirements to the code that implements those requirements, and then we need to validate that the code is correct. So we need a traceability from the code to a validation procedure, which could be things like tests or static analysis or a code review and things like that. And we need to have a mapping from the validation to the results of that validation. So there's a very rigorous verification and validation process, and the use of static analysis tools could help to automate part of that process, and that also motivates the use of static analysis within the Fusion language. I'm not going to give you a full Fusion language tutorial. You can see that online, and that would not fit into that talk. But I give you a small example for Fusion. The main concept in Fusion is a feature, and a feature can be a routine that contains code. So here's a small Hello World example that defines a feature called Hello World, and that contains the code say, which is a call to another feature that prints the string that is given as an argument. We can nest features, so within our Hello World feature we can declare an inner feature called HW and put the code into that, and when doing that we would just declare an inner feature that wouldn't execute automatically. So if we run Hello World to actually print something, we have to call this Hello World or HW feature here, which is done here in the second. So the basic main two statements we have in Fusion is a feature declaration, which is this HW is, and a feature call, which is this HW down here as an example. Features may have arguments, so they can behave like Java methods, so we can pass a name to the HW feature and then use that name in the output and call it giving an argument. We can also have inner features within features. So in this case here, we put the code into a run feature that is nested in the HW feature, and then we can have values, instances of AW that we create by a call to HW, giving an argument, a string. So this would create an instance of HW without printing anything yet, but calling run on that instance would then actually call say and print Hello World. So main thing you see within Fusion code is really feature declarations and feature calls. Fusion uses design by contract. So let me give you a quick introduction. Features in Fusion use design by contract to define their behavior. So every feature can have a precondition, which is a Boolean expression that has to hold before a feature can safely be called. And in return, a feature guarantees a post condition that specifies also in a Boolean expression what guarantees are given after the call returned. The design by contract concept is pretty old. That was first presented by Bertrand Meyer back in 1986, who used that extensively in his Eiffel language. here's an example of how design by contract can be used in a square root function that has a precondition that the argument, which is a 32-bit integer, has to be non-negative, because it would be impossible for this function to produce a useful result for a negative argument. And once that precondition is guaranteed by the caller, the function can guarantee a postcondition, which in this case means that the result squared is the largest possible value that is less or equal the parameter given. So it's an approximation, integer approximation of the square root of a. And the largest means that the next bigger value would result in a bigger value if squared. So the question now is, what do we do with these contracts? If we would check them dynamically at runtime, that will of course introduce runtime overhead, and in some cases that runtime overhead may be prohibitively expensive and cause a big overhead, or but in other cases that runtime overhead may be required for safety, like for an access to an array. We really want to have preconditions that make sure that the index is within the legal bounds to ensure that arbitrary memory accesses are prohibited. So the solution for controlling the contracts is so-called qualified contracts, which Fusion brings, where we can selectively decide which pre- and post conditions in our running system should be checked on runtime and which not. So in our example, we can introduce a qualifier debug to always, whenever debugging is enabled, check the precondition, but the more expensive post condition would only be checked if the debug level is set to 5 or higher. So we can have this more expensive checks enabled only if we enable higher level of debugging. The default qualifiers that Fusion defines for that is safety, like for things like index checks, then debug in general and debug with different levels. There's a level called pedantic, and most interesting for us now, there's a level called analysis. Analysis is actually not for checks that are done at runtime, but checks that are done by static analysis tools. So we have another example here where a feature is declared that finds the maximum of a sequence of 32-bit integer values. And the precondition here is the sequence must not be empty, otherwise the maximum would not be defined. And now for debugging, we can use quantifiers that iterate over all the elements in the sequence to verify that the result is actually the maximum. That means that it is not smaller than any of the elements in the sequence, and that is actually part of the sequence, so it's not bigger than all of the elements. A different way to formalize that would be to use quantifiers over all 32-bit integers, and then say there must be some integer that is in the sequence and that is less or equal to the result. And for all integers that are in the sequence, they must be less or equal than the result, and there must be an integer that is in the sequence and that is equal to the result. But these kinds of expressions, quantifying over all integers, are something that you really don't want to check at runtime, but that could be useful for static analysis tools verifying this property. So contracts provide a direct way to add formal requirements, so the traceability to the requirements from the code directly to the code. And they provide a means to verify that these requirements are actually met, either at runtime or by defining or even automatically generating tests for these runtimes, or by using these pre and post conditions as input for formal analysis tools to statically verify that these contracts actually hold. So we need static analysis tools. So I want to give you an overview now over the toolchain of the Fusion language. Fusion toolchain starts off with Fusion source code files and a front end that processes these and creates Fusion modules out of the source code files. So the Fusion modules are a bit comparable to jar files in Java. These module files are then processed by a middle end that creates a Fusion application file. It's an intermediate representation for a whole application. And this application file, oops, I have to get out of the way now, is then processed by an optimizer and analyzer to create a Fusion intermediate representation that can then be processed by different backends to produce executable code like machine code or Java code or any other executable format. And I'll go back to my original position. Static analysis in the Fusion toolchain is actually done at several locations, but the current implementation, it is still mostly not implemented yet. So where it should be added is towards the front end, the middle end, and also the optimizer and analyzer. The static analysis is facilitated a lot by using a very simple intermediate representation in these intermediate format files. So as an example, the Fusion module files mostly consists of declarations for features, and they are grouped in 5 kinds in there. A feature could be a routine, which contains code. It could be a field, which is a feature that can also store a value. Or features could be intrinsic, abstract, or choice types, while a choice is the Fusion union type. And each feature declaration contains things like its name, possibly code, types like the result type, and possible inner feature declarations. And types within a Fusion module file are either feature types, so the name of a feature followed by possible type parameters, or just type parameters that are used directly. And the code is a very simple bytecode kind of code using a stack machine with only 10 different expressions or statements, and they are things like call, match, constant, assignment, pop, and so on. The intermediate code does not contain any loops or gotos. Loops are implemented using tail recursive calls, so they are converted into tail recursion. So basically, only branching mechanism we have in the intermediate code is a match. So this format makes it much easier for analysis tools to go through the code and perform the analysis. There is very simple control structures only that are involved, and a very limited number of statements. Now I have to get out of the way again. So the static analysis in the different parts that is planned is for the front end that already performs type checking, but it should also perform checks like check that fields are initialized before they're first used, and that instances are immutable when they escape their current context, which is a very important prerequisite for thread safety of the code. In particular, the single modules should be checked by the front end for their thread safety when used with other modules. Then the middle end that joins several Fusion modules into an application performs things like dead code removal, so it can analyze the libraries and what parts of the libraries are actually used and put only those into the final application. And it can perform code specialization, in particular if you have libraries with type parameters, that code can be specialized for the actual types that are given. And the middle end can detect data that is used only thread locally. And at the end of the toolchain, the optimizer analyzer static analysis is what runs on the whole application and can perform things like compile time evaluation, so constant propagation at a large scale, more code specialization also as a result of that, can make whole program call graph analysis, lifespan analysis in particular to allow stack allocation instead of heap allocation whenever it can be proven that any instance lives only locally, and it can perform a program-wide data flow analysis to verify, for example, safety properties, that certain data is not accessed by parts of the application that are not supposed to do that. So, coming towards the end, the next step, the Fusion project in total, is still pretty much at the beginning. The next things to be done is we have to finish the work on the intermediate files. The module files are already mostly existent, but currently used only for the Fusion base library, and they have to be more general. Then the intermediate files for applications and still need to be put in place. Simple analysis tools work has started on these to do things like field initialization and immutability, but they need to be implemented. The toolchain currently has a Java interpreter and a C backend, but the C backend is still missing garbage collection, floating point support, and also there's missing a proper interface to legacy C code to libraries. That also has to be added. We need to put a lot of effort into the Fusion standard library that is really minimal at the moment, and we have to find a way to model I/O and thread communication in the context of immutability. There are ideas using something like automatic monadic lifting for that. You find more on that on the Fusion website flang.dev under the design. So, in conclusion, I think Fusion is an exciting new language for safety because of its simplicity and the use of design by contract in a way that prepares the language for static analysis. We are still a very small team, so we need to grow our team, and we also would love to get developer feedback. And we also be a small company, so we need to secure long-term funding. Please have a look, get involved. You find the resources here. Flang.dev is a website that gives you a general introduction to the language, and it's the central part where information on the Fusion language is gathered. Here's my email address, and the project is fully available on GitHub. Thank you. I guess I will be available for questions now if you watch this live at FOSDEM. Goodbye.
Well, thank you very much for that interesting talk. Fusion certainly looks interesting. And it looks like the Q&A session is working now. We've had some technical difficulties this morning, but it looks like we're live now with the Q&A. So do we have any questions from the chat?
Hello?
Hello, can you hear?
Can't hear anything.
Can the audience hear our Q&A chat now?
Okay, I think I've stopped the echo. I'm sorry for that. Okay, thank you, Sean, for the message. Just type. I think I can answer by speaking.
Are you able to hear me now? No, I guess not.
So I just see the question from Thomas for the backends. And currently, the current Fusion implementation has a JVM and a C backend, but it should not be limited to that. And currently, the JVM backend is an interpreter. That means it doesn't create any jar files like in my slides, but it directly executes the code, while the C backend creates C source code that is then processed by Clang. But it should be open. There can be other backends. I would like to see a direct LLVM intermediate representation backend, and I would expect that probably you can profit more from optimizations if you avoid going through C code.
GCC is actually an alternative. You can use Clang or GCC interchangeably. I think I will best answer by typing. That might be better. So the question is how to prove that a new language is safe enough. It depends a lot on to what level you want to certify your system. So if you get for the highest criticality level, you have to actually verify that the machine code that is running in the end is correct, and so you have to go into really a lot of detail when verifying this. And one way that I expect would help is if you have a simple intermediate form, and this is what Fusion provides, and a backend that transfers this simple intermediate form into the executable code in the end, into the binary code. It would make it easier to verify at the level of this intermediate code, because then all you need is a certified compiler that transfers this into machine code. So, but it really strongly depends on the level of criticality and on what level you do your certification. Well, okay, so the question for the GCC front end, I have to admit I don't know the GCC code and how front ends would plug into there, but since the intermediate code is designed to be simple, I would expect that this would be a possibility as well.
Yeah, I can't stand the flickering either, so we're going to switch this over. Sorry about that. Up next, we're actually going to switch it up, and we are going to do, we're going to go over to infrastructure here. God, they are really having a problem with the Q&A system. I definitely blame Jitsi for that. Again, sorry about that, everybody. Especially for all of you out there who, you know, have, you know, issues with like seizures and stuff. I'm always a big person looking out for that. So again, my apologies to everybody. Next, we're going to just do a quick look at running trusted payloads with Nomad and Waypoint. Asking the question, but what about influences from bad actors in and outside different projects, and how you can add a Waypoint build pipelines to protect against supply chain attacks while running jobs in Nomad. And then we're going to turn the camera back on. We're going to look at Log4j, and then we're going to take another camera break, and then we're just going to keep chugging on. So here we go. I'll be back in 15 minutes. I also want to remind at this time again that we are trying to see if I can re-screen this. We are trying to raise money for the Children's Miracle Network hospitals. Again, sorry for having the camera off. I'm just having that type of day today. Children's Miracle Network Hospitals is an amazing program where charity program where all the money that's donated, including our $308.50 so far, will be donated to various children's hospitals and pediatric centers across the United States and Canada. You know, kids getting injured, treating mental illnesses, genetic diseases, domestic mental abuse. This was stuff that was difficult in the United States before the pandemic, and it's gotten even worse after the pandemic. So we thought that the best way to start off the new year, a lot better than how I'm currently starting off the year, is to help out sick children across the United States and Canada, especially because we're doing this under Child's Play. And one of the network series that is part of the Children's Miracle Network Hospitals is the, my brain just died, hang on, because it's stupid early in the morning. The Children's Specialized Hospital, which there are 14 of them in New Jersey. They're really high quality hospitals for children and the needs also of their parents, because it's not just about children, it's the stress and safety of the parents as well. There's multiple ways you can join. If you are on Twitch, there's a little widget. If you scroll down below through Tiltify, all the money is being handled through Tiltify. It's not being touched by us. And also, all the money that's currently donated, even if you donate $1 or $5 to the cause, we're not even asking for big money. Although it'd be fun to watch Fee One Dead's 69 nice dollars get knocked off the leaderboard. But any bit of money, even if by the end of Sunday we only still have the $308, that money goes to the charity through Tiltify for sick kids. So just any bit completely helps. But we have a Tiltify widget on Twitch if you're on there. If you are not, if you're just watching this on a TV, but you have your mobile phone, you could scan the QR code in the bottom left corner. And of course, like I've been doing all this time, I've been reposting the charity drive link in chat. So you can click that, donate anytime again. I believe they use PayPal to do it. There's no cryptocurrencies yet for the Tiltify system. But again, I mean, it would be absolutely amazing if someone could donate like $300 right now and kill this thing, but we're not even asking for that. If you have just simply, the way we got to $308 in the first place is a lot of donations, including anonymous donations, literally donating $5 or $10 here. Even $1 will make all these streams for FOSDEM 2022 worth it, especially since I'm going to be streaming from like 4 a.m. in the morning all the way to noon. This is crazy stream. So anyhow, next up, and I'm going to leave it on the floating page, we are going to be doing running trusted node payloads with Nomad and Waypoint. I will see everyone at 7:15 so that we can watch Log4j together, and then we're going to take another short break, and we're going to actually, no, we'll be back for Log4j, and then I believe on crowd security, I'm going to take another camera break, and then we're going to, actually, no, sorry. We're probably actually going to watch everything until 10:30, and then I'm going to take a camera break, ironically enough, about camera mobile support for FOSS devices, so that's going to be fun. So, yeah, let's watch a brief look at running trusted node payloads with Nomad and Waypoint, and then we're going to look at the insanity that is Log4j. So I will be back visually at 7:15, so enjoy.
day, good afternoon, good morning, wherever you are. Welcome to my talk about running trusted payments with Nomad. Let's first introduce myself a little bit. As I said, I'm Tom Vogler, and I actually went to university to become a molecular biologist. That seems far away from operations and engineering, but it was a quite gradual slide down to the dark path, as my colleagues used to say. From a biologist, I went to bioinformatician or developer, getting through the 500,000 data points a week that we were generating. And in an academic world, the developer is also the server guy, so that's how I picked up config management and operation skills. Now, for the last decade or so, I've been in operations, and I'm currently a DevOps cloud engineer at a Dutch consultancy company called The Factory. So, to start off with my talk, I would like you to ponder the statement that's currently on the screen. So, imagine the situation, it's Monday morning, it's stand-up time, and the intern just proudly announced that he solved the problem we've been having with our main product, our money maker, by fixing the database connection. And I'm probably right when your reaction right now is similar to the person that's on the screen. It was also my reaction on the screen. So, as a background, this is pretty much a story of my youthful history as an operations guy. So this actually happened. It wasn't the database connection we were discussing, but yeah, a fairly junior person quite proudly announced that he fixed something in our main product that to most of the people in the room didn't seem related to the problem we were facing. So first of all, everybody's gut feeling was, why did you deploy on your own? Why did you deploy on Fridays? We don't do that here. But instead of scolding my young colleague, me and the other people in the room actually started thinking, why don't we deploy on Fridays? Like, why was there nothing in place that would have... So the product was still fine, we're still making money. So what would we need to have in place to make sure that the code that our intern pushed out of the goodness of his heart, like, what do we need in place to make sure that that doesn't cause any problems? Or in a worst case scenario, even a bad actor inside or outside our company, if they were to be able to push code to us, how do we prevent bad code or, mistakenly bad code, let's say that way, into production? And of course, when we looked at this code, the case for him didn't make it any better. I'm not showing the actual code. This is actually code. This is valid code. It's functional code. It's code that creates Mandelbrots. And Mandelbrot is a type of image, and this code is shaped like a Mandelbrot. So it's a Mandelbrot shaped code creating Mandelbrots. It's actually a winner of a competition to create the most obscure code, and they seem to be winning, at least in my case. But the code the intern produced wasn't as obscure as this, of course, but it was hard to read, it was hard to follow. We weren't exactly sure that it actually had any effect, or if it had a good effect. So that didn't help, right? So we had to have a conversation about, so first thing we did is lock everything down, and that's not necessarily a bad thing, but of course he made the mistake of shutting it down too much, so it became an impediment and people started to try getting around it. So closing down on yourself is not always the right option. It's making sure that people can do their job in the most secure way possible. So, because, right, we're in the business of, selling stuff or servicing people, but in the end, we need to get our product in front of people. And to do that, we need to have confidence or trust in production. So we need to make sure that everything that we do or put in between a developer station and production or a customer is to the benefit of giving us the confidence that it will work. So I borrowed here a definition of chaos engineering, which is an advanced feature of this all, of testing. So getting confidence in production. And so we need to open it up, but we need to have a process in place that will provide us confidence so that we can allow people to push code. Or we don't push code for the sake of pushing code. No, we push code for the sake of providing new features. So we should be able to release new features in our place. So first step to gain trust, of course, is adding tests, both unit tests, so small tests that will make sure that the code will run, operates in the way that we think it does. Then we'll add a layer of integration tests, basically exposing it to the wild world for the first time and making sure that assumptions it makes about how the world looks like actually are in place. And then, of course, system integration test and end-to-end is actually a surpassing phase of the same concept. Right? We'll open up our system to more outside information, outside places that have different contracts or different promises, and how our code acts on with those contracts or promises. From, if you're a fan of promise theory, right? Because a system can say that it's supposed to do something, like I'll be cleaning my room, but our code will need to validate that the room is actually clean, right? If you ask my 16-year-old self, did you clean your room? The answer, of course, is yes, but the truth might be a bit far away from my answer. And so your code and your test not only need to test the happy path, it needs to also make sure that it tests the failure path or the dark side or whatever you want to call it. So adding testing, just to make sure that our developer, our intern doesn't produce unlegible code again, we introduced code reviews or a 2-man 4 eyes principle. Right, so we always made sure that before code can go to production, at some point during the process, someone else has looked at it. Not only for code quality purposes, but also nefarious reasons. Not that we suspect anybody from being an actor, bad actor, but there's a possibility, especially when you're in more advanced or high capital places like banks, for instance. So put it in place, but make sure that it's helpful, helpful in a way that it creates trust, it creates better developers, but make sure that the process is not blocking in any way. So make sure that you'll have enough people to review your code, that it happens quickly enough. Most of the time, your CI/CD system can also help you out. Talking about CI/CD and making it simpler, I'm used to a lot of CI/CD tools, Jenkins, GitLab runners, the Travis CI, GitLab Actions. The most of the time, you'll be allowed to write freeform pipelines. That's good because I can do basically anything I want. But also, going from project to project, it makes it difficult. So everybody writes their pipelines in a slightly different way. Naming things is hard, so steps will inevitably be called different in every pipeline, although they do the same thing. And this is where Hashicorps Waypoint comes in, and it's a fairly new product they released. And it's to me, so it's an excellent tool that could help us formalize way we deploy things. And that's because it has a built-in step naming convention. Waypoint, the pipelines are written in the Hashicorps configuration language. People that are used to the Hashicorps product suite should be fairly familiar with it. Packer uses it, Terraform uses it. So not only now you have a shared DSL, a domain-specific language across all your product. So not only the configuration management people or your ops, traditional ops people will write using the same code, but in Terraform, but also the developers that are creating their own pipelines will now use HTL. It's easily extendable, but by having a plugin framework, so if anything is missing, you can quite easily add it yourself. Or hopefully someone in the community will have had the same problem you have currently and will have written a plugin already. So what does it look like? I mentioned already, it has a set nomenclature for pipeline setups. So here with example product for a project called Lorem Ipsum, and it will have 3 standard steps. It will have a build step, it will have a deploy step, and it will have a separate release step, which is nice, which you don't see in too many CI/CD tools. Immediately, so you have to shoehorn it in, but in Waypoint it's already built in. So you can deploy something, but you don't expose it to your user set, which is a very powerful tool you have in your toolbox to be able to make sure that everything is ready and then you deploy it to customers instead of having to show them a sorry, we're down for maintenance screen for a while. So of course your CI/CD, there's a lot of places that you'll have need for secrets or passwords, and a lot of tools, the first initial way to do it is hard coding it into code. And basically means there's now a plain text password somewhere in a config file that basically the entire company has access to. So you can, of course, as we did initially, you can restrict it, but there's another tool that Hashicorps provides, which is Vault, which is their secrets management tool, and it's open source. It can help you with your tokens. It can save passwords, you can retrieve passwords, it can help you do certificate management, and it even can help you, and that's why I'm focusing on right now, is what I call password as a service. So Vault has the ability to create short-term SSH passwords or MySQL passwords, and there's several others. But that way, you no longer need to hard code a password somewhere. Now you have just a step in your process that says, I need to deploy something to a new server for which I need SSH. Please generate me a SSH key that's valid for the next 10 minutes. It auto expires, so there's no interactions, there's no lingering passwords that in the system that happen to be on everybody's post-its on the screen, because that's your get out of jail card now. Vault now creates the password, you use it for 10 minutes and it automatically gets removed, which is brilliant. This is where we are in the process of internal. So what I call internal, this is the internal process where one writes code, where we build it, we check it, we deploy it to customers. But there's other ways of people, well, bad actors, so can involve the system. So from now on, what I'll be discussing is how can we prevent bad actors from interacting with our system or manipulating us in doing something or deploying something that we didn't want to. So before was unintentional mistakes. From here on in, we'll be discussing intentional bad actors. So first of all is an advice I got from one of the CTOs I worked for: do not trust the internet. His version includes profanity, but for the sake of this presentation I won't. So I'll stick with do not trust the internet. And that's annoying because we want to stand on the shoulder of giants, which has pros and cons. And we'll be discussing a few of those in the next slide. Right? When we write code in either our Node, our PHP, our Ruby, great people have gone before us and they've written very good packages. So we want to use npm install, we want to use composer install, so that we spend our time writing the code that we need or that we make money with, and everything else will pull in as a dependency for the boring stuff that nobody's interested in writing yet another object mapper for any databases, right? Use the ones that are used, use the ones that people are frequently using, so the bugs will be out, more people have looked at the code. But that brings us in trouble, because as we discussed in the previous slides, let me introduce the concept right now. So the concept of supply chain attacks. So people attacking the bits outside your own infrastructure to make and which you have no control over, right? npm.org is not under your control. So if people manage to remove packages that from npm, you're in trouble, right? You have continuity problems because you happened before. A developer got mad for some reason and he pulled all his packages, which happened. A lot of other packages happen to depend on, and which other packages happen to depend on. So basically, half of the internet couldn't deploy on a Friday. Not only didn't want to, but literally couldn't. So you have a continuity problem. And that's actually, in this scenario, is the best scenario to have, because you can't deploy. But what if someone managed to hack into someone's npm account or RubyGems account or their Maven account and managed to inject bad code? Crypto miners come to mind if they're not actually interested in ruining your product, but just your reputation by using everybody's computer to mine code on. You can say that's far-fetched, but it isn't. If you Google supply chain attack, then your favorite programming language, you'll find that even in the last year, pretty much all of the languages that have a central package repository have been either attacked or successfully attacked. So we should have a way of not trusting the internet, which basically means pull everything inside. So have your own operating system repository, so run a pulp for your RPM stuff, for your Debian stuff. Pull in every base image you're interested in, run it in your own repository, image repositories. Pull in, as I said, make a own cache of npm packages, Ruby packages. Use tools like Artifactory to pull everything in, so you no longer have a continuity problem. So because if the upstream provider pulls it out, you still have the local version. But it also gives you the opportunity to create what's called a software bill of materials. It's something that came out of corporate America, but it's very, very convenient to also do it. It's spelled. It will take a little bit of time, but it will teach you several things. First of all, it will actually teach you what is included in the first place. You think, from a high-level perspective, because you'll have a RubyGems file, but or whatever the equivalent is in all the other languages, but those packages have dependencies, which have dependencies, which have dependencies. So especially if we look at the...
All right. I still have to pop in and out in a little bit, but up next, which we'll have the cam on for at least, we might take one other break and that's it. We are going to go and check out the gift that keeps on giving. The thing that I think described everyone's New Year's and definitely described my January, which is, there's sections for every single programming language in here and every single type of framework, software framework. And of course, there is a Java one, and you can't have a Java one without Good old log4j. So let's look at Java security, log4j, the security manager, and funding. Here we go. I am actually hyped for this one.
Hi, thanks for coming to today's talk about Java security. What I want to do in this talk is to talk about a couple different elements in the Java ecosystem. The first thing that I want to talk about is log4j, a relatively major incident that occurred in the Java ecosystem about a month ago that affected a little over half, or probably about half, of Java applications. The second thing that I want to talk about is the security manager, or how certain things in the JDK are changing in order to make the overall system more secure, and just make some adjustments that are worth knowing about. And then for open source developers, I want to talk about the role of funding and how different organizations and open source projects can get funds and not feel like they're scrounged or scratched up against the walls by a lack of funding, with other organizations having a lot more than you do. So to introduce myself, my name is Eric Koslow. I currently handle developer relations for Contrast Security, working to secure applications from the inside. Before joining Contrast Security, I've done a number of things in the overall software ecosystem. One of the notable roles for FOSDEM, or those in FOSDEM, Friends of OpenJDK, is I was one of the principal product managers on the Java platform itself between 2013 and 2016, working with an emphasis on security. Before that, I was a product manager of some security products that would analyze code for security flaws, and I was also a software engineer, so I sat and built software and wrote it every day. Otherwise, I'm also a news editor over at InfoQ, a technology news reporting site, and I've done a couple courses with Pact Publishing. Probably the most popular one that I've done is called Hands-on Cryptography with Java.
I totally dig the unicycle picture. That's a nice touch.
So the first thing that I want to talk about today is log4j, explain what that was, how it affects a lot of Java applications. But in short, log4j, log4shell was the nickname of the vulnerability, was a really bad vulnerability that affected a lot of Java applications. And it had a CVSS 10 because it was fully remotely exploitable in terms of running remote code execution on people's systems. The way that log4j vulnerability worked is any attacker who could get a string into their system would submit a particular string that was expression language combined with a JNDI lookup. You can see a picture of it down in that license plate on the car over there. It's JNDI LDAP, then you give it a URL. And what would happen is any Java application that went to log that string through log4j would look up that class, try to download that class from the internet, and then execute that class to run anything that happens, and to execute anything that that class does. So the result is any attacker who can get that string into your application to log that as regular data can typically cause your application to run their remote code. And the most common thing that people are using this for is to execute system commands. So they just do system get runtime.exec, and then they pass in their own string to run all kinds of things. And that's the most common thing that people are doing here. But the result is really bad. And is it really that bad? Is this something that we need to pay attention to? It's actually a bad enough vulnerability that two major organizations in the United States associated with the government had to step in and take a bit of a decisive action, more so than they usually do. CISA is the Cybersecurity Information Security Agency. They handle a lot of things for different federal organizations. And what they did was, back in mid-December, they literally came out with an edict for the rest of the government that said, you absolutely need to patch within a week, or we're going to have some words with you. They can actually have words with anybody that they want to. They're a relatively good organization that can get around when they need to.
The camp disappeared.
Christmas Eve was coming up. Their deadline was, I think it literally was Christmas Eve that you had to patch by. Similar thing, the FTC is the Federal Trade Commission that does a lot with consumer enforcement. They came out with a notification in early January that basically said, hey, everybody, we want to remind you that we're the ones who fine people who are negligent on cybersecurity. We just wanted to remind you about our enforcement powers and that we've issued fines in the past. That's not a very common thing for government agencies to do, so it demonstrates that there's a lot of attention on this vulnerability and it's something that we should all pay attention to. And who can exploit Log4j if we don't patch? Is it really that bad? Do I have to do it? What if I set up a system in place? Well, the way that people attack Log4j is that anybody can really exploit it on your systems as long as they can get data into your system. What I have here is just an exploit demonstration that I'm able to use. If you look at the command on the top right, I have a class that opens whatever system command that I instructed to run. In this case, I'm on a Mac, so I gave it the command of open my calculator because that's the most common thing that people can do. And what happens is I just have a basic web application that logs some of the input. It logs the data body that comes in. So if I go and I make a request to that web application and I give it a data body down there on the bottom left that says LDAP, I give it my LDAP location where I'm listening, and I give it my class file, the JRE will go download that class file and execute it in the system context. And what happens in this case is my system executes the calculator application, and when I go to access that web request, my calculator opens. So it's nice from an exploit perspective because it works and I can show it to people, but it's really bad when other people can execute system commands on my machine. And what did good patching look like for the people who did a good job in terms of patching and fixing their vulnerabilities in terms of remediating Log4j?
I love that the default example is the calculator. That's just hilarious.
Group, I think it was Volker Simonis and Martin Verberg from Microsoft who did some good collaboration around an instrumentation agent, and I was kind of happy that SD Times picked out a project that I worked on called Safe Log4j. But ultimately, good patching was a mix of three things. There are people who went through and they updated the Log4j library to introduce a version of the library that wasn't vulnerable. The second is, in the cases where you couldn't do that or before the patches existed, they used an instrumentation tool, which is what that hop patch for Apache Log4j that AWS did, as well as Safe Log4j. Those are tools that connect to a JRE and provided instructions on how to execute securely and effectively mitigate the Log4j library. Otherwise, another good thing was people who had an inventory and knew where Log4j was. Because when you know where Log4j is, you can go through and you can actually patch it. Otherwise, the weak patching, the people who were really stressed out, they were kind of the opposite of this. They were scrambling to ask other teams. I saw a number of groups that were posting on .NET forums or demanding answers from their open source projects and saying, you need to tell us, do you use Log4j? Well, Log4j is a Java library, so it doesn't make sense that when I'm in a crisis and I have to deal with something, that I go ask a team that's clearly not affected. It's certainly fine to ask your .NET or Python or Node teams about their security posture, but not when you have to deal with an emergency in terms of fixing a vulnerability right now. Otherwise, something that was kind of weak was people who were updating network defenses because that license plate from before, the reason that license plate picture is funny is we know that we're going to log the text that we read from the license plate. And that's not web input. You can't block that at a network level because it's part of an image processing system. There's too many ways that we get data to log to block it at a network level. Otherwise, another thing that happened with the teams that had a lot of trouble was they had no idea where Log4j was, which is why they went around scrambling everywhere in order to deal with the problem, and they didn't make much headway because they were going to places where Log4j wasn't. But if you still haven't patched the library, please do so. Please go ahead and patch the library. If you haven't done it already, it's really prudent to do it. It's something I strongly advise that you do. If you build the software, you can update the library. Please go ahead and do it. If you buy or license the software, maybe it's a commercial thing that you get from somebody else, you can either make what's called a software bill of materials, or you can just ask the vendor for it. It's possible you can ask an application and say, hey, what are the libraries in this application? And you can just look to tell if it has log4j. Of course, with shading and other techniques, you want to do a bit of a diligence to figure out if there's any log4j classes hidden in another jar file, but you want to look. And then you can also get a patch from that vendor if it's a commercial software, or you can use one of the instrumentation-based patches that I showed just a minute ago. And if you rely on a service, you communicate to somebody upstream, like a cloud provider or something, it's worthwhile to ask them if they've patched, because if you don't have insight into their tech stack, it's not the same as a .NET team where you know that they aren't affected. You don't know, so it's worth asking. Otherwise, you really want to focus on what it is that you're defending, and in this case, there's really two things that you're defending. The first is you're defending against hackers who are stealing your data, because that's what they're going to do with the log4j exploit. The second is there's regulators that are probably going to fine you if something bad happens, because they've literally stepped in and reminded us that they're going to do that. So if you're not worried about hackers, or you're thinking, oh, it's hard for them to get my application, maybe defend yourself against the regulator by just patching the vulnerability. Regulators, in a sense, are the ultimate advanced persistent threat, because you're not allowed to keep them out. Now I want to talk a little bit about things that have gone on in the Java
You should always worry about hackers.
Security Manager, and while it's been deprecated in JDK 17, there are some other really nice things in there that you can use. One of the big things that's been going on since about the Java 9 timeframe is the modularization of the JDK. And what's happening in the modularization system is the attack surface is actually going down quite a bit. I'll move myself to the top right up here. And what happens is, with applets gone, the attack surface from those applets is no longer present. So a lot of the threats that used to occur in the Java ecosystem aren't there anymore. And what I like about modularity is it takes different threats and it really boxes them into a small environment. So with java.xml, which is a package as part of the module system, that's where I'm going to have my XML-based attacks, my XML external entity injection, my XML bombs. If I use java.xml, I might have those vulnerabilities. If I don't use java.xml and I actually J-link that module out, it can't affect me because it isn't there. Hackers can't attack things that aren't there, so by taking these threats and these risk profiles and putting them into nice boxes, it's made it much easier to secure systems because we know what's there. Same thing, there's one java.compiler. If I don't have the compiler shipping with the system, nobody can attack my system through things like JSP injection, where you upload a JSP to a web accessible location and you cause the server to execute it. If the compiler isn't there, the system can't compile, which means that it can't execute uncompiled code. Otherwise, another major vulnerability that people have dealt with for well over a decade now is SQL injection. It's a way of modifying a query through remote input to take over and steal a lot of data. That's present in the JDBC, the Java Database Connectivity, in the java.sql module. So if my application doesn't use the java.sql module, it's really hard to get a SQL injection in there because I'm not using SQL at all. So by taking these threats and really boxing them into areas, it's made it much nicer to do a threat model of an application and figure out what's there. Another big benefit that I've seen here is the presence of JDK Flight Recorder. I really like JDK Flight Recorder. It's probably one of my favorite tools that was introduced in the JDK in recent years. And what I really like about JDK Flight Recorder from a security perspective is it gives you nice visibility in terms of what's happening in the system.
He really has no idea where he wants to put his camera, does he? Like, FOSDEM really needs to put a standard of where your webcam goes and where your slides go.
Because deserialization is a vulnerability where people can often execute arbitrary code by providing a new body for the method in the object that they tell you to deserialize. You go to deserialize it, you ask the object what it needs to execute, and the object gives you a vulnerable payload and takes over your system because it says, you deserialize me by letting me take over your system. Not really a good bargain if you're on the receiving end of that, but if you want to attack applications, deserialization is regrettably an effective thing that you can use. And one of the things that I like about JDK Flight Recorder is I can actually look and I can ask a system, are you doing deserialization? Have you done any deserialization recently? If you have, what are some of the classes that you've deserialized? And now I have a bit of an understanding as to what that application is doing. And I can actually go through, and when I run something in my QA or dev environment, I can get a view of good behavior. I can get an understanding of the classes that I do deserialize, so I can use another feature called, I think it's called a serialization filter, and I can provide that list to the serialization filter and say, I only want you to deserialize these classes because I know that they're safe, so if anybody gives you any funny business with a deserialization payload, please don't execute that, and please don't let them take over my system. JDK Flight Recorder, wonderful on the visibility perspective, and it gives you the information you need to secure deserialization events and some other things. Right, here's where I was talking about deserialization making the filters possible, because in JEP 290 a long time ago in JDK 9, they introduced a serialization filter, but what happened was nobody knew what classes they were supposed to provide. They'd just say, like, well, you can provide a list of safe classes. Nobody knew what that was because I don't know what classes my libraries use. I might know which things I need to deserialize, but if I run on Tomcat or WebLogic or JBoss or any of the app servers, I have no idea what they need, so nobody really knew what answers to give to the serialization filters. But JDK Flight Recorder can now tell you, so what you would do in this case is you just use your application where you'd have JFR, JDK Flight Recorder recording in the background, and you'd collect that list of classes, you'd collect the list of what it says it's deserialized. You would then create that allow list and give it to this JEP 290 serialization filter, and lo and behold, you'd know that you would only deserialize the known safe classes. And with that, you just continue your regular patch cadence of making sure that you patch your JRE and JDK in accordance with the security baseline, keep your libraries up to date, and you're pretty good. You've defended against a major class of vulnerabilities. So the combo of JDK Flight Recorder with the serialization filters is a really good security benefit. The security manager is one element here. They deprecated it in JDK 17 as part of JEP 411. If you use the security manager now, just be aware deprecation doesn't mean removal. It's not getting taken out in 17. It's getting marked as deprecated. So what happens here is if you don't use the security manager now, which most people don't start using it. Could it have done something in log4j? Actually, yes, that's kind of a surprise and literally a poetic end that nobody saw coming here. But just, it's not a thing to get started with using right now. If you say, oh, well, there's a security manager, I wouldn't go reaching for it. Could it have stopped log4j? Yes, actually, it could have done something with log4j now, assuming that it was in place and correctly configured. But what happens is the majority of people don't have it in place, and it is actually hard to configure. Probably one of the best teams, the only one I've seen really do it well at scale, is a company called Elastic. And when I went looking around for examples of teams that had used the security manager well, Elastic actually has some details about how they've configured the security manager to work in their application and how they've tuned it to defend against log4j. So it was pretty interesting to see what they had done. So good job, Elastic, for having used the security manager and come up with good policy files. But they were relatively unique in the Java ecosystem because they built the application and they could provide guidance to the operator in terms of how to use it. And a lot of us don't necessarily have that level of control or the same things that Elastic had. So while the security manager could have done something, it's not in the right place for most people to be able to do it. It may be really difficult, and probably not feasible within the time frame. So to summarize the Java security chapter,
Thank you, True47, for following us on Twitch. I really appreciate it. This is a reminder, if you're on Twitch, we are trying to raise funds for the Children's Miracle Network Hospital. At the bottom of Twitch, there is a widget where you could donate. You don't have to do a lot, $1 or $5, and we'll worship you basically forever. But let's look at more into how you can secure your Java platform from the dreaded Log4j.
You're busy for a time. I understand. I don't expect perfection. Just don't let your JREs languish for several years. Also, keep up to date on your libraries. There's a tool called Dependency Check that you can use from OWASP. GitHub has some things that they can use to automate pull requests to upgrade vulnerable dependencies. And when you run Java in production, the JDK Flight Recorder is an excellent tool to use to monitor for events. It has a lot of really nice capabilities in terms of understanding what the JRE is doing and giving you good visibility. And instrumentation tools are the things that AWS, Microsoft, and myself reached for in order to deal with major events going on like Log4j. And the reason that we reached for them is they work well for security. They engage the JRE at a code and method level and allow you to make adaptations that weren't there originally. So in the case of the Log4j vulnerability, what we did was we simply disabled Log4j's ability to load remote code, which the majority of people said, why is my logging framework loading remote code anyways? I don't want it to do that. Log4j team is a bunch of really nice people. It's just, things happen. Otherwise, I make instrumentation security tools. That's the main thing that I do. You're welcome to use them for free. We have a thing called Contrast Community Edition if you want to try it. What you get in use of that is you get a thing that will track your vulnerable dependencies, so you'll see where you depend on different libraries that are vulnerable, if any major vulnerabilities in the world affect your application. You'll also get the ability to detect custom code vulnerabilities, and because it relies on Java instrumentation, you simply place an agent in your application and you don't have to change any code. It just automates the detection and it puts a sensor where that sensor is supposed to be. Because FOSDEM is an open source project, we do have a lot of open source tools. I've put a link here to developer.contrastsecurity.com where we have our GitHub location posted. We have plenty of tools that are open source. SafeLog4j is one of those that anybody can use for free for perpetuity for as long as they want to defend against Log4j vulnerabilities. It's perfectly fine. We like contributing to open source things. And if you work on an open source Java project and you say, can you help my open source project? I'd love to help your open source project. Just reach out to me. I'll put my contact details at the end. I'm looking at a lot of things, and yes, I'd be really happy to help anything on your project. It's a great way of engaging the community. Now, the last thing that I want to talk about is funding, because I learned a while ago a really interesting fact that paying of various open source groups is actually hard. It's not that people don't want to fund you, maybe that's also true, but it turns out that when you go to pay them, it's actually not easy. And the realm of no money is actually common in the open source organization. So you can certainly look at your own examples and go back past 2014. But in 2014, the OpenBSD group almost shut down because they didn't have money to pay their electrical bills. Of course, they ran a bunch of servers and different things to do their builds, and they were literally going around asking for money to keep the lights on. That's pretty tough in order to create a major secure operating system when you're worried about your electricity bill. In 2016, something else happened with NTP where there was a vulnerability.
I very much feel the pain of this. Eventually, we're going to also have a donations page so that you can help us do even more crazy things that we normally do, including our upcoming badge for DEF CON, which we hope to make an announcement between February and March about.
Like, you can go report that this is vulnerable, but we'd like some help. Otherwise, another major event that occurred back around 2014, another major vulnerability called Heartbleed, where OpenSSL was compromised and had, I think it was a remote code execution vulnerability in it. It wasn't until that vulnerability that people turned around and finally started funding OpenSSL, never mind that it was in just about every project. And I'm in kind of a unique
I love that
position here
Heartbleed
because
just
I
never
can just
dies.
move around
It's
and
like
start
Heartbleed
things.
and Stuxnet
And when
never
I say
dies. And then
Untitled Chapter,
Y2K came
what
back
I
thanks to
do, this is
Microsoft
a
for no reason.
technology news site where we write a lot of articles. One of the first articles I wrote when I joined that team was about the EU bug bounty program. The EU created a bug bounty program called FOSSA that was designed to provide funding to security researchers who found vulnerabilities in critical open source projects. So what the EU did was they went through and they analyzed and they figured out what are some open source projects that are critical to us. And they picked a couple. The Java ones that they picked.
No relation. See, when Europe creates FOSSA, it's awesome. When the United States creates FOSSA, everyone gets censored.
And I was
Fun.
fortunate here to be able to interview a couple people about FOSSA because at InfoQ we do a lot of actual research. We don't just write our opinions masquerading as news. So I interviewed members of the EU who are on the team with FOSSA, as well as a couple other people in in the overall open source ecosystem, and I just asked them some questions about open source funding. And here, if you found a security flaw, you get paid up to 25,000 euros. Pretty good amount. And if the project acknowledged the bugs and fix it, what did they get? Well, it was nothing. It wasn't that the FOSSA people didn't want to pay them. There are other reasons that I'm going to get to in just a minute. But I looked into the question here of why would groups pay for finding security bugs, but not pay for maintenance that would prevent them or fix them? So I found that to be a very interesting question. So that was one of the angles that I pursued when I was writing up the article. And I also talked with a bunch of people in the open source community, and I said, well, what's your view on bug bounties? What do you think of these things? There's a couple other bug bounty companies. There's HackerOne, there's BugCrowd, a few others. And what a couple open source maintainers told me is they really seem to recognize the importance of bug bounties. Like they understood why security vulnerabilities and security bugs were important, but they didn't really like the concept of those bounties. And one of them told me something, I think I'm paraphrasing here, but they said, those bug bounty programs, they create a lot of work for us because we have to validate the fixes, we have to validate the findings, we have to tell that that researcher actually found something real, and then when we do validate that, we have to go through and fix it. Like, we have enough issues already, why are we paying people to go out and find more? But, you know, they're good maintainers, they're good groups. You're probably a good open source contributor here coming to FOSDEM. And so what happened was they understood why these security flaws were important, but it was really unclear and kind of murky as to why you'd pay for one class of bug, but not the others. And a couple people were just joking around because intelligent people like to joke. Humor doesn't mean you're going to actually do it. But I heard more than once a humorous anecdote that said, if you want to get funding, just introduce a major security flaw every once in a while. Because if Heartbleed got the money when they introduced a major security flaw on accident, well, why shouldn't I introduce a major security flaw into my project as well? And then those companies will pay me to fix it. Now, I haven't seen anyone actually doing this. I have seen some other shenanigans that have gone on in open source communities recently, but like this is a correct and sound logical argument, whether you like it.
I can easily answer why you would want to pay for it. One, because someone else did all the work, and two, no one really sues you when a button doesn't work, but they will sue you when all their information is stolen. And you have enough people do that all at once, especially when big entities are involved, and you are fucked. And I think that's worth, basically, it's putting smaller money up front so that you can avoid bleeding larger money later on. But that's just me.
Contractor there without a contract. So, like, how can you justify allocating funds to this developer or this project without others? There's no kind of corporate structure there. So what you're doing is you're just giving money to an individual person. And that's kind of ripe for abuse that's occurred in different communities. I drew what I think is at least a funny cartoon down in the bottom of a politician. I grew up in the Chicago area. In the United States, it's regarded for its political corruption. So this role of, my brother runs an open source project, so that's the one we need to fund, that's what I grew up with. If you have a team of developers, you have like 5 or 6 people working on a project, well, which of those groups do you actually fund? If there's no kind of corporation or no entity or no charity to fund, it makes it really difficult to figure out which of them get the money and how much you would fund them. If you have a foundation like Eclipse or Apache, those are actually kind of the easiest to pay because there's some entity there and it's clear to anyone looking what that foundation does. Like there's no ambiguity that the Apache Software Foundation is dedicated to open source. There's no ambiguity that the Eclipse Foundation is also dedicated to open source. So it makes it relatively more possible to contribute to those foundations. And there's some common models that I see when I look out in successful open source project is the role of a project and then an open source version of that and a group that kind of stewards and guides the open source group, as well as a commercial entity that is able to sell support contracts and do some of the monetization pieces that fund people to actually work on that open source project. So in the Java community, that's been going on for about 25 years. We all know it was started by Sun Microsystems. And there's kind of 2 major locations for its open source. One is the OpenJDK project that's kind of run by Oracle. The other is the Eclipse Foundation that runs a lot of Jakarta EE. And there's a number of vendors in the Java ecosystem that are able to pay for support engineers and people to actually work on JDK. So you have your open source organization, you have your open source steward, and then you have the commercial organizations that really pays a lot of the contributors and gets them to work on the project. A similar thing with Kafka. Kafka is Apache Kafka. It's an Apache project, and it has commercial support vendors. Confluent and Avon is another one that I've seen in that realm. So if you want commercial support, if you want to pay somebody to work on Kafka, those 2 organizations tend to be doing that. Cassandra, also run by the Apache Software Foundation. You've got 2 vendors in that space. DataStax is one in particular that funds a lot of the work that goes on in Apache Cassandra. So what you have is the open source organization and then a commercial entity that is able to collect money and get people to be paid to work on that open source organization, on that open source project. So if you're stressed out about your own project funding, if you're working on an open source project and you're wondering, how can I do some of this? One of the ways that you can do this from the perspective of the people I talk to who could fund some open source projects is to ask yourself, when somebody funds my project, where should that money go? And if it's going to go to the project, the difficulty is there's no real definition of what that project is for somebody to pay. So in this case, you might benefit from using something like Tidelift, which is an organization that lets people sign up for open source support subscriptions. And just sign your project up for Tidelift, and you'll probably get some funding because Tidelift makes it possible for people to fund you. If you want to get money as an individual, just to fund your open source project, not that you have to monetize the entire ecosystem, you probably need some sort of consultancy or LLC around the project. And what I would do is just give people the ability to buy like a minimum number of hours for you to work on the project. And the benefit there is there's something for that organization to actually buy that they can put on their books and make it possible to give you the money. So if you sell like a minimum number of hours that you'll work on triaging their bugs, fixing their bugs, consulting, something like that, it's possible for them to pay you to do that. And what you would do as a consulting arrangement is you'd probably sell something up so that those hours can expire on either a monthly or annual basis, and that's relatively common. Otherwise, if you do want to set up a consulting company, you're certainly welcome to do that. You can get a lot of contributors there. You just set up a consultancy or LLC around the project, and you would essentially sell support for your open source project. And that way there is something for the organizations to buy, which is the support contract from your company, where then your company goes and spends that money on the open source contributor group. Otherwise, if you don't ask it from this perspective and you just say, how can people fund my project? It's really a big question on the other end, which is, if I'm going to fund a project, what am I actually funding? And there's two good groups here. I was talking about Tidelift in the last section. Tidelift is an organization that makes it possible for a company that uses open source to essentially buy a subscription to open source. So they commit a certain amount of money at every particular time, every quarter, every year, and they just say, we actually want to fund open source. Tidelift looks at their utilization and they say, you use the following 12 open source projects, so we're going to take your money and we're going to divide it up in a particular way, and we're going to get it out to those maintainers in order to be able to actually pay them to work on things. So companies sign up to pay support based on what they use. You sign your project up. You get some amount of whatever money the companies pay to your own project based on usage. So it's a nice way of collecting something. It's probably not going to be huge, life-changing amounts of money, but it's something that you can use to not feel like other people are taking advantage of you. Otherwise, in terms of foundations, the Eclipse Foundation has been doing a really good job in the Java ecosystem of taking over various projects to just do the work around the ability to get an open source project. And what Eclipse is doing, especially in like the Jakarta EE realm, is they do a lot of the work that makes contributions possible. So they build the ecosystem, they manage a lot of the IP stuff, they manage a lot of the contributions, community discussions and whatnot, and they do the things that you as somebody who writes open source code don't really want to do. There's a lot of work around building a community and getting contributions and doing all of that stuff on the back end. That's what a lot of the companies do. So if you can get your project and it's something that the Eclipse Foundation would be interested in, you can certainly approach them. But what's nice about them is that they make contributions possible and they offload a lot of that back end work. I don't think they're a group. It's not somebody you go to say, hey, can you fund me? I don't think they really do that. But they lift a lot of the ecosystem errata off of your back. So with that, the summary of what we talked about is log4j, how applications are attacked, what the exploit payload was, how essentially if you use log4j, virtually anyone who could get your system to log data could take over it by getting classes to execute on your code. We talked about the security manager and how the JDK is changing, in particular the ability to use JDK flight recorder and instrumentation-based tools in order to get better visibility and defense in your system, and funding in terms of open source, where a major way of thinking, if you're crunched about it, is to look at the question of, if somebody wanted to pay my project, where would that money be going from their perspective? And a couple ways that you can do that to maybe not feel so scrunched. Otherwise, if you want to talk further, if anybody wants to follow up after this, I'm really happy to talk about your project. Just reach out to me through anything. Twitter's probably the easiest one to just get a hold of somebody. I work at Contrast Security. We do some accurate instrumentation. We have an agent that connects to Java applications and is able to monitor security flaws in the custom code as well as third-party library risk. You're welcome to use the free community edition in your project or open source group. And if you just want some general help hooking it into your open source project, I'm really happy to do that. Just reach out to me. So you can use the free community edition at any time you like. And if you want an open source project, we have an open source project called SafeLog4j that deals with the risk that I talked about at the very beginning. So thank you for coming to the talk. And if anybody wants to keep on talking, we'll be doing it over in the FOSDEM Friends of OpenJDK room. Thank you very much.
So that was the Log4j talk. It was really neat. I like that did an overview of like of what Log4j was. Very concise. Really, let's do the audio here. Really good speaker. I was not expecting the funding your open source project, especially within the scope of bug bounties and vulnerabilities. So honestly, so far, that's been the best talk and best speaker so far at FOSDEM. Now, I know there's a ton of talks. It's impossible to see everything until later on when it gets uploaded to YouTube and PeerTube. By the way, I'm still trying to fix PeerTube. I'm going to do that tonight. So this episode is going to be shared over to PeerTube when it's done on YouTube. So I'm going to put the YouTube URL. The next tomorrow, we're back to streaming on PeerTube again, just to let everyone know. Before we switch over to the other talk, I do want to note that one, we are still this today and tomorrow is our last two pushes for trying to raise money for the Children's Miracle Network hospitals, which is a fantastic organization. I'm actually going to bring up their Wikipedia. That donates whatever money that gives money to whatever money they're donated to, including our current $308.50 to various pediatric centers and children's hospitals across the United States and Canada. Just the idea that, just because my 2022 sucked doesn't mean that a child's shouldn't. So we want to hack the planet and get money to kids who are ill from COVID, mental diseases, physical injuries in need. To have the funds to do that, especially in America where we have no insurance, including very close to home to us is the Children's Specialized Hospital, which are 14 hospitals, pediatric hospitals across New Jersey. They're huge facilities, and they literally deal with every single type of thing imaginable to anyone 18 and under. So anyone 17 and under. It's absolutely phenomenal, the work they do, and it's only possible because of your donations to, for example, the Children's Medical Hospital. So I posted the link again, chat. If you can't get to your desktop or the link doesn't work, you can scan the QR code if you have, like, you're watching on TV like I am and you have a phone. And if you're on Twitch, you could scroll down and we have a widget that directly donates. It's using Tiltify via PayPal. Sadly, no cryptocurrencies, but it's a third-party reputable company, Tiltify. We handle the money. And while our goal is still 600, I don't know if we're going to make that. But let's say we don't. Let's say that by tomorrow, that miracle thing, we get $599 US, basically the cost of a launch PlayStation 360 gigabyte. All that money, including the money now, still will go to Children's Miracle Network Hospital to help sick kids across the United States, Canada. So just, you don't have to donate $20 or $50, even though that would help out a lot. But what really helps out a lot and how we got to the $308 in the first place is people donating very small amounts, like multiple anonymous donors. You can donate anonymously as well, who donated $1 each, people who donated $5, $10, that sort of stuff. That's how we got to over halfway to our goal. And maybe we'll get to our full goal, maybe we won't. I'm just happy, even though my eyes are about to fall on my skull, to be able to do this. And speaking of hack the planet, let's go to our next talk. And as much as I want to look at more Java security, this title stuck out to me just on the title alone, but I think its subject matter is very timely. It's called Hack the Planet, and it is about e-waste. How we can mitigate electronic waste in our society, especially with rise of industrial nations such as ours and China, and that the EU really wants to industrialize, and we're developing second and third world nations to unfortunately follow our same pattern, such as many countries in Africa and Southeast Asia and Eastern Europe. It's become a mess. And so we're going to watch, I'm going to turn the camera off, just to warn everyone, I am going to turn the camera off, but we're going to watch about how to mitigate e-waste. And we might see a very small snippet of another talk. And then we're going to look, I'm going to turn the camera back on. We're going to look at an open source book of software security for compiler developers. Then we're going to look up crowd security and about old web architecture. And then we're going to end it with this long ass talk that I'm just going to let play. I'm not going to have the camera on for it. It's going to be the last time I turn the camera off. That's about just cameras on mobile devices that aren't Android. It's pretty crazy. So without further ado, as they say in the professional infosec, as we all say, know and love in the professional infosec world, Hack the planet!
Not everybody has the same devices to debug MCUs.
See you all in roughly 30
having
minutes.
a lot of different debug headers means that people can quickly connect to these boards, and debug or glitch an MCU. It's got 6 SMA connectors, which connect to the LSC clock, the HSC clock, and the power plane. That is so you can connect a chip whisperer or a scope to glitch an MCU or to perform power analysis on the MCU. It's got jumpers on the board. Those jumpers are there to either connect the SMAs to the MCU or to remove that connection quickly, so you can prototype quickly if you encounter problems, you know what the cause of the problem is, etc. It's got solder jumpers on the back and the front to connect different parts of the functionality of the board to the MCU, and magnetic 3D printed feet. So when you place this board on the bench and you pop open the socket, the board doesn't flip. Now, in this part of the, in this diagram, you can see all of the different debug pinouts. Now, usually if you see a pinout of a board or of a development board, you see the custom functionality that somebody has programmed onto an MCU, and this is basically all of the functionality when it comes to debugging with regards to the MCU that's by default available from the manufacturer. This is additional I/O like SPI, I2C, etc. CAN that allows you to see where you can expect certain pins to break out. Now, the backside has 4 power supply solder jumper groups, and that is specifically for glitching and powering the board. If you connect the first 2 pads, if you bridge those pads, you can power the MCU, and by connecting one or several of the last ones, like in here, you can glitch that particular power supply line. That is so you have a bit of flexibility on which part of the MCU you want to glitch. Now we have a halftone effect image on the backside of the board. That's actually a face, and that's the face of Paul Feyerabend, which is a philosopher of science, and although he didn't coin the term, is an epistemological anarchist. He was a big inspiration to me about 20 years ago when I was studying in the art science department in The Hague, which is a department that combines art and science and engineering. And he questions the scientific method and especially the culture surrounding science and the role of the layman within the development of science. And he believed that the prominence of naturalism and the specialization of science required some checks and balances, and those checks and balances are provided by the general populace. This is one of the reasons why I think that citizen science needs to exist, and it's one of the reasons our lab was founded. The Unbi probe is a probe that we use to analyze boards. during the pandemic, it was quite hard to find probes that were flexible enough to allow us to deal with lots of different kinds of boards. A lot of probes aren't meant to be played around with. So I needed to design probes that allowed me to play around with a lot of different boards and to find out what were analog signals, what were data signals, etc. So I created this simple version which had a spring-loaded needle in the front, a magnet wire going to a header surrounded by a 3D printed case. That eventually led to a PCB format for it, which has a passive spring-loaded needle probe, a 2-pin header, a high-frequency SMA connector, 2 solder jumpers, 2 pads for 0402 size SMD components, and a spare needle that can be removed from a receptacle and replaced with a concave, convex, and serrated heads. Now, the ability to change heads is kind of important because we don't know what we encounter half of the time. Now here you can see a schematic overview, diagram overview of the probe. In the middle you can see 2 solder jumpers and the ability to add decoupling capacitors. That is if you want to use the probe as a driver. It's also possible, for instance, to place a resistor where you would use a solder jumper and a LED in a location of a cap, so you can quickly see which lines or which traces are live and which aren't. Now, this flexibility is important. This is what we're lacking in our tools today. A lot of tools have very specific functionality, very specific requirements, and they don't allow us to be that creative with solving our problems. That's why this probe exists. Now, the pin has a 1.27 millimeter pitch. It has a 2.65 millimeter travel distance, and that's kind of important. Mainly, if I use this probe, I tend to put it in vias or in vias in pads or right up against components. And if most of the time in all other probes that I have that aren't spring-loaded, it would lose connection quite quickly, and I just needed a stable interface with the board. And the travel distance of the spring allows me to make a reliable connection to the board. It's got a slim, long neck. I will elaborate why that is. And it's got a via fence surrounding it, so the quality of the signal remains high. And it's got a SMA footprint spec. Now, to use multiple probes together, we have the Unbi probe base, which is a magnetic 3D printed base. It has 12 SMA connectors, a 12-pin header, a prototyping area for 0603 sized components, ground buses around that prototyping area, and the possibility to bridge SMA connectors in that prototyping area. This allows you to be flexible, and we need it to be flexible. So all of the functions in this board are there so you can quickly prototype and quickly get what you need when reverse engineering an old device or a broken device. Now, as you can see, you can connect Unbi probes in the 12 SMAs on the top using, as you can see here, hand-formable RF SMA to SMA cables. That breaks out to the prototyping area on the right and a set of headers. It has 12 small magnets on the magnetic base, and that is to assure that you can leave the Unbi probe base on your bench during sessions, and it don't move. So it doesn't move much. Again, this is for the reliability of your of working with these probes, so you can make sure that personal error is not part of the data you'd eventually be capturing. We have another tool that also works in tandem with the others. This is called the Unbreak. The Unbreak is a QFP 48, 64, 100, and 144 breakout board. It is 3.2 by 3.2 centimeters. It's got a VCC bus on the top edge and a ground bus on the bottom edge. It's got a prototyping area for 0201 size components salvaged for mobile phones. So if we get components from mobile phones, we want to experiment with them, we use this board. Now this is the top and the bottom. As you can see here, the VCC bus is on the rim on the top. Adjacent to those are the braked out pins. And on the back, you can see the ground bus, and all of the pins adjacent to that. In A, you can see that you can connect the power supply pins and the VCC bus using 0 ohm resistors. Decoupling capacitors are placed between the ground bus and the power supply pins on the other side of the board. That allows for kind of quick prototyping and quick use of the board, and allows you to get reliable signals, which I didn't get from the Adafruit board. Here you can see all of the different pinouts together. The yellow one on the top is the 48 pin one. The one following it in green is 64, blue is 100, and orange is 144. Now, we use the probes and NumPy Probase to repair one of the devices we needed during the pandemic, which is the Thurby Thandar TA4000. This is a 400 megahertz logic analyzer, which was produced in June 1997. It's got 32 channels, an RS-323 port, a Gentronics port, GPIB port, and is used frequently. Now, after we gave a Hackaday talk about this earlier, and I got an email from somebody telling me that modern logic analyzers exist and that there are open source solutions. I'm perfectly aware of this. The handy thing about this logic analyzer is that it is easy to use manually without connecting it to an additional computer. And that means that if I have, say, a USB scope window open, I don't need to juggle that with a with my, for instance, DS view window. So also being able to control it manually without having to touch a keyboard is very, very useful in prototyping and working with different kinds of boards. Now, using the probes, you can see already 2 EEPROMs labeled. I labeled those. Using the probes, I found where the firmware was located, which was on an STM-C27C1101. It's found using the NV Probase, like I mentioned earlier. It's an EEPROM, first issued in September '98, and contained the firmware. Now, the flexibility of using my probes meant that I could use the LED option that I mentioned earlier, and I could see which part of the logic board didn't work and which part did, so I would be able to repair a few traces and get it back to working again. As you can see, I could dump the firmware, and we modified the firmware to use it for alternative use cases. So you end up with a hacked logic analyzer. That is one of the uses of our tools. I wonder what everybody else will be using when they use our tools. These tools will be available in our repository. That repository is repo.unbina.re. If you want to know more about us,
lemons!
You can find more information on our website at unbina.re. Our wiki, which contains all of the information of our tools, is on unbinary.be, and on Twitter you can find us at unbinary. Now, thank you for listening to this talk. Obviously, I haven't given you a lot of concrete examples of things you can do with these tools apart from the logic analyzer. Hopefully, once these tools are available, and once we make more tools available, it'll be more common to use tools specifically aimed at reverse engineering. And I hope that in the future or next year, we can have a discussion on which parts of the tools you found useful, what changes were required, and what other tools you might find useful. Thank you, and thanks to FOSDEM for inviting me. Thank you. Thank you, and thanks to FOSDEM for inviting me. Thank you.
We should be online.
Thank you, and thanks to FOSDEM.
Thank you, Maurice, for your talk and your involvement in reducing e-waste. We have a few questions here. Shall we try with MMU Man ones first? Did you try using the TA4000 with Sigrok yet?
I'm actually currently making it Sigrok compatible, so yes.
Great. What did you mean to glitch? Glitch for me is a problem. Can you be more specific? I know you gave an answer. Sorry. Thank you.
Well, the principle of a voltage glitch attack is that you use a short transient voltage, like a small spike, usually of by 1 volt or up, to glitch basically an MCU, and enough for it not to break, but to disrupt its normal order of operation. So what would, for instance, could happen is, say, for instance, you might have a bit of boot code you want to circumvent. You could introduce a glitch right before the execution of the boot code, and then skip over that boot code, so it will continue operating without, for instance, certain security checks. This is to make sure that you can even use MCUs that are locked down by the prior user or the manufacturer.
Okay, thank you. Very precise. I saw someone from the Reunion that told you, say, you had a creative use of the TLD. Reunion is on the French ancient colony. It's an island in the Caribbean Sea. I guess you are aiming your work to the South countries.
Yes, we are currently joining an alliance that focuses on reducing e-waste in the global south. And these tools are obviously simple, as you probably have seen. They are designed to be easily produced and easily used, regardless of the situations people's labs are in. And they're aimed to be used, for instance, also in developing countries. So people in developing countries that have an excess of e-waste and have labs can start experimenting with repurposing e-waste using our tools in order to reimagine what e-waste actually is.
Great. We don't have much questions anymore. What? Please ask questions in the room. Well, I actually enjoyed a lot your talk, since I'm definitely not in electronics, but it gave me a few ways to understand it. And maybe you decided to put me in electronics using your tools.
Great. If you send me some contact details, that counts for everybody in the stream. You can email them. And we also have a few of our tools available for free. Currently, our repository is kind of lagging. We would like to have all of the tools available in our repository today, but that will take a few days. So if you wait a few days, all of the tools, apart from the Oyster, will be available under the CERN OHL SV2 license. So we can also send you some prototypes if you'd like to play around with them.
I'd love to have them and bring them to Bolivia for helping.
Great.
Any more questions, please? I'm so sorry. I guess your talk was so self-explaining. Or yes, thank you. Which microcontroller units did you have a try at glitching re-ing code yet?
My main focus has been on on a whole range of STM32 microcontrollers, but also EFM32 microcontrollers specifically. Also because they're quite common in use and broadly used. So the main benefit for instance, the Oyster would be to target a microcontroller that is used widely within the field.
Great. I have another question here. Do you have any plans regarding processing of large amounts of e-waste at scale?
I'd like to start small. There are plans, but I would first like to make sure that if we address these things at scale, we usually communicate with other parties as well. And those other parties need to understand what is possible with e-waste first. So the start of the trajectory is this. We develop tools, we develop know-how, we try to document what we learn, and through that, we will hopefully get to interesting ideas and an interesting dialogue with the larger public and e-waste processors. Currently, a lot of e-waste is shredded simply, and we need to reverse that strategy by imagining new trajectories that waste streams can get into.
Great. And finally, what alliances are you joining to reduce e-waste?
We are joining the Prevent Waste Alliance, which is part of the German government. They're absolutely excellent. And so if you have a look, I'll post a link to their website and all of the projects they are doing.
Okay, it's soon stopping. There was another question. Maybe we'll answer it in the room. You can join soon.
Hey, sorry for that, and thank you, Wagner, for sending a lemon. Um, again, the hell happened here? My apologies. Um, I'm kind of dealing with a home issue right now. Don't worry, I am physically fine. Um, there's nothing physically wrong with me. I'm just running around trying to deal with everything in the apartment. So we're gonna watch a little bit of that about Java security, and then we're going to go into crowd security. We're going to go into open source book for security for compile developers, and then LLVM, right? And then we're going to go into crowd security. And as soon as I am done here, I will turn the camera back on, probably more closer to like 9:30 to 10. But I'm gonna try to get that done, everybody. So just be patient, and the mug will reappear. And again, everything's kind of crazy right now. I'm pretty sure tomorrow's stream is going to go a lot more smoother than what's going on right now. But thank you for everyone who's been putting up with us, and thank you, Wagner, Sura, for donating a lemon. And if you are interested in donating some dollars out there, again, we are still trying to raise money for the Children's Miracle Network Hospital. We are currently at $308. We're still trying to hit that $600 goal. But again, that's more of a goal. Regardless, all the money donated so far and in the next 2 days will be donated to various pediatric centers and hospitals across America through Children's Miracle Network Hospital, including the my brain just died, including the Children's Specialized Hospital, in which there's 14 of them in New Jersey. So this donation has a direct impact on us. We're handling it through Tiltify, which is a reputable third-party company, and we have a widget um, on Twitch. If you're interested in donating, even if it's just $1 or $5, that means a lot. That's how we got to $350. $308 in the first place. The QR code also can go on your phone directly to the website where you can donate through Tiltify or a third-party reputable company. And then finally, once again, I just posted the link in chat again. Wagner, thank you for sending us a lemon. We very much appreciate that. And let's look a little bit about LL's SoftSec book, an open source book on software security for compile developers. And then we're going to get directly into crowd security. So let's go. Gonna play a little bit of music. It starts up in a couple of minutes. Actually, sorry, we're gonna go for the other security thing. We're gonna bounce back. Let's look at see what Java security is real quick, and then we'll go for the logbook stuff. Sorry about that. Again, my apologies for not being on cam more often. This always happens in the multi-part day. It's always the first day. Everything happens in this this our crazy streaming stuff, and then like the next day or so, when the rest of the days happen. Okay, that already ended. Um, everything ends up working. I have no idea why that's the way it is. Um, oh, it's actually time now. So, let's go check this out. Let's go do this here. Let me just set up the next talk real quick. Let me set up the next couple of ones. Just so that we could just go right to them when they happen. And finally, and there we go. I think we have this all set here. So again, we're going to, the future is going to be crowd security, old web today, keeping Flash and other retro websites accessible on the modern web. And then we're going to end with status of camera support on mobile FOSS devices. And finally, a very short thing on people pitching their open source projects. And I think that's a nice way to round things off, but let's finish up by again checking LL's SoftSec book. So we should have video now. Here we go. Enjoy. And as soon as I get the camera working, the camera's fine. It's just as soon as I get everything sorted out here, I will turn the camera back on. We'll watch the rest of this. So thank you for being patient out there. I really appreciate it.
Let me start with summarizing the key aspects of this new open source project. I'll then go into more detail in the following slides. The aim of this project is to create a book to educate compiler developers on all aspects of software security relevant to them. We do hope that the book will also be of interest to other developers working on system software. The reason we decided to start this project is that as compiler developers, we see that in recent times we end up working more on security-related aspects. While working on those, at least some of us feel we could use deeper expertise from time to time. After having looked around, it seems there is no great educational material available specifically for compiler developers, so we thought it would be a good idea to try and create such material. We also thought it would be good to create it as an open source project. By enabling more experts to contribute and by making it freely available, we hope we can multiply the positive impact this book can have. The status is that we really just started this project. Some initial pieces of content are written, but probably more than 90% of the content still needs to be written. Maybe the main reason I'm talking about the project today at this early stage of development is that we are looking for help. We welcome help in the form of reviewing existing or new content, suggestions for improvements, and new pieces of original content. In the end, our goal with this open source book is to make compilers better. More specifically, we hope that this book will help raise the security-related expertise with many compiler developers. In turn, we hope that will result in better implemented security features and in fewer attacks succeeding in breaking hardening features. Let me go into a bit more detail on the reasons why we started this open source book. We've observed that many of our compiler developer colleagues more often work on security-related features than in the past. We also observe that from time to time we're missing some deeper insights into how hardening features do block attackers both in theory and in practice. Or at least sometimes we feel we don't have enough background insights to be sure enough about the design and implementation trade-offs we're making when implementing security features. This seems to be true not only at the company I work for, but across the industry. In some cases, it may be that there simply isn't any theory or enough practical understanding by anyone to be fully comfortable about a particular design decision. But in many cases, we probably could make more informed design decisions if the collective knowledge about security aspects of code generation were more easily available. After looking around, we did not find great educational material to help us overcome the lack of expertise. We did find a lot of detailed descriptions of how a specific exploit manages to work around a hardening feature implemented by a compiler, but we did not find much material that explains on how to think about a class of exploits or how a particular code generation strategy may affect the probability of success for a class of exploits. More than a year ago, I thought I'd just write up what I thought was relevant for myself, and I initially thought it could fit on a few pages. but I quickly realized there was probably on the order of 100 pages to be written, even when sticking to essentials. I also realized that by trying to write up an easy-to-understand description of what I thought I knew, there were gaps in my knowledge in the details. So, trying to write up how classes of exploits work and how to mitigate against them helps me to understand the issues better. I believe that is called the Feynman technique to learn something. I do believe it's worth creating a book describing what compiler developers should know about security aspects of code generation. First, as already said, compiler engineers are working more and more on security-related features. Secondly, by making the book publicly available, rather than just write something up for myself or my close colleagues, it can have a much wider impact. Thirdly, by making the book not only public, but also open source, we can get input from other experts more easily. That can make the book only better. I also hope that by creating one more forum where experts can discuss publicly, it could also help a bit to further strengthen the community of low-level software security experts. While the book is focused on compiler developers as the target audience, I expect that many of the topics covered will also be interesting to other system software developers such as firmware or kernel developers. To make it as easy as possible both to contribute to the book and to consume it, we thought the most recent Creative Commons Attributions license was best suited for this book. It's also known as the CC BY 4.0 license. We've created the project on GitHub a few months ago. The URL for it is github.com/llsoftsec/llsoftsecbook. Since then, my initial focus was on implementing the basic build system for the book. The book is written in Markdown. Pandoc is being used to convert that Markdown source to both an HTML and a PDF version. Continuous integration has been set up to check that the book builds correctly on every pull request and commit. A live copy of the latest version of the book is automatically published as a GitHub Pages page at the URL shown at the top of the slide, llsoftsec.github.io/llsoftsecbook. The majority of the chapter content and sections still needs to be written. We expect that as we write more content, we may discover that it will be best to make some changes to the overall structure of the book. As of now, the book has the following structure. It starts with an introductory chapter. Then there's a chapter on everything related to memory vulnerabilities, such as buffer overflows, ROP, JOP, DOP attacks, and how the various classes of mitigations work to block those exploits. The third chapter aims to describe how covert and side channels work, with the next two chapters then covering attacks making use of side channels. I've decided to split this into two chapters, one for side channels where the attacker needs physical access to the system, and one where the attacker does not need physical access. A sixth chapter covers supply chain attacks, which have been in the news a lot recently. And then there's a chapter for all other relevant topics that do not fit the other chapters and may not need a full chapter on their own. I hope that in the past few minutes I managed to explain why we believe we need to write a book on software security for compiler engineers. The project is currently in an early phase of development and we're looking for help. You could help in various ways, which include, but are not limited to, sharing your ideas for new content, sharing your ideas on any other way the book could be improved, reviewing existing and new content, writing new content, and sharing this project and talking about this with everyone you think could be interested in it. Some ways you can reach out are by raising a GitHub issue, raising a pull request, or starting a discussion thread. You can also reach out to me personally at the email on the slide. I hope I convinced you of the usefulness of the project, and I'm looking forward to hearing your feedback. Thank you for listening. Thank you for listening.
Okay, I think we're live. Yeah, very nice. I hope you enjoyed the video just now. And we do have Christoph with me right here. If any of you have any questions, please feel free to type in the message box below. And yeah, and perhaps just to get us started, Christoph, if you want to just expand a little bit about the GitHub page and what are some of the where do you see the future of this textbook sort of in the long term view?
Right. So, my thoughts on creating this is basically me myself. I want to learn more about how to, as a compiler writer, know all the things I should know about security. I know a thing or two, but not all the things. And so that's why I'm really motivated to create this open source project. And so what's there right now is like the framework for a book with a few pieces of content filled in. And me and a few other people I work with were writing some pieces bit by bit still. So probably I'm expecting in the coming week 1 or 2 more pieces to be up for review. But we really can, so it's not set in stone what the best structure for this book is. We're having a incremental development process, so to speak. And so as we write, maybe we discover that there's new pieces of content that we need to write, or maybe we should structure it a bit differently, and then it's easier to have a nice structure that you can keep in your head about all aspects of security that the compiler writer should know about. I can say that already. For example, we now have the start of a chapter on supply chain attacks. Like in the very first version that was on GitHub, that wasn't there. That was someone else working in compilers, working on supply chain attacks, suggesting, hey, maybe that should be added. And so basically, we're looking for help from anyone to contribute ideas on what should be there, ideas on what can be improved in the book, how the structure could be improved, even just reviewing what's there. Probably as you can all hear, I'm not a native English speaker, so I'm very sure that everything I write, even just grammatically, there are things that could be improved. So all of that is very welcome.
Cool. Awesome. We do have a question asking about, is there a rough timeline for this project? And when do you see are there milestones you've planned, or others? What do we call like a finish, for example?
Right. So I'm not going to put any dates on it. So like a true open source project, this is based on how much time people have available to contribute. I am reserving some of my time to make sure that we get the ball rolling. And then there's 1 or 2 more people currently reserving some of their time to get the ball really rolling. And personally, I think it would be awesome if by next year we would have a first draft of the basics of everything that we should mention are in there. That would be awesome. But it boils down to the more contributors, reviewers, people filing bug reports or ideas for improvements. It boils down to, will there be enough people helping with that? So that will be the thing that mainly determines how quickly we progress.
Right. Yes, another question we have is, what would be the advice for different compiler engineers working on different parts or sections of the book? Are they mostly going to be different, or can they write parts of the book and then will be similar type of things they write for another part, or is there anything they should know before they dive into the book itself?
Yeah, it's an interesting question. I hadn't thought about a front-end engineer or a back-end engineer. Should they think differently about security, or should different parts of the book be interesting to them? It might be I'm trying to think out loud. I'm guessing that things like cache side channels might be more interesting to back-end engineers, because to mitigate that, you work more closely the individual instructions. But then some other parts might be more relevant to front-end engineers. Like the example for supply chain attacks, maybe I'm guessing that maybe that's well, it's probably relevant to all compiler engineers, but they may be specifically relevant to maybe whoever is managing the development of a tool chain and everything around that, and that kind of thing. So I do think that the different sections of, well, I would expect that there will be some contents that will be relevant for no matter exactly where your expertise is in developing a compiler.
Cool. And yeah, what about in terms of sort of the use of this book in the long run, or maybe after it's finished, or perhaps while it's almost finished? Where do you see, because it's open source, then where do you see the majority of the users will be, and what sort of impact will it have?
Well, so with this open source project really being at the start, I can only dream for like what's the maximum impact this book could have. Like in my wildest dreams, this becomes like a standard textbook for students studying security and system software. That's in my wildest dreams. So even if that doesn't become reality, and if this just becomes like a really good resource for compiler developers that need to know about security, then I think the project is already wildly successful if we achieve that. I do think that the book probably will never be actually finished. Like new security aspects get discovered pretty quickly. So I do think that's important that there is live, like, so I talked about there being a live version. I do expect that the live version will be like the most up-to-date, the most valuable version. At the same time, I do expect that at some point we will get to the point where we think like we've given a basic description of like the main concept that we think everyone should know about. It's been reviewed by quite a few different people. Those parts are getting stable. Maybe at that point we can like have a 1.0 release or something like that. But I haven't really thought about that. At the moment, my main focus is on let's get development of the book going, let's get that going well. And really, I don't expect that there will be an endpoint as new security-related insights do pop up all the time.
Right, absolutely. And what about in terms of the sort of the actual content of the book? What do you think would be sort of the general sort of structure or content of the book look like? Is it going to be is it important, for example, for certain definitions to be laid out as an introduction, and then sort of followed by maybe some examples or exploring some of the most recent security updates and security knowledge?
I don't think like there's one structure that will definitely be better than a whole number of other structures for the book. And so what we have right now is just one way of organizing stuff. So basically right now it's something along the lines of memory vulnerabilities, a huge category of security issues that compilers have a role to play in. And then there's side channel attacks, also a huge area compilers have a role to play in. And then a number of other attacks. We also have discussed like what's the amount of knowledge that we can assume a reader to have, like what should we start explaining, and that's like it's not set in stone exactly where we should draw the boundary. So actually right now I'm writing a part for cache side channel attacks. So for example, I'm planning to actually write like what's the basic structure of a cache. There are some cache sets, there's associativity, this is how it works, because you need to know the details of how that works to understand like how could you make an exploit like this work, and then you have to know that to know how could the mitigation work. And so I think we will assume some basic computer science knowledge background. But yeah, it also depends on feedback. So basically, we welcome very much feedback. What readers say, oh, we could use more detailed information here, or actually this whole section seems to be too basic to me that everyone knows that. You can remove that or just put it in an appendix or something like that.
Right. Okay, I think we've got about 3 minutes. Are there any additional questions from the audience? Feel free to type them in the chat. Is there anything else you would like to share, Christopher? Maybe about sort of during the, I assume, of course, this is perhaps not the first day that you've thought about this book. You probably have thought about it for very long. What are some of the, are there any sort of interesting things that, is it, well, I guess, I mean, one thing I could ask is the book that we see right now the same as sort of when you thought of it the first time? Like, has anything changed so far? Or like, because I can imagine with so many technology updates that there must be changes all the time.
So I started thinking about this about a year ago, and I wasn't even thinking about an open source project or even thinking about the book. I just thought like, oh yeah, I get a lot of security related compiler security related questions, and every time I have to like do a context switch in my head, and I wanted to have a bit more structure and write it up. And I thought, oh, you know what? Everything that's related to security and compilers, I'll just write it up very briefly on a few pages, and then like have a taxonomy of it, and then that's for me that will make it easier to understand. And then as I started writing, when I just started writing something about cache side channel attacks, I quickly ended up with 10 pages, and that's when I realized, okay, I won't be able to come up with a summary in a few pages. This is turning into a book. And then the idea developed for, maybe I should make this an open source book. And so that's how the idea developed in the past year.
Oh yeah, that sounds very interesting. Yeah, we got about just around 1 minute left. Let's see if the crowd has any more questions. If not, I'll probably leave some last words to you to give a quick summary.
All right. Well, if there are no further questions, so yeah, in summary, if you think there is value in creating a book that summarizes like the key aspect, the key security and compiler related aspects that engineers should know about, then please do provide feedback. That's very valuable to us, the few people that are currently contributing to the book. If you want to contribute yourself, you can do that by reviewing, you can do that by sharing IDs, just leave it an issue on the GitHub page in the issue tracker, or reach out to us in any other way. If you want to write content for a specific topic, that's very welcome also. Again, please do reach out to us so that we don't have multiple people not knowing about each other writing the same content. So yeah, this is really the start of the project, and we very much welcome any and all feedback. And if you think this idea is interesting, do share it with everyone you know who might also be interested. Thank you for listening, everyone.
Cool.
Have a great day.
Yeah, thank you very much.
Just want to reiterate here the hi out there, because we just got a message, as I guess people are finally waking up. Hello out there, Pony Lover. We are, God, that username. I'm right now just dealing with some home stuff, so I don't have the camera on yet, but I'm hoping that within the next half hour, maybe even sooner, we can get the camera back on. But as they say in the showbiz world, the show must go on. So up next is, just as a highlight for the rest of our schedule, is crowd security. And then we're going to look at how to archive retro websites, the stuff like archive.org does. And then we're going to end it with the status and issues with using camera support for FOSS software on mobile devices. And then watch people pitch their projects, their free and open source projects on here. So again, as soon as I'm able to get the camera back on, I will turn it back on. But let's keep it going. Let's check out this interesting piece. It's going to be about an hour long. I hope to get on the camera before that on crowdsourcing approach to different defense problems. As I say here, by distributing free and open source software, allowing you to protect yourself and share information about relevant actors. So this is like kind of like a reporting platform for people who develop. Basically, this is like DevSec. So this is going to be really neat. Let's do this, and then hopefully I'll be finished up here. Again, I'm sorry. Tomorrow's stream, I will pretty much be on the entire time with the camera, and we'll start on time and everything. It's always these. Whenever we do multiple days, it's always that first day that's screwy. So here we go. And just as a quick reminder, we are trying to raise money for the Children's Miracle Network hospitals. I'm putting the link again in chat if you want to donate $1 or $5. The QR code also works, and if you're on Twitch, we also have a widget for that. And when you donate, I see you donate, and we cheer you on. Right now, Fee1 Dead is still good with his 69 nice dollars. Can anyone knock him off the leaderboard? Let's find out. Enjoy, you guys.
Exploit is most of the time a lot shorter than the delay between publication of this vulnerability and the application of patches on all live systems. After all, Log4j has been a great example. While within a day you have been seeing proof of concept and functional exploits popping all around and the internet being scanned, weeks later some admins are still fighting with the application of patches on those same legacy systems. Second of all, the perimeter. While not even mentioning the current sanitary crisis and the multiplication of VPNs, let's say that most modern architectures are challenging the security of the perimeter. Public cloud, serverless architectures, Kubernetes, containers, SaaS, you name it. The firewalls that has been sitting protecting the whole network is something that is now more and more difficult. And it becomes even more difficult to have a very even security level across the perimeter. And last but not least, money. Hackers are using stolen services, and mostly free tools. But the people defending needs to throw money at licenses, salaries, and so on. So defending is a lot more costly than attacking is. So the castle strategy is something that is gone and very likely never coming back. However, the good news is that there are a lot more people trying to run IT systems and perform productions than there are people trying to attack. And we hope that joining force together is going to outweigh the attacker. We do believe that by allowing people to run free and open source software to protect their infrastructure while sharing information about the attacks that they are seeing, we are going to significantly reduce the problem. And this is how we intend to deal with this problem, by distributing free and open source software that acts as an IDS, IPS that allows people to protect their infrastructure or IT systems while contributing to a global reputation system. That is, if people do not decide to disable it. When they are detecting and blocking attacks with open source software, they are then going to share with the community the IP that they just blocked, the scenario for which they blocked it, and the timestamp. This information is going to be reprocessed on our side mostly to deal with false positive and poisonings, and then being shared back to the community, so that the bigger the network, the more information the user is going to be able to share with each other. More concretely, it means that we are distributing back to the users the list of IPs that are being synced at attacking every machine on the internet so that they can preemptively block them and protect their infrastructure from those attackers. So now about the software itself. Some of you may see some similarities with fail2ban. CrowdSec is going to detect attacks from logs. And when we speak about logs, it can be things as simple as logs from your web server or your SSH server. But here when we speak about logs, we mean actually more or less any stream of information in which we are going to be able to detect some behaviors and take some actions. So it can be log files, it can be CloudTrail from AWS or Kinesis, it can be journald, it can be your Docker logs, it can be logs from Kubernetes. So really any kind of stream of information. And then those logs, they are going to be normalized and enriched before being matched against scenarios. Here, when we speak about enrichment, it can be things as simple as geolocalization enrichment, for example. And then a scenario is a description of a misbehavior that we want to detect and potentially block. And this is where the community aspect starts to kick in, is that besides the fact that the software itself is open source, all those parsers, scenarios, and enrichment plugins, they are part of a hub, a bit like a Ansible Galaxy or Docker Hub, that are actually GitHub repositories that are hence very open to contribution and suggestion by the community. So at this point, your logs have been normalized, enriched, and then you match them against scenario, and you have detected the behaviors that you want to stop. For example, IP1234 is performing a brute force on your website. Then, when it comes to reaction, we start to be quite opinionated. The thing is that, first of all, we do believe that you do not detect and react at the same place. And then, second of all, the way you react to an attack really depends on your environment. For example, if you are dealing with mail servers, you might be okay with banning huge parts of the internet from your mail server. On the other hand, if you say the same thing to a person that is running an e-commerce website, it's going to be extremely frightening for them because every false positive might be a loss of business. So you want to allow the user to react how he intends to and how he wants to a given attack. For example, the guy running the mail servers might be okay banning a lot of IPs directly on his firewalls, while the guy running an e-commerce website might prefer to leverage his CDN service to inject CAPTCHAs or JavaScript challenges to the potential malevolent users and simply try to fend off the bots. Or in a more corporate environment, some people might want to, instead of trying to deal with the source, reinforce the security of the target. And maybe in the case of a very distributed brute force attack, you might want to increase the security of the targeted account by enabling multi-factor authentication or locking out the potential compromised accounts. So anyway, my point here is that you detect in one place, you react in another, and how you react can really depend on your context and your technical stack. And last but not least, and this is a bit one of the main key points here of the project, is that once you have detected and blocked an attack using the open source software, unless you decide to disable it, you are going to share with the community the IP that you just blocked, the scenario for which you block it, and the timestamp. This information is then going to be processed by us and share back to the community in terms of block lists that are automatically pulled by the software and deployed on your IPS systems. So that people are going to have their instance permanently fed with lists of IPs that are very likely to attack them based on their past behaviors and the attacks that they have been performing in the past. And now, what exactly are we supposed to be able to detect with CrowdSec? First and foremost, CrowdSec doesn't intend or pretend to protect you from 0 days, APTs, 3-letter agencies, and so on. But it's more intended as a general cybersec hygiene software that should have very low false positive, low technical entry barrier. And as such, is intended to protect you from most of the background noise that you are going to see. Scanning from the latest vulnerability, some brute forces here and there, general vulnerability scanning, and so on. And while out of the box the software intends to mostly provide this kind of cybersec general hygiene, we have seen some users successfully use it to deal with more complex attacks. Given the transparency of the software and the grammar that is allowed by parsers and the way scenarios works, you can as well use it to deal with more complex attacks. A typical example is that we have seen great success into fighting level 7 DDoS attacks from very distributed botnets, or as well to use it to deal with more, let's say, business-related issues such as credit card stuffing or credential stuffing, or even some people very successfully using it to deal and detect with bots in the case of scalping and scrapping. And this is one of the great side effects of CrowdSec, is that by detecting enough of the background noise, we can then filter it out and try to identify more targeted attacks. Here, when we speak about open source, we mean that the agent, so the component in charge of reading logs and detecting attacks and so on, the bouncers, which are the components in charge of reacting to a detected attack, the parsers and the scenarios are all under MIT license. And while this license is rather permissive, a question frequently arises of how do we intend to live and survive as a company, because we are not simply hobbyists. Here the thing is that we try to be as transparent as possible on the fact that for us, this software, the open source software, CrowdSec itself, is a mean and not the end. Our endgame target here is really to be able to monetize the access to the CTI for people that do not want to contribute it. That the data that are contributed by the community and shared back in part with the community can as well be monetized for people that are not willing to share any kind of information or access it in a very large way. Before jumping into a demo, let's have a look at CrowdSec architecture. CrowdSec is made of a few components. One of the main components is what we call the agent. The agent is in charge of doing the heavy lifting. It's reading the logs, parsing them, enriching them, and matching them against scenario. He's the one that is going to produce alerts that are going to say, for example, IP1234 performed attack XYZ on my machine. And then this alert is going to be sent to what we call the local API. This alert is going to be sent to the local API using HP REST API. And this local API is in charge itself of converting an alert into a decision based on the user's profile and configuration. This is with the local API that the CSCLI, which is a CLI tool we are going to see during the demo, is going to interact. And this is as well this component, the local API that we often call API, that is going to push information to the central API and get back from the central API the community block list. And it's as well from this local API that the bouncers, so the component in charge of reacting against an attack, are going to be fed. We have two types of bouncers. Bouncers that are, as we say, in rupture mode. So whenever the CNIPs they don't know are going to ask the local API whether they should let it pass, block it, present a captcha, and so on. And other bouncers that are in polling mode, which means that they are polling from the local API on a regular basis to get the list of IPs that should be banned, the list of IPs that should be unbanned, and so on. So these are the main components of CrowdSec. And now, without any further ado, let's jump into a demo, as it's often worth 1,000 slides. Let's install CrowdSec on a very standard Linux machine. Here we are going to follow the documentation, and as we see, we are distributing our own package for most of the Linux-based distributions, while being integrated upstream into some. Distributing our own package allows to have a very fresh package all the time. So once we edit the repo, we can install the package. As we said earlier, we try to have as low as possible technical barrier when using CrowdSec. And here we can see that the installer is going to detect the services that are running. So here my web server, SSH server in the Linux distribution, and as well install the associated collection. Here what we call a collection is an ensemble of coherent configurations that allows to cover a technical stack. So from the user point of view, the installation and the configuration of a minimal detection part is done. And we can have a look at CrowdSec logs and immediately start to fire an attack to our web server. Here we are going to use Nikto, which is a web application vulnerability scanner that has the advantage of having a very typical behavior of this kind of software. And we can see, we can stop the attack, but we can see already that our IP is being flagged for having performed a lot of attacks. You can see that we try to perform XSS probing, trying to exploit past traversal, access sensitive files, do aggressive crawl, non-static resource, and so on. And if we listen to CrowdSec, my IP, it's me here in Ireland, should be banned for 4 hours, lastly for having performed the HP probing attacks. However, if we go back from the attacker point of view, we can see that we are not blocked when trying to access a website. After all, and as we said earlier, CrowdSec is in charge of the detection while the bouncers are in charge of the remediation. So here what we are going to do is that we are going to pick a bouncer so that we can now add remediation to our existing setup. Here I'm picking the firewall bouncer for IP tables, which means that now when CrowdSec is going to block an attack, it's going to instruct the firewall to block it. And we can see that by simply installing this bouncer, I'm not banned from the machine. I cannot access it anymore. For the rest of the demo, of course, I'm going to unbind myself as it's going to be a lot more convenient. And so now if I try to access the website again, I can access it again as I unbind myself. What we are going to do for the further in the demo is that we are going to deploy a dashboard using CrowdSec. So here the dashboard is going to use Metabase and deploy it as a container so that we can have some observability on the attacks and the different things that CrowdSec detected. In the meanwhile, I wanted to speak a bit about bouncers. During the demo here we use the firewall bouncer. However, as I said earlier, the plan here is really to have decorrelation between detection and remediation. And so a lot of various bouncers are existing for the software. If I was using Cloudflare as a CDN, I could leverage Cloudflare as a bouncer, or I could even have it directly at the applicative level. For example, by having a bouncer directly within my Nginx web server, or even directly within the application by using the WordPress bouncer that actually acts as a WordPress plugin. Now that our dashboard is deployed, we can directly connect to it. So, of course, when we are going to connect to it, we are going to get some simple observability. But given that we just install the software, there's not much to be seen inside. But we are going to come back to this later. However, it's already giving us a nice observability of what is going on, the kind of attacks that are being blocked, and so on. One of the things that I want to showcase is the ability for CrowdSec to evolve. Here, as we are seeing, we are looking at the logs of our firewall, here IP tables. And it's indeed a very interesting piece of information and something that we could leverage from a security point of view. So what we are going to do is that we're going to try and find a collection that is relevant to this kind of logs so that we can use them and detect new things. So here I'm going to look at the IP tables collection. As we can see, the IP table collection contains logs for IP tables and a scenario to detect port scan. And to teach CrowdSec to detect port scans or similar things within IP tables log, I simply have to install this collection, again using CSCLI. And as you can see, it has actually added a parser for IP table logs and a scenario to detect port scan. And so now if I look at my log again and I go back from the attacker point of view, and I'm now, for example, performing, so I cannot access my website, and I'm now going to perform a port scan using Nmap to my machine, and I can see that my IP is now being picked for having performed web scan. So again, if we look at the decision, we are going to see that now my IP is being banned but for having performed port scan, and if we try to access to the machine again, we are banned and then we cannot access it. One other key point that I want to showcase here is that CrowdSec has the ability to deal with hot logs as it does with Sql logs. And let's imagine that I'm evaluating CrowdSec and I want to see whether it would have triggered some false positive based on my traffic or some false negatives. What I can do is that I can reuse here my old logs from 2019 and reprocess them again with CrowdSec, or tell CrowdSec these are my logs from Nginx type and please process them. And what CrowdSec is going to do is that it's going to reprocess these logs and emulate to tell you what it would have done if it was running in 2019 at that moment. And so instead of going to the previous months, I go to the past few years, excluding this year. I'm going to see here all the attacks from 2019 that are being reinjected into my database and all the various IPs being processed. So here, while the demo showcased CrowdSec running on a simple virtual machine running an Ubuntu-based environment, CrowdSec aims at being available in as many environments as possible in order to be able to fulfill our mission. We are already distributing packages for FreeBSD, most Linux-based flavors, OpenWRT. We are even working on a Windows port, for God's sake. And we're as well targeting self-use platforms instead of the virtual machines. We are distributing Helm charts for people running Kubernetes, Docker images. We even have proper integration into AWS for people that are doing serverless integration. We are targeting various application servers, load balancer, reverse proxies, traffic, Nginx, Lambda functions. And we're as well distributing various libraries for various technical stacks such as Python, PHP, JavaScript, and so on. And most importantly, here during the demo we showcased firewall bouncers that has limited capabilities, which is ban or ban. However, the more you go into the applicative layers, the more diverse can be your response to a given attack. For example, the applicative stack libraries for bouncers allow you to present as well captchas, as is soon going to be able to perform the Nginx bouncer. So here the possibilities are hopefully endless. As we said earlier, one of the key points of the project is our ability to process the signaling that has been sent by the user of all the blocked IPs and detected attacks in order to share them back automatically to the community. For this process to work correctly, we need to ensure high resilience against poisoning and false positive. I propose here that we walk a bit through this existing process. The thing is that we cannot prevent users from trying to poison the system. However, we can make it so that poisoning is so expensive and so complex to achieve that it's not a realistic course of attack for a potential attacker. So what happens is that all the users in the systems that are starting to send information are getting what we call a trust rank. Trust rank is a notation of how trustworthy the user is. And in order to make the poisoning process too complex, what we do is that first of all, your trust rank is going to start very low. And in time, it's going to slowly grow. What it means is that, for example, after 2 months of using software on a regular basis, we still do not know if you are ill-intentioned or if you are a legitimate user. However, if for 2 months you have been sending us information on a very regular basis, and you are the only one sending us information from a given IP, we know that at least you are spending some resources in order to provide information to the network, because you seem to be the owner of the public IP, and the fact that you send us information on a regular basis shows that you are at least investing some physical resources such as CPU and memory into the process. And then what is going to happen is that on the side, as we're running a network of honeypots. Honeypots are machines that are running simulated vulnerabilities so that they can get attacked by third parties. And what happens is that after a few months, as I said, your reputation is going to slowly go up. And then, for example, your reputation can continue to grow because you provide us some information that we're able to verify. For example, if you tell us that IP1234 has been performing SSH brute force and attacking your machine, and then later this information is being confirmed by a honeypot or one of our users with a stronger trust rank, your trust is going to continue to increase because you provided us an information that we have been able to later verify as being true. And again, we still do not know if you are well-intentioned or if you are malevolent, but at least we know that not only you are spending some resources, but as well you are running some real services and providing us some information that we're able to later verify. And so your reputation is going to continue to grow. When it comes to false positives themselves, this part is very majority shared with the open source part that as you might see if you look into the project, but we distribute whitelists to be able to avoid banning CDNs or SEO engines and so on. And so false positives are mostly dealt in this way. And in order to prevent poisoning, one could argue that, especially nowadays with public cloud, etc., malevolent user can throw a few $1,000s and get their hands on hundreds of EC2 instances or small machines using a hyperscaler or public cloud infrastructure. However, what happens is that one thing that is very hard to simulate is the diversity. Now with tens of thousands of users who have users based on in every country in a lot of different autonomous systems. And for an IP to be able to make it part of the consensus and so to start to be actually redistributed to the users of the community, not only we are going to look only at reports from users with a high enough trust rank, But more importantly, we are going to look at the diversity. We are going to wait, for example, for having the report from hundreds of users. But most importantly, we want these hundreds of users to be located in 50 or so different autonomous systems. Because while it's easy to throw money at a public cloud provider and get 100 of IP addresses to perform poisoning attack, achieving the same thing, having 100 IP addresses but that are spread across 10 or 50 different autonomous systems is going to be a lot more expensive for the user. And last but not least, considering that IP range is like an interval, we know that most attackers, or at least opportunistic attackers, are going to scan the address space as an interval. So the attacks that you as a user are going to see are going to be quite similar to the attacks that are being reported by your neighbors. And this is one more way that we can ensure the coherence of the information that has been sent by the user. And last but not least, you might very likely be aware of it, but most of the attacks come from a few autonomous systems, a few ranges, and most of the autonomous systems and most of the IP ranges existing on the internet are perfectly innocent. So an IP being reported that is part of a range that has never been reported before is going to be subjected to human validation before making it to the consensus and being redistributed to the community. So these are the main parts when it comes to, let's say, dealing with poisoning and false positive. But this is not our only target. One of the main things as well that we try to identify and fend off is being able to identify cohort behaviors. If you take the case of a botnet, for example, a botnet is going to be constituted by 1,000 or more machines and IP addresses that have, in appearance, no link between themselves at all. However, they are always going to attack in cohort because they are being controlled by one entity that is then going to later rent it to various customers and so on. And this is typically one of the things that we are working on, is being able to identify all these cohorts and being able to say these 10,000 machines that have from an external point of view, no link between them. Actually, they always attack together, so that if you see one IP starting to attack you, we can tell the user that he needs to block the other 10,000 IPs because they're going to come after him and the 10,000 machines are being controlled by a single user. And these are all the mechanisms that are put in place in order to ensure that we have a good resilience against false positive and poisoning before redistributing the list to the users of the And before concluding this presentation, I want to rehearse a few points. So first of all, CrowdStrike is not going to send your logs to us or to any third party. The only thing that is being sent, and you can opt out of it, is whenever you block an IP, you are going to send the IP address you blocked, the name of the scenario for which you blocked it, and the timestamp. These are the only information that is being sent to us, and because they are the only information that are relevant for us to achieve what we want to do, which is this global CTI. On the side, and in order for GDPR compliance and so on, we have what we call a progressive data degradation that is put in place. I'm not going to go into details here right now, but it's the fact that a report of an attack is something that loses a lot of interest within time, because most of the time an IP that is being malevolent at a given time is a legitimate machine that got breached, that is now being used for an attack, and one day or the other, the legitimate owner of the machine is going to be made aware that the machine is misbehaving, and then is going to clean up his mess and the machine is going to become good again. And this is the reason for which, for example, for us, after 3 months, the data of a given attack is less and less relevant and is going to be progressively degraded, first in terms of timestamp and then in terms of IP address and so on. And then a legitimate question is, how do we as a company intend to survive and make money, etc. Because as I said, and we want to be transparent that we're a company and not simply hobbyists, is that we intend to monetize the CTI part. People that want to very vastly access the data that we are collecting and that we are retreating. And that's why the software itself is open source and is under a very permissive license, because for us, the software is a mean and not the end target. Thank you very much for your time today and your attention. I hope you enjoyed the presentation. Feel free to find us and join us on Discord or via the documentation or via GitHub. And of course, I will be happy to answer any questions. Have a great day. Bye.
Okay, and we are now live for the Q&A, and we have about 30 minutes, up to 30 minutes for live Q&A, and we're looking for your questions. Please post them in the chat. And one thing, while we're waiting for questions, one thing I was wondering is about this whitelisting and predictive algorithms and reputations. How long have you been working on this? How many iterations did you do?
So the project started around 2 years ago, and we are now about a bit more than 15 people working on the topic.
Okay. And did you find things, or did you just had an initial model and then evolved on that, or did you need to rewrite that idea, or
yes,
or did you experiment?
So I would say the part that is currently truly evolving the most is how we are treating the data from the users. Because initially when we started the project, there were very few users. So we mostly rely on our honeypot network in order to be able to detect some reliable information. And now that we have reached, I think we have between 15 and 20,000 live installs, we are getting enough data that is so representative that we can truly change and pivot how we treat data and how we can redistribute back data to the community. So this is something that is, let's say, ever growing, and as well with the variety of the platforms that we're adding. For example, we added Kubernetes support recently. And as I tried to explain, we know that the main change is how we deal with false positive and poisoning, and with containers and Kubernetes and machines that pop and go out, then dealing with the reputation of the users becomes a lot more complex.
Okay, it sounds like you are growing with your challenges.
Yes.
Okay.
Definitely.
Very interesting. So there's a question in the chat. How does it compare with the commercial IDS solution?
Yes.
Do you have any comparative data?
To be honest, I wouldn't be able, because it really depends on which solution you are referring to. I think one of the main differences is that we don't, let's say, pretend that CrowdSec will out of the box prevent you against APT, 0 days, and very advanced attacks. It's more intended as out of the box as a good cybersec hygiene software. And then people that, as soon as they get their hands on and understand how it works, we have seen people using it to fight more technical or more complex issues, such as like a very distributed applicative denial of service and so on. But it's definitely not intended like a purely an EDR or something that does DPI and this kind of technologies.
Okay.
About the question about the Docker logs, so yes, it supports Docker logs natively, so as a data source. And currently we are supporting those data sources from like files, journalD, Docker. What else we have like as well, Kinesis and CloudTrail for those of us that are running on AWS. So now CrowdSec. Yes, so Oleg, I definitely agree. So we draw definitely some inspiration as well from fail to ban, and to be transparent, CrowdSec is as well something that we decide to create based on our previous experience. In the past, we're running like a managed hosting companies and having to deal with a lot of logs, etc. And of course, we experimented with fail to ban, but we found out that something missed, which is this distributed component. So, and when it comes about integrating fail to ban with CrowdSec, we have seen some people doing it. And the thing that we have been trying to be a bit in touch with fail to ban people, but I think they have maybe other priorities, but we have seen users doing it.
I think there was one question about this concern about the centralized database, or did you answer that?
Yes, yes, definitely. I think it's a great question. So, centralized database are like on a global scale. Yes, so yes, definitely, we're aware that it's concerns that people can have. So, first of all, one thing is that the whole sharing information and getting blacklist back from the central entity is something that people can disable. So you can use it just as if you want a modern or more advanced and decentralized fail to ban, first of all. And second of all, let's say that all the whitelists that the user can set up are going to precede any decision that is being fed back by the community. And last but not least, we have been asked several times about opening the central part, etc. The things that, as I was explaining to Alexander, we are still learning while we are growing and with new changes, etc. We hope that in the soon future, we can at least publish a white paper and maybe in the future open source the code, but even open sourcing the code and the things that if we were to do something truly decentralized, the technical challenge will be a lot bigger, and we are not ready yet to face this kind of challenge. So we pick the aspect of doing a centralized, let's say, processing of the data.
Yeah.
Is the data so? Yes.
I read a question for the video. So, is the database open for investigating my own IP address, for example, like SMTP blacklists? And is there something like a removal request?
Yes. So two things. So yes, actually, I didn't showcase this part because it's not open source, but it's let's say freemium. But we have a online console where people can view as well the data that they send from CrowdSec, and in this part you can as well access what we call the CTI. So you can look up an IP to say what the community says about it, whether it's malevolent. It's mostly intended for people that may be afraid of false positive or are uncertain about what to do about a given IP. And then when it comes to self-removal, yes, there's directly a self-removal form on the website itself so that people can ask to be removed from it. And it's something that is then processed manually. However, we are very cautious in the way in what IP we redistribute to the community. Like, as an example, I think that currently 1 to 2% of the IPs that we are seeing are actually redistributed to the community. So the chances that you end up in the blacklist is that you have really messed up. However, it's something that is here simply at least for compliance issues.
But if I would elaborate on that question a bit, so if I'm an internet service provider that has maybe a range of IP addresses, like a class whatever net, with lots of IP addresses, can I subscribe to a service to be notified?
So yeah, so it's something that we're working on. Let's say one-to-one with some people. We didn't create automate a service like this yet because we need to be able to show the ownership of the IP range of the autonomous system, etc. But it's definitely something that we're working on.
Oh, cool. Yeah. So let's see what other questions come up. Please, in the community, in the chat, ask some more questions. We still have time. Lots of time, actually. On the other hand, if you want, you can elaborate on a topic that's dear to you.
Yeah, sure. What I can elaborate a bit is because I feel it's always a concern, like how we are dealing, with reports from the community and how we are dealing with false positive, etc. So as I explained, we give, let's say, individual reputation to all the users. And once users have reached enough trust, they can participate, let's say, in voting. And we are very conscious that nowadays with public cloud and hyperscalers, motivated attacker can get their hands on hundreds of IP addresses. However, what is, first of all, more difficult is to get your hands on hundreds of IPs across many autonomous systems, because this is what we qualify as diversity, and to do it in the long time. And on the other hand, we now reach to a point where the network is strong enough to be efficient. Typically, when Log4j came out now a month ago or so, we were able, within a few hours, actually 2-3 hours, to identify more than 1,000 IPs that were actively scanning very early the internet for this kind of vulnerability and to share it back with the community. And we have heard from some of our users that knew they had some vulnerable machines and services exposed that managed to, let's say, dodge a bullet simply because having the community blacklist, it's not going to protect you from a deterministic attackers that is targeting you specifically, but at least it might avoid, getting hacked by a very opportunistic attacker.
And then Oleg describes that somebody might block, or that if the list is used at very many places, you might get blocked by getting on this block list, but as a kind of censorship.
Yeah, it's definitely a concern, but simply that making it truly decentralized would have makes a problem, let's say, lot complex, and we're already having enough challenge to deal with it in this way. And yes, for Oleg and Klaus about the self-removal, yes, as I said, there is removal forms that you can find directly on the website, so that it's accessible to everybody.
And Anthony asks if the database is hidden.
I'm not sure to understand what the database hidden means. So what I can say is that about the softwares that people have, all the IPs that they receive from the community, etc., they can see it directly. It's by default, it's a SQLite database, but you can use PostgreSQL or MySQL typically. And about, let's say, the community database, the things that, as I said, now you can start to access some of what we call the CTI part by querying to know. Actually, maybe I can even show one. Wait, can I share my screen? Or
yes, you can. That should be possible.
Yes, I'm going to share. Okay, so here, for example, if you're asking, yes, should show. I'm showing like my console, and typically about, for example, this IP that attacked me, and I can see what the community is going to tell me about it, what kind of things. So this is what I meant by, yes, you can access reputation information, and currently it's really like intended to be consumed by humans, and in the soon future we are going to have as well, REST API, so that people can integrate it more into automated systems. And so yes, Anthony, the database is local to the agent. And I want to state that you can completely, disable any kind of online dependencies that you might have. You can simply use the software as a super fail to ban if you prefer.
Yes, so I think we again answered all the questions that there have been from the community for now. And let's see if there are some more questions. Otherwise, we might need to finish Q&A early. Maybe that's not something the community wants, so keep the questions flowing. So there are lots of thank yous in the chat. Can I configure this to all my machines what an IP they detected?
Yes, yes, Vic, definitely. Actually, the thing is that all the decisions that are taken locally whenever you detect an attack are done independently of the central database. The central database is simply here so that once a lot of people have reported an IP as being malevolent, it's going to be shared with everyone. But like when I showed during the demo performing brute force or web vulnerability scans and so on, all these decisions are taken locally, completely independently of the central database, and the communication in the central database is something that is more asynchronous or out of band, if you want.
So how long would it take to detect such an attack, or to notify the other local machines? Is it a thing of seconds or minutes? Or?
So actually, it will be like more around like between, let's say, if an IP is extremely active and is attacking enough people with good reputation, as we have seen like during Log4j, is between, let's say, half an hour, 1 hour for IPs to start to be shared back to the community.
And okay, so it's half an hour for the community, but how fast will it then be on a local site?
Then it's like instant, less than a second or so.
Oh, okay, that's very fast. That's good. Is it possible to run the service independently? Let's say have a couple of widespread servers. Yeah.
Yes, Klaus, it's definitely something that is possible. We have people that either run like let's say a more centralized setup, because as I showed during the presentation, most of the components are speaking through API. So either you do a more, let's say, central setup, but you can as well run a lot of independent CrowdSec instances of your machines without having them communicate together. And so you can use it only to protect yourself without any contribution to the central database. Then the only trade-off is that in exchange, you are not going to receive block lists neither.
So but when I have lots of nodes collecting data locally, and maybe I missed it in the talk, did they then communicate securely even over wide area networks? Is it then TLS?
Yes, maybe I can show quickly this. Here. So what happens is that, as I'm showing on the document, so CrowdSec is made of various components. There's the agent that does, let's say, the heavy lifting, reading the logs, etc., parsing, matching against scenarios, and then it sends the alert to the local API. So if you set up, you can either set up a lot of very independent CrowdSec instances that don't speak to each other, etc., or you can have, for example, agents that are running on a lot of machines and then sending all the alerts to the same local API so that your decisions are then applied like across the perimeter. So here the intent is we like to, let's say, we do not want to force the user to have a specific setup, but simply provide the components independently, like the bouncers, the agent, and the local API that are speaking through API, so that people can do either very small setup independent or something very centralized. We have as well, for example, people that are simply running CrowdSec on their central syslog services, and then having the firewall bouncer only on the frontal firewall of the network. Dagos was asking, in this case, offline without community, what will my multiple machines share informations? So yes, they will share the information as long as I'm using the same local API. You can see what we call the local API as a way to make your machines communicate even together, even if you are not contributing to the central database.
So we have about another 10 minutes almost. Time for more questions. So if you want to quit the Q&A session, you're free to do that. Or if you want to continue, it's your choice.
Sure. I'm going to leave it here, and I will keep an eye on the chat in case people want to join. And as always, so you can either join us who have a Discord and discourse, etc., to interact with the community. So if you have any questions afterwards, please don't hesitate to join, and we'll be happy to see you. On this, thank you all for your time and your attention, and I wish you a great FOSDEM. Thank you very much. Bye-bye.
Yes.
Welcome, everybody, to yet another automation talk. And you may be wondering, what makes this session special? There is nothing special on this session apart from the topic. Today, we are going to try to understand how IT network operations can be automated in 2020. The approach for the session is going to start giving you a good understanding of what is IP network automation and share with you a framework that can be used as a reference in order to put the different pieces that are part of this ecosystem together, highlighting what are the challenges and the trends that we are facing today, and everything with the focus on open source projects that can help us on this journey. First, the presenters, we have Mr. Damien Garros, Director of Architecture and Network to Code, and myself, Christian Adey, also part of the architecture team and Network to Code. Network to Code, for who is not familiar with the company, is a small consulting company only focused on network automation, building almost everything that we do around open source projects, doing a lot of contributions and trying to bring all this power into the different solutions that we are working on. For today, let's start first understanding what are the different components of a network. Traditionally, when we think on networking, we have to focus first on the control plane. Control plane has been typically the plane where you interact with the network, configuring the different routing protocols such as OSPF, BGP, and others. So it's the plane that is focused on defining how the packets will be forwarded. But the actual forwarding happens at the data plane. Here, traditionally, this has been a closed environment that you don't have access if it's not through the control plane. But since the rise of SDN, we are going to talk about this later, but we open the door just to decouple these different planes so we can currently today program this plane directly via OpenFlow, P4, or other languages, protocols that give us access to this plane. However, either controlling or data plane, both of them have to be managed. And the focus for today, for this session, is to understand how us, from the management plane, we can do the best on the control and the data plane. Let's start first understanding what it looks like on the traditional network management. Networking has been, and still is in part of a really close vendor ecosystem where the operating systems are basically proprietary. So you have your operating system with your private CLI, the command line interface. Usually these interfaces, because it was not actually needed, are using unstructured data, making the configuration more an art than an actual science and making automation really difficult. So this was the reason to promote and to sustain manual changes. And this has been like this for decades. What's changing today? We have some drivers that from the last 20 years have been appearing at different pace, but are transforming completely this ecosystem. First driver was a complaint from the network operators. In 2002, they published RFC 3535, where they were asking about a different way of managing the network. They were asking about data model management, so they could provide end-to-end services in a more smart way, instead of using a CLI-based interaction. Part of this, you will be aware that the rise of cloud scale environments, so big deployments for data centers to sustain the cloud and other big scale networks, promote that you cannot scale the operations of this network as usual. You cannot do the same that you have been doing until that point. So you need to put automation in place. You have to save time from the operators and make better and smarter decisions on how you manage this network. Also in 2009, with the rise of SDN, that even was not today a full reality of the vision that they promote, has transformed, has changed the way that we innovate into the network. Open the door for the hardware disaggregation, understanding something is the control plane, something is the data plane, so you can play in a different games with the different planes. And this opened a lot of innovation around how we automate and how we manage the networks. Also, this was the reason for the late years to appear network operating systems that were not closed. They were based on Linux, so making this ecosystem closer to the traditional server environments. And last but not least, the transformation about how we not only operate the network, how we manage applications, how we manage systems. Today, the DevOps culture that we put together developers and operations include also not only the systems, but also the storage and the networking, made that everyone is used to work as everything as a service, working on hybrid environments, on premises, in the cloud, and making the deployment time really, really fast. You cannot follow this trend if you are not automating your network operations. If we think about what is the actual adoption today, and using this diagram from Crossing the Chasm, makes like as a reference to understand how we are today. If we think about 10 years ago, there were some innovators doing research on the area, thinking about potential use cases. Because of the cloud service providers, they needed this kind of solution. They started investing and developing the first ideas about this. There were also some pioneers on the field, but the point today is that there is already a lot of companies that are doing this kind of operation. They are transforming the way that they handle networking. But we are still in front of a big revolution. We expect from our experience with the industry that in the next 1 to 3 years, a lot of new companies will start adopting this, because networking is still behind the automation, the DevOps culture that is pushing hard from the applications and system engineering side of things. The question was that sometimes you can understand like automation like an abstract thing. You don't fully understand what are the use cases that are real use cases, because at the end, automation, network automation today is automating the tasks that are already real, and you move this into a part where you still do the same, maybe better, but in an automated way. Here there are just a bunch of examples, it's not an exhaustive list, but for instance, for you to get some glance, you can see that all the configuration from rendering the configuration from some information that is auditable, that is structured. You can build the configuration, you can provision, push this configuration to the devices, keep backups, check if the configuration in place has changed for any reason, enforce a remediation of this configuration, or you can think about other solutions like self-healing networks that they can check what's the state, understand what's happening via telemetry, via monitoring of the state of the network, and take decisions automatically. So the same thing that an operator in the middle of the night will get a page and react to an issue in the network, if you can code this logic into a script or into an application, this can happen automatically, saving your sleep time. That is really important, but more important for the business is also saving operational time. So you are reducing the impact of any problems that may happen in the network. Now, we want to share with you a typical network automation framework. This should not be really different from any kind of framework for automation. The difference here we have is in the network infrastructure. Infrastructure that today is composed by physical boxes, virtualized applications in containers, also as a service, so you can consume services, networking services from cloud providers. There is a big variety of things, but the network infrastructure has some particularities that make it different. Most of the time, when you provide a service in networking world, it's an end-to-end service, so it's taking into account a lot of different devices that have to share a state. They have to reach a consensus on the protocol just to transport the packets from one side to the other, in a way that in some of these cases you are not the owner of all the boxes. Imagine when you move a packet from one side internet to the other. This is because behind you there is a IP layer that has converged and the packet can move from one part to the other. This adds some complexity. Specific here, we want to highlight also the telemetry and analytics. So there is a big changes on this area. Traditionally in networking we have been using SNMP, but today we are converging more into putting together the metrics that we get from the network together with the servers, making a big difference. All this information via workflows, understanding what is your intent state of the network, how do you like to be the network from the source of truth, putting everything together into an automation engine that you can understand as a translator, moving from your intent to the actual change, will make that you can operate this way in an automated way. And we are going to use this framework in order to reference the different functions that make sense to take into account. And let's start first with the network infrastructure that, as we said, is a really diverse ecosystem. But let's understand this from the point of view of how we interface with the devices. Traditionally, as I mentioned before, we have the CLI in order to change the state of the network, so you interact via command line interface. You also have had and already have SNMP, this Simple Network Management Protocol, in order to get data from the network. This has been there for decades, and there is still, in most of the cases, the primary way to interact with the network. But because of the revolution that we have seen in this area, there are new interfaces. So there are new data model interfaces like netconf, resconf, that is the same but via API, GNMI, that is promoted by the OpenConfig, netconf is by the ITF. So at the end, there are different standards, consortiums that they promote different ways to interact with the network devices, especially to make these operations more suitable for automation, because as I mentioned before, CLI is not a structured way to connect to interact with a device. But because this ecosystem is really huge today, we don't only have the traditional network devices that support these interfaces. We also have custom APIs. So imagine a network service from AWS or from Azure, from a cloud provider. You raise or ask for a virtual network. This is now defined via an API. But at the end, if you want to provide a complete network solution, your network in the cloud should connect to your network in the data center. And this needs some connectivity, some protocols that have to run between them. Also, with the rise of the Linux operating system, we also have access to the Linux shell. This was something that was not possible before. The network operating systems didn't provide this kind of access before, but now they are starting to give you the same feeling that you have with the servers. But the reality today, from this survey from 2020, run by Damien, you can see that the first interface to interact with automation was the CLI, not netconf. So there is a lot of huge work in order to make the interaction with the network devices smarter, because if not, you have a lot of things to solve around it. Another important topic, not for the actual management of the network, but to make really good development environments, because as you know, with the software development lifecycle, there is the testing attitude, no? I would say that this idea of testing everything before moving into production, we want to test how you manage the network, and testing in production sometimes is not the best. So there have been changes and new technologies that have helped us to be able to simulate, to create labs in order to understand how to manage this network. From VirtualBox, using background, moving to containers, Docker, that there are solutions like Container Lab or VRNet Lab that provide the emulation of network devices into Docker. Voxen, for instance, is now a new project that makes possible to translate from network operating system images into Docker. Another solution like NetSim tool that help you in order to abstract environments that you can then run via background or Container Lab. But all these solutions are focused on labs. One node solution that you can run in order to simulate your small network to check some things. But what if you have to run a really big network that you want to test before production? Google has this problem, and Google has promoted open source project, the Kubernetes Network Emulator, that help them in order to run a big network scaled through a cluster to test these kind of things. At the end, the idea is to be able to test things before moving into production, focusing on managing, not on the performance, for sure. Another key element on this architecture is the source of truth. This is where we define the intent state of the network. So you have to understand that the network is running and there is a state, but maybe it's not the state that you want. We have to get some place as the reference where we define the intended state, what we want the network to look like. To make this, there are a lot of challenges. It looks like a simple thing. Maybe you can do it like in a table or in a file, but the changes that we have to face nowadays is about data modeling. So how a model that we think that is abstract enough then finally suits well with the different vendors, with the different services, with the different interfaces. Maybe one interface for one vendor is different the model that they have if you go via GNMI or if you go via CLI. these differences make it really hard to approach this in a good way that you can abstract the data model. Then you have to get a data validation because the data is defining your intended state. If the data is wrong, your intended state will be wrong. Because this data is key on this process, we have to trace it. We have to understand who changed that, why. And the changes should be atomic because as a service, we have maybe to touch multiple places of the network at the same time. So if an operation fails in one node of the network, maybe we have to roll back everything in order to keep the state as expected. And last but not least is the challenge on the data source aggregation, because maybe you have multiple source of data. You maybe have an IP address management in one place, an IT service management in another place, you have a data center infrastructure in another place, but at the end, all your network automation is going to consume this from one point. So you have to make it suite together, and solutions to promote the single source of truth, that all your automation makes sense and you have well-defined system of records, authority of that data, makes a lot of sense to think on this strategy. At the end, we are going to consume this data via different interfaces, maybe a REST API, or even better, using maybe GraphQL that makes easier to combine the different data that you need and don't get more data that you need and apart in only one request. Here, projects we have a lot in this area, but we are going to highlight the most important ones. As you can guess, Git, in order to track and to get the control of the files that define your state, maybe a YAML, maybe a JSON, is an option that you may take into account. But then
used for the Flash-only emulation, and that's written in Rust and running in WebAssembly. Yeah, so here are the supported environments again. This is kind of what we have so far. The disk images were created kind of in each emulator. So I used v86 to via the web interface to prepare the disk image and then export it, and also save the state so that can be restored for the emulator for faster loading. That was all possible through the web interface of v86. For Basilisk 2, I just used the desktop version and created disk images that way for each of the Mac browsers. And yeah, you can see on the left all of the macOS environments use Basilisk, all the Windows and Linux environments use v86, and then Ruffle is sort of its own setup. Yeah, and so I wanted to also cover WebAssembly is great, and WebAssembly and JavaScript emulators are great for the video and audio, so that's very well supported. But then the networking part, it turns out, is not so much there yet, and essentially we need a JavaScript/WebAssembly based TCP/IP stack to support networking, and that is not currently provided in the emulators in order to be able to terminate the TCP connection on the other end. And so web archives need to be accessed via HTTP through TCP. v86 supports sending Ethernet frames over a WebSocket, and Basilisk 2 port of in JavaScript actually doesn't have any networking support, although Basilisk 2 itself does, and it's possible to get the Ethernet frames out. I wanted to avoid relying on external infrastructure as much as possible, so not having a server that accepts the WebSocket connections. So we need to get from the Ethernet packet to the HTTP web archive somehow. Luckily, there is existing work that I was able to build off of, and that's the EAS proxy created by the folks at the University of Freiburg who work on the emulation as a service project, and they've kind of done a lot of the hard work of actually compiling a TCP stack in WebAssembly and providing wrappers for sockets that work with native JS streams. So it's a full TCP stack implemented in WebAssembly, and it can terminate the HTTP connection from the emulator in the user's browser, so that the client in the browser connects to a server that's running in WebAssembly. And a little bit more of how that works I'll show in a second. One other thing I wanted to mention, kind of the networking setup in a nutshell is sort of these two web workers. The emulator worker sends Ethernet frames to the Pico TCP web worker over a broadcast channel, which processes them as a TCP packet and then passes them to the HTTP server, which then proxies to the live web and then sends the response back. So that's kind of a very approximate explanation. One other thing I wanted to mention is how the changing of the date works, and that works essentially by the home page in the browser is set to this IP address, which basically then redirects to the actual URL that's set in the emulator configuration, and the timestamp is also tracked in the HTTP server proxy. And when the user reloads, it sort of uses the latest version of the timestamp and the URL. Okay, so here is a diagram that sort of covers how the system works. So the emulated browser on the left loads, let's say, geocities.com, then goes to the HTTP proxy on the 10.0.2.2 IP, which then sends a packet over the broadcast channel to the web worker that's running the Pico TCP IP stack, which then sends, goes from the web worker, or within the web worker, it gets processed as a TCP IP packet and goes to the HTTP server, which receives the packet, then reads the HTTP request. From that, it gets the URL and sends the request to the Wayback Machine or the live website. And then say same thing all the way back. It receives a response, sends the TCP packet through the Pico TCP stack, which then becomes an Ethernet frame that is then sent to the emulator in the other web worker, which receives the packet and sends it back to the browser. So there's a lot of moving parts here, and then we saw that occasionally things don't quite work. There's a network error. There's a lot of places where things can go wrong. Let's just put it that way. So there's definitely room for improvement in this system to make it more robust. And kind of the overall flow of this is this is kind of this zoomed out view of the architecture. So what happens in the browser is we have the inputs for the URL, the date, and a toggle of whether we're loading the live site or a web archive, and then that gets connected to the emulator running in the web worker, which also separately controls the canvas. So there's a separate connection there back to the main browser thread that does the rendering. It also communicates with the TCP IP stack on a separate web worker. The emulator also pulls disk images from remote storage, and that's the emulated disk images and save states. And then one other part is that we need a CORS proxy because web archives can't be accessed in the browser from other sites. And yeah, so essentially there's kind of a separate proxy that's required to load external websites and web archives, and that goes through Cloudflare currently. And that's kind of a very brief overview of the architecture. And so yeah, so what about Flash and Java as well? So as we saw, it is possible to run both Flash and Java because we have these browsers that have Flash and Java and Shockwave even installed. Many Flash projects do work. We can support the latest Flash up to 32. but there are still some limitations. So obviously we only have older browsers, such as Firefox 10 and Opera 12, and that may not be sufficient for projects that were built, say, within the last couple of years. And many Flash and Java projects were just not fully archived. It's very common to kind of find web pages that have Flash and Java embedded, but some of the Swifts and jar files are just missing because they weren't crawled initially. And then there are sort of performance limitations, as you saw, that obviously it can be slow loading Flash and Java occasionally, so it's not as fast as Ruffle. And that kind of brings us to the Ruffle emulator. So that is supported in Old Web today. Web page loads directly in the native browser, and the emulator is only used for the Flash. Obviously, it's much faster since there's no full OS emulation and no need for custom networking. However, Ruffle is also still in development, and there's not yet full support for Flash, and there may be subtle differences from sort of the official Adobe Flash that's running in the full OS emulation. And of course, you don't get the retro browser, but you do get performance if you're looking for just Flash specifically. Yeah, so I just wanted to kind of cover in this matrix some of the trade-offs and different ways of supporting Flash in Web Archive. So there's Ruffle, as I just mentioned, which doesn't yet support all Flash, but can run pretty well at full fidelity, speed, video and audio, and it doesn't require any server-side infrastructure. There's no CPU cost per user. Then there's the Old Web Today JavaScript emulation system. It can support all Flash up to Flash 32, but as we saw, there's not quite the full performance yet. And there's also no cost per user, as it's all client-side. And then finally, there's the remote browser approach, which is the oldest approach that we've tried. I didn't cover it this time, as there isn't quite enough time for it. And it can support all Flash, and it can run at full fidelity, since the content is since it's running on the server. But there's also a CPU cost per user, as you have to run a new instance of the container for each user. And Old Web Today covers the first two, Ruffle and the Old Web Today JavaScript emulation. We have a separate system, the PyDB remote browsers, which I'll link to, that covers this other approach. Yeah, I just wanted to end with a few links. There's a blog post about Old Web Today, and a link to a few of the repos, including the main Old Web Today repo, and as well as the forks of some of the emulators that I've used. And then there's other web recorder tools that also work with Flash, such as the Docker container-based system, and we have an extension that injects Ruffle and allows for kind of archiving with Flash. Some future work, obviously optimization, adding new environments, making networking more robust, improving rewriting of HTTPS URLs for old browsers that isn't quite always working, supporting additional archives besides Internet Archive that also support the Wayback Machine URL interface, and support for perhaps uploading archives directly and integrating with other web recorder tools. So thank you for listening, and I'd be happy to answer any questions in the time remaining.
All right, so once again, that was archiving old websites. Again, I apologize. What's coming up is going to be the last session for this live stream, but it's kind of the longest one, and that is going to be camera support on mobile devices using FOSS software. If you've ever flashed, Lineage mostly works, but if you ever flashed like Bromide or God forbid Replicant or Postmark OS or Ubuntu Touch. The cameras are usually completely offline and inaccessible due to a bunch of drivers and other issues. This is going to be an hour and a half talk on the subject with a whole round with a really awesome speaker. Again, probably hear my voice. I'm personally okay. I'm just dealing a lot with the apartment right now that I live in. I'm hoping that near the end of this, closer to noon, I'll be able to turn the camera back on and be able to end the stream with everybody. When we do, we're going to Twitch raid someone, and then tomorrow it's going to be a lot smoother, 4 a.m. to 1 p.m., entirely focused on security. Again, thank you for everyone for their patience. If you find any of this content fascinating and want to see more, because we're going to be doing a lot more streaming this month, including Tuesday for Patch Tuesday, and Master of Unlocking, which will also be tomorrow. Don't forget to hit that bell, like, share, subscribe on Twitch, DLive, and YouTube. On YouTube, make sure to hit the bell notifications, turn all notifications on, because YouTube is really poorly coded. And that, again, to remind everyone, we are trying to do our last push today and tomorrow to raise money for the Children's Miracle Network hospitals, which distributes money that's donated to them, like we are going to with our current $308.50 to various pediatric hospitals and pediatric facilities and children's hospitals across the United States and Canada. If you're interested in donating, the link is in the chat. I'm going to be posting it again later on. There's also a QR code for all of you mobile users out there that goes toward Tiltify donation. And on Twitch, we have an easy-to-use widget at the bottom. It uses Tiltify, which is a great third-party charity donation system, along with PayPal. You can't donate in cryptocurrencies yet. And that we got to our $308 due to small donations, including anonymously through multiple people over the past couple of months. $1 or $5 is what built us over the edge. Even though right now, Feel One Dead still is on our leaderboard and will probably go down in history of being on for a month and a half for $69 elite dollars. But that, again, even if we don't meet our $600 goal, and it was a lofty goal, but we had a lot of crazy stuff go on in January that kind of messed things up. But even if we don't reach that goal, the current $508.50 are still going to go to kids across the United States, Canada. So if you have the means to, get out your credit card, don't have it on camera so no one can see, and please donate money to a very good cause. Now, let's start the last segment of the day, talking about the dreaded terrible camera support on mobile devices, and let's see if there's been any improvements over the past couple of years. And as soon as I get everything ready, I will turn the camera back on. Again, my apologies. Tomorrow at 4 a.m. will go a lot smoother than today. Today was kind of like a learning experience, plus snafu happened, and Murphy's Law at the same time. All right, here we go. Enjoy.
Techniques that could be built on top to obtain advanced feature like zero shutter lag or HDR. As I've said, I don't want to go into detail, but just to present the fact that all that we have presented so far, it's just enough to capture a single image. While it turns out that the image capture itself is more complex systems which closely resemble closed-loop systems, where statistics, as collected by processing the raw Bayesian frame, are transformed by a dedicated chip or by a dedicated computational capable device into parameters that are used to apply transformation to obtain the final image, but that do also influence the way the next frames are captured. The components which is usually responsible to perform this kind of operation, both applying the parameters, both computing them by parsing statistics, it's usually called an image signal processor. And its functionalities could be exploited to implement what is usually called the 3A loop, which is more complex than that because it's not only about auto exposure, auto white balancing, and autofocus, but there are other tuning parameters which are dynamically calculated based on the characteristics on the captured image. With that in mind, I would like to try to classify camera systems in a very simplified taxonomy, starting with what I would call a legacy design, even if that's not totally fair, because that's a perfectly legit design also today. But it comes from a time where SoC or embedded systems were much less capable than today. So the computational power was not comparable to modern devices, and most of the computation-intensive image manipulation algorithm used to run on the sensor itself, which usually embedded a small, tiny ISP, which gets controlled by a set of I2C commands usually. In this configuration, all the heavy lifting is performed by the sensor itself, which presents to the SoC an image in a format which is already consumable or already presentable to the final applications. Which means that we are heavily relying on the characteristics of the image sensor and its feature sets. It also means that if you move in one design to use a different image sensor, also the user visible characteristics might change depending on that. Your new sensor might not be capable of providing image in the desired format or resolution, so the application feature sets changes depending on the hardware design. There is another point which we are also going to explore later in the panel, which is about the fact that also today, still today, in both in mainland Linux and both in most of the BSPs, sensor drivers are programmed by using binary blobs of register values pair as provided by the image vendors. And the way it usually works is that those binary sequences are generated by the vendors, provided to ODM or OEM to integrate in their BSP drivers, and they then later surface into mainline drivers as well. So we still heavily rely on the vendors providing the correct programming sequences or reverse engineering them, which is not an easy or funny exercise. This of course creates a sort of vendor lock-ins, which does not only mean that you are confined to use a single producer if you have made a design with them, but also means that you have a dependency on their supply and support chain, which is not easily accessible if you are not a producer which makes millions of devices a year or something. Of course, if you are a device producer, it's also worth noting that smart sensors are usually more expensive than sensor which only provides raw images. For all these reasons, and with the incredible increasing computability capabilities of embedded devices, in the last years, it's more and more common to find designs which embed an ISP inside the SoC itself. In this way, the sensor is only requested to provide images in raw formats, and all the heavy lifting is performed on the SoC side itself. This, of course, has several perks. The first one, if we want to consider the software side first, is that the SoC usually runs Linux, which means that the code that controls all the image processing is closer or potentially accessible. And that means that there is more space compared to using vendor firmware binaries to get really to know what happened there. Of course, there is a matter of features and performances, because if the SoC is integrated in the SoC, if the ISP is integrated in the SoC itself, it could exploit the high-speed interconnects to the other parts of the systems and could run higher clock rates, and in general could provide a more extensive feature set compared to a tiny ISP embedded on an image sensor. Also, since we are in control of the code which runs on the ISP and performs the image manipulation, there are higher chances of code reuse and standardization. From reusable 3A algorithm, which are not anymore delegated to the sensor firmware, to also we live in a time where open hardware designs could be exploited to produce dedicated chips or dedicated components which might compete with proprietary ones. Of course, with the evolution of technology and the evolution of the hardware feature that an SoC could provide, the software side, the kernel side in this specific case, had to evolve as well. Video for Linux has been designed in a time where most of the design were revolved around having a smart sensor, and Video for Linux was designed through the single dev node abstraction when there is a single point of control towards user space, which is the usual dev video something we are all used to work with. With the introduction of, with more and more features appearing on the SoC side, of course the current interface as it was did not scale at the time. So I'm here presenting a totally fictional design where on the SoC side you have the usual CSI2 receiver, as well as other components which might perform rescaling, conversion, and formatting of pixels. Each one of them has a representation in user space through the V4L2 subdevice extension to the V4L2 API, and through the topology API, which are known as the Media Controller API. There is a question, this is a design which has been, which comes from like 10 years ago or something, and there is a question which is totally legit today, which is why all of this complexity? Why do we now have an explosion of V4L2 subdevices in user space? Why cannot we control everything through a single point of control and make application possibly easier or make life easier for them? Let's make a counterexample for that. Assuming we want to capture an image in a known size and format from the capture pipeline. With a single dev node abstraction, we have a single point of control where to apply this request. Since the hardware was simple on the SoC side, it wasn't enough at the time generally to apply the same format to both the receiver side and the sensor driver side, so that they are compatible, and you're mostly done with that, and you could expect images to arrive in the format that you have requested. Let's assume the same request is performed on much complicated systems like this one. So you're asking for an image in a known resolution and known format at the end of the capture pipeline, but there are several different combinations that could allow you to obtain this very result. Let's assume in the first case you are plumbing an application that does still capture, so you want the highest possible image quality. One possible configuration would be to require your sensor to operate at maximum resolution and provide images in unmodified Bayer format, and perform resizing and conversion along your ISP pipeline, and in order to obtain the resolution that you have requested. In this way you will maximize image quality, but since the sensor operates at a high resolution and the highest possible resolution, its frame rate might be limited by the characteristic of the sensor itself. So let's assume instead you want to plumb a use case for video recording, and you want to have a sustained FPS for the whole duration of the video. One possible configuration in that case would be to request your sensor to provide images in an already downscaled format which matches your final image request, and only perform conversion along the pipeline in order to guarantee that the sensor could operate at a higher frame rate. And this is another perfectly legit configuration to obtain the final image as you have requested those. Let's also assume you are in a more complicated system with two cameras and you only have a single scaler or a pixel converter. In that case, you might want to decide to dedicate the converter or the full ISP pipeline to one camera, and if your sensor is capable of doing so, requiring it to provide images in a format which is already presentable to application. This is another perfectly legit use case, and you should be made capable of deciding how to configure your system depending on what are the final requests from your applications. So the argument for all this complexity in user space ends up in having user space configuring each single point of the capture pipeline precisely, which is a burden and makes systems more complicated to deal with. The counter argument is, why cannot we code everything in the kernel infrastructure itself? Well, our coding is usually generally a bad choice, even more so in an operating system. The duty of an operating system is to enable application to implement use cases, not code them. And the more we are coding in kernel space, the more we are limited to make the contribution and the driver useful for a general audience. This means that to have a usable systems and to realize a known use case, there is a part of system or platform configuration specific that has to be applied to the whole system before it can produce images in the format you desire. This means that for Linux, in the last 10 years, evolution of the application got a little bit stuck because of that. Because in the regular desktop systems, most of the application like Cheese, like XAVTV or several other, they assume to work with UVC cameras. UVC cameras are a special kind of smart cameras in terms that they could be operated through the single dev node infrastructure and do not need any device, any platform-specific configuration. It's also usually GStreamer or other frameworks like FFmpeg are usually the preferred way to access cameras, not only because they provide an easier API compared to the raw Vida for Linux 2 API, but also because they are usually easy scriptable, and the system configuration on embedded devices is usually performed by a set of scripts, which is of course a solution that cannot scale beyond the single vendor use case or the single implementation. And so the case for a camera stack, it's all in this part. And 3 years ago, the planets aligned, and there was the possibility to start working on a camera framework for Linux with the specific target of abstracting away all the platform-specific configuration from application, which should be made capable of relying on a single and unified API, which is totally platform independent. The drawing I'm showing here comes from the libcamera materials. There are a lot of presentation about the libcamera architecture online. I'm not going into detail into that. I just want to stress out that one of the target of any camera stack, and libcamera doesn't diverge from that, is to isolate the platform-specific code in a part of the library which should not influence how the application the API towards applications. We have decided to call that part of the libcamera pipeline ender, but it's really hardware configuration to accommodate a specific use case. So what are the perks and the rationale for a camera stack for Linux? The first one is that all the device-specific components should be isolated in a known place, so that applications do not care about that and could be developed generically enough to run on different systems without modifications. There is a pain point at the moment that in order to enable that to happen, hardware support has to be implemented in the camera framework itself. The vision for that is that a pipeline ender, so the platform-specific part of the system, it's really hardware support. It's something that should be part of the vendor BSP if they want to provide a usable cameras. Of course, it's a long way to get there because vendors, like camera vendors or any kind of vendors, the less they have to provide in terms of software support and software development, the happier they are. And it's not easy, but it's a long process to buy them, to convince them into adding support for their platform in a way that it's abstracted away from the single use cases they have implemented. And of course, to get them on board, there is a requirement to have some critical mass around a single point of contact or a single code repository where they can contribute to and provide usable cameras for their customers. The other argument for a camera stack is to provide the generic and unified API towards application, which includes a set of known controls. Right now, VDF Linux controls are standardized in their definition, but the way they are applied to the device, it's very much device specific. A value that gives you an exposure on a camera will give you a totally different exposure on another one, and that's not acceptable for applications which have to deal with that by themselves. So standardizing on a set of controls and providing a generic API does not only allow application to be written in a generic way, but does also allow to implement and provide adaptation layer towards other known frameworks like GStreamer or Pipewire, or in the case of Android, the Camera Hub version 3. Also, or an emulation layer for retain compatibility with legacy v4L2 applications. There is also the fact that if centralizing the implementation of 3A algorithm in a single place might give potential for a lot of code reuse, or even to the definition of a framework that allows to implement platform-independent algorithm that performs the most usual 3A functionalities. There is also the fact that we have what I would call the state-of-the-art implementation of an open library for 3A algorithm, which is provided by Raspberry Pi, and that's inspiration and a point of reference for everyone that would like to look into that and provide a competing implementation or improve the existing one. So all of that was to make the case for a camera stack for Linux system. And the question I would like to explore in the continuation of this meeting is how much of this does apply to mobile devices, especially free and open source mobile devices, and how much of that could be reused in their development. I hope you have enjoyed this small presentation. I would like to thank you for your attention, and I hope as well that you will enjoy the following discussion, which will now move to the Gcc call, where you are very warmly invited to contribute to by asking questions in the public Matrix channel. Thank you all.
Thank you, Jacopo, for this interesting talk and introduction into the world of cameras. As we have quite a few speakers today on the panel, I will keep it short and hand it over to you, Jacopo. I'm very much looking forward to the discussion. Seems there is, we've lost he's back, okay.
Sorry, I lost my connection just at the time when you say I will hand it over to you. So the right timing indeed. I hope to be back.
Yes.
Okay. So thank you for the introduction, and thank you everybody for being here. Thank you for the guests in the panel which are here, and which I very much move on to introduce immediately. So there is quite some people here. I hope that they can bring a different perspective about cameras and about Linux mobile devices with their expertise. So I'm starting introducing. I will share my desktop if I could, where I have some slides, which I would like to share during the discussion. No, I just need to find the right slide deck, and that's the one. So I'm not sure if you can see that or if it's any useful to you, but I would like to start introducing in alphabetical order. We got David and Naush from Raspberry Pi. They are camera engineers working on camera enable on the Raspberry Pi. So David, hi there. I would like to briefly introduce yourself. I know Naush will join us a bit later, so I'll let you introduce yourself first.
Yeah, hello everyone. Just a quick introduction then. So I'm working on cameras at Raspberry Pi. I've been doing cameras off and on for a while now. And indeed, Nosh and I, we were two of the engineers who did a lot of the work on the, if you can cast your minds back to the last round of Nokia Symbian phones, so phones like the N8 and the 808 PureView, which had pretty good camera systems actually for the time anyway. So Nosh and I did the sort of led the work on that really back then, and now we find ourselves at Raspberry Pi doing similar things, I suppose. I mean, it's you know, life at Raspberry Pi is rather different. You know, we're not so much interested in creating mobile devices. It's more about, you know, creating APIs and toolkits for our users. So it's a bit different, but you know, there's still a lot in common.
Okay, thank you. Next, we have Dorota and Martin. They are software engineer for Purism, working on the Librem phone. So if you would like to briefly introduce yourself as well, I'll let you choose an order. The first one that takes the camera. Okay, go.
Hello.
Hi, Dorota.
It's Martin here. Well, my name is Dorota. Together with Martin, we work on the Librem 5 project to introduce the support for the two cameras that that are present on the phone to the mainline kernel eventually. We are not there yet because there's a lot of work. And apart from the kernel, we also work on basically the entire stack from libcamera that was the topic of the previous talk, as well as applications. But I will let Benjamin talk about that. Yeah, we work on the Librem 5, which is a phone made by Purism. And if Martin wants to introduce himself specifically, here is your turn.
Hello, everybody. Yes, I'm working on the kernel as well for the phone. And the Librem 5, I think, includes some pretty nice cameras, actually, that we just need to make proper use of. And during the last year, thanks to Laurent, we made sure that we can now stream frames on one of the cameras using a mainline kernel, and using the standard tools with a Linux control, whatever. And I just want to hope to get some feeling about libcamera, and it's basically a device where we have an OpenGL ES2 implementation, but nothing else apart with respect to image processing. So that will be interesting. Okay. But thank you for that.
Thank you. Since Dorota, you introduced him, I would like to introduce Benjamin, which is working on camera support for the Pi phone. Benjamin, if you would like to quickly introduce yourself as well.
Sorry, you cut out there for a sec. I'm Ben. I work for Sublime HQ on Sublime Text, which is completely unrelated to the camera stuff I do. I took over fairly recently over Megapixels, which is the most common camera application for the PinePhone, and hopefully soon the PinePhone Pro. I also dabble in driver development, working on the same camera stuff.
Great, thank you. Then we have invited to join us Hans and Kate from Red Hat. Hans is a long-term kernel contributor and is now looking into enabling camera use cases for Intel tablet platform, is my understanding. And Kate is helping with implementing an autofocus algorithm for the same platforms. If you would like to introduce yourself quickly as well.
Hi everyone, I'm Hans de Goede. And yeah, everything has been said. I'm a kernel developer. I'm working on IPU3 hardware enablement together with Dan, who we'll get to, I think. Oh yeah, he's next. So yeah, nothing else.
Hi everyone, I'm Kate, and
I'm a lip camera developer. I implement the IPv3 algorithm and based on Hans and Hans kernel works, and he quickly developed some some drivers such as the VCM and sensors drivers. So I based on his work and developed the IPv3 algorithm to make all the devices up and running.
Thank you.
Yeah.
Thank you. And as Hans, you introduced him as well, we have Daniel on the call from the Linux Surface community. Daniel has been doing an amazing job making devices with non-Linux compatible ACPI tables working with Linux. That was an amazing job. So Dan, if you would like to introduce yourself as well.
Thank you. Yeah. Hi, everybody. I'm Dan. My work background's really data analysis rather than programming, but in March of 2020, I found that I needed my laptop cameras to work. So I thought, how hard can that be? And kind of fell down a bit of a rabbit hole from there. I've mainly been working in the kernel, adding support for the cameras on the Microsoft Surface line and quirks for their weird firmware at the same time.
Great, thank you. And finally, we have Laurent and Kieran from the IDEas on board. Laurent is the lead architect and main developer of libcamera, and Kieran is the core developer of libcamera as well. If you could quickly introduce yourself.
Sure. Thank you, Jacopo. So as you mentioned, yes, I'm here in my quality of lead architect of libcamera here today. I'm also the founder of IDEas on board, so my background has been extensive development and mostly in the Linux kernel side for the past more than 15 years, more than I can count actually. And we started the libcamera project a bit more than 3 years ago, moving from kernel side to the user space and the framework side, which was a very interesting journey where we managed to learn quite a lot, including the fact that if you design kernel APIs, and we're thinking about video for Linux in this case, without having actual use cases in user space and real applications to use that, you end up making lots of mistakes. So we've been suffering from work I have done in video for Linux myself. So I constantly have to apologize to myself when working on libcamera. But I'm very happy to be here today. And hope that we'll be able to cover quite a few interesting discussion points, especially given that we have different communities that haven't necessarily interacted that much in the past. So let's see if we can collaborate nicely together.
Thank you.
Hello all, I'm Kieran. Also been working with Laurent for I think 6 or 7 years now. So we were working on cameras and graphics before that, and that's kind of brought me in clearly as one of the main developers on libcamera as well. And I'm really happy to see that it hopefully will provide more user application support for more platforms. So I'm really happy to see so many different groups coming in to talk today.
Okay, so thank you everyone. The format that we're gonna try to respect today, I prepared 5 discussion points, which I would like to introduce to just sparkle the discussion. We have 50 minutes time, which is pretty strict, and we will do our best. Also because the bot, which closes the video conferences, is merciless, as someone has said in the chat. And I would like to keep a Q&A session for the end, around 10 minutes. But if there are interesting questions which comes up during the discussion, we will be happy to take it. The only thing is that I might not be able to see them because I'm in the call. So if you notice something which is worth discussing, please notify me. I'm not sure if my slides are actually useful in this way. So I'll try to describe the slides, which it's a bit more complicated, but so I would like to start from the question which has been left unanswered in my previous presentation. How much of the context which I presented, assuming my understanding is correct, applies to Linux mobile devices, and how and why they might be considered different compared to other platforms? I don't know if you can see that for real. I found this one on an internet forum a few months ago, and that was said to be the most commonly found picture in the smartphone of Linux power users. and it's basically the back of a router or something with a large password. What is the hint here? The hint is that a Linux power user might not be that interested into cameras, or at least in advanced functionalities of cameras, and certainly cameras are not a selling point for Linux devices like they are for commercial ones. One other point which I would like to bring to the attention is the fact that if you're a producer which makes a new phone every 1 or 2 years, moving your work to the next generation of products is a considerable effort if you have to do it every 1 or 2 years. But if you have 2 phones or 1 phone, or you are in a community which will never see new phones, that's Nokia 900, that will never see a new version, unfortunately, maybe you are not that concerned about the effort, about porting from one version to another. So the first question which I would like to ask, and that's specifically for Purism and Ben from PinePhone, it's what is the expected set of features that cameras should provide in a Linux-powered mobile devices? I would like to ask Dorota to start first. Do you have anything to share about that regarding the Librem 5 phone?
Oh, yes, of course. So I'm taking offense with the statement that camera support is not a selling point for Linux devices. It has been one of the most requested features, and it still remains one of the most requested features for our phone, to actually have the cameras working well. And I think in general, saying something like selling point of Linux devices, like Linux in particular, it's kind of a red herring. People want a phone. They don't really care whether it runs Linux or not. And therefore, they will apply the same considerations regardless of what the phone is running underneath, as long as it meets their functional expectations. And one of those expectations is having a working camera. So I think that makes it just a regular thing, not really different from any other phones. When we try to contrast phones with stationary computers, I think there are some differences. The focus is perhaps a little bit different in terms of you cannot go outside and take pretty pictures with your laptop. I mean, you can try that, but you're not going to have a very good experience. So just taking pictures and just taking even snapshots is going to be a case that is not present on the desktops. That being said, I expect that video calling is going to take the cake when it comes to actual usage. So I would say that from the perspective of the users, while those are different cases, the underlying stack doesn't really need to differ that much between phone and traditional desktop use case.
I see. So thank you for your answer. Benjamin, could you relate with that about the desired feature set for a phone like the PinePhone? And that's an additional question, which Dorota, if you want to reply as well. If you have considered, and I know you did, using a camera stack, have you found that an entry barriers into doing so, which is not justified for the use cases that you are trying to implement?
So to answer the first thing, I'm in complete agreement. I think that the camera is a very important part of the phone, which is why I got into doing this in the first place. And I think the end goal should be to get to the same stage that Android is at this point, where you can hop in a video call with the camera and it just works, and you can take photos and video and it just works. And these are things that are part of at least some people's everyday lives. I know they're part of mine. So I think those are all important. In terms of camera stack, that's a bit of a complicated question. After long deliberation, for the time being, lib camera doesn't seem to be in a state where I can use it for megapixels. Part of that is probably simply the the speed at which things can get developed, because I can work on the camera driver and megapixels at the same time, pushing features in both cases. If libcamera was in between there, I'd have to also do patches to libcamera, which then take, go through a review cycle and everything. And at least for the PinePhone, and especially the PinePhone Pro, these are still really early days where any kind of barrier to further development can be a huge hindrance.
Mm-hmm. Thank you. That was very interesting to know. Dorothy or Martin, do you have anything to add to that, to the last two questions? Do you find the entry barrier justified for the use cases that you're trying to achieve?
Yeah, I think I agree with what was just said, that libcamera as a layer in between is, I would not say it's not necessary, but it makes dealing with the entire stack slower. When you could hard code some internals, basically we could hard code the hardware configuration and get on with it. If we didn't want to use the camera, but on the other hand, I understand why camera exists and why it is needed in the long term. So it's kind of a difficult situation whether I should want to invest in the long term of cameras or whether the short term of just having our device supported is the right thing to do.
I perfectly understand. So sorry.
Yeah, I'd like to interject there. I also think that, at least in the current stage, libcamera is very focused on applications that aren't camera applications, because the megapixels app needs to have a very intricate set of features, or at least that is going to be the eventual goal, that maybe even hardware specific features that just don't make sense to put into a more generalized library. And on the other hand, libcamera makes all sorts of sense if you're, say, a web browser or any other application that needs to, take a picture, but it doesn't have to look amazing. It's not supposed to be a work of art. It's just a picture. Or like, video conferencing, you're just making a video. For those sorts of things, it's currently, or for the PinePhone at least, it's getting into a better state.
Okay, I hope we can resume this point later in the discussion. If no other comments on this part, I would like to move to at least Laurent. Yes.
If I may make a quick comment, Jacopo, on that.
Sure.
I think that's fairly interesting remarks, especially when it comes down to the fact that we have an ecosystem of very different applications when it comes to camera usage. And indeed, on the video conferencing side, we may not need to get the most quality out of the camera, even though as time goes by, I think that people expect better and better quality there as well. But when it comes to still image capture, for instance, you may want to apply different types of processing on a picture. That doesn't necessarily make sense in other use cases. But we really, at least that's a design goal of libcamera, we really want to enable all those use cases, regardless of whether you just want a high-level API with something that works for video conferencing and getting usable images out of that, or if you want to go for something much lower level. So libcamera does provide process images, but also has the ability, if the platform allows that, of course, if the hardware allows that, to produce raw bioimages where applications could have full control on the processing and of low-level parameters. So I'm entirely sure that there are some use cases that we could discuss where having an extra component in the middle between the application and the drivers may get a bit in the way and may make things more difficult. But even for, I would say, power users or power user applications that really want to have detailed control of the camera, that's something that we want to enable. I'm not saying that we're necessarily there yet, but it's certainly a design goal.
Thank you. I hope we can resume the discussion in the next points as well, with maybe opinion from Raspberry Pi and other vendors. The next point I would like to discuss before diving deeper into that part it's looking at the current designs for at least the devices which exist on the market today. And I'm thinking about the Librem 5 and the PinePhone because those are the one that I know the most. But I'm sure there are other communities which I'm not aware of, so feel free to speak up. I would like to get in touch as well. So I'm using the PinePhone and Librem 5 as an example designs because they fall in the category which I a bit unfairly labeled as legacy designs, because they both feature an SoC with does not have an ISP on board. So I try to list a few challenges which I imagine you had to face, like how do you perform the biring? Is there 3A loops? What does generate statistics, and how are the algorithm implemented? How you decided which formats to support? And I would like to ask again to Ben and Dorota if they could explain how things work today on the PinePhone and the Librem 5. Ben, if you want to go first this time.
Cool. So the PinePhone has both cameras are smart sensors, so they have an integrated ISP. They don't offer a lot of data beyond just here's the image we recorded. But they do allow for a fair amount of configuration of the ISP itself. Megapixels generally just uses it in raw format and then handles the debayering and other post-processing on the CPU or the GPU for preview. The formats are all both of them support a variety of formats. I think it might also be good to cover the PinePhone Pro here because the PinePhone Pro is...
I have a point for that.
Oh, and a separate one? Okay, never mind.
Yeah, I got a separate one for that. It's a kind of a different design. Dorota, do you have any other insight to share about how the camera stack looks like for the Librem 5?
Oh, yeah. The Librem 5 camera stack has kind of a tiny little ISP on the camera module itself. We can do some basic corrections like color correction and vignetting. I think that's the same on both sensors. As far as I can tell, on the IMX8 SoC, there is a little ISP as well, but it's limited to gathering statistics from the photos, from the capture frames. And yeah, the sensor passes down raw data, both sensors do, and then the SoC has the task of processing them. And the challenge is how to process them fast. And so far, that has been a big limitation. We are processing them on the CPU currently. We do have access to the GPU, but the GPU is also not very well developed. We only have access to OpenGL ES2, which brings quite large limitations to what we can actually do. There is no compute mode on that GPU, so we are going to have to get creative to get the data fast out of it.
Okay. I was meant, and it was my intention to make a point to discuss explicitly how GPU debayering is performed, and I was interested to know if different implementations were easily portable between different devices of debayering on the GPU. I haven't prepared any slides for that, I'm sorry, so I don't know if there are other comments on how such a design could be made more portable or could be replicated in other infrastructures. Maybe if anyone.
So I've got a good answer to that. Because or at least Megapixels right now uses OpenGL ES2 for debayering. That code is because it's OpenGL and OpenGL runs on everything. It is extremely portable. There's already been work done on a separate Qualcomm chip. Someone's worked on, I forget who it was, but someone's worked on supporting a Qualcomm chip using Megapixels, and they had to do very limited work with the debayer shader. This is just for the preview, not for actual image capture, but they had to do very limited work to get that working. And the main part of that was actually just working with a different image format rather than doing different logic for the debayering. So in terms of portability, the GPU debayering is about as portable as you could possibly get.
Okay.
I have a question on that, because you also have OpenGL-based debarring, actually also using GLES2 in the QCam test application that we have in LibCamera. So really a similar implementation, but then that has been developed completely separately. I fully agree about the portability when it comes to the source code and when it comes to the fact that you get an output image that's pixel perfect. But what we have found is that depending on the GPU that we're running out, and possibly also depending on the OpenGL implementation, performances can vary quite a lot. So even though the source code itself is portable and will produce the correct output, you can have really bad performances and maybe lower end GPUs if you don't pay attention to the number of texture units that you have, or to really low level details. So my experience there is that, yes, there's portability at the source code level, but if you want it to run smoothly, it can become more complicated. So for a simple algorithm like debarring, that may not be too much of an issue, but if you add more processing steps and you need to make sure that everything runs with correct performances on lots of different platforms, I think that can be quite a bit of a challenge.
Okay, thank you. I'm sorry if I have to cut the discussion, but I'm a bit concerned about time, so I will try to move a bit faster than that. So describing the architecture for the two existing phones, both of them doesn't have a full feature ISP and relies on some functionalities provided by the ISP on the camera sensor. This is a question on the slide, mostly for the LibCamera team, and we got something that it's called a simple pipeline, which was actually started by the Megapixel original developer in order to support the Python. It has been deviated to that in order to accommodate more platforms, and recently I've seen Ben and Dorota trying in interface with that. And I'm under the impression there is a bit of a misconception about what the simple pipeline does and what it is supposed to do. So I would like to ask Laurent if you could clarify that a bit. And also,
sure.
Sorry, after that, I would also like to introduce the big discussion. I would really like Nosh to be here for giving his opinion, being the pipeline and the developer for the Raspberry Pi, about what does it take and when it is necessary to implement a pipeline for your own device specifically. So Laurent, if you could clarify those 2 points.
Okay, I'll try to be quick. So as Jacob explained very clearly, the pipeline handler is really the backend implementation in LibCamera that has the device-specific code, and it's supposed to configure the camera pipeline, to pass buffers around, to interact with the kernel drivers. So it does not do image processing. That's the job of a separate component that we call the IPA, for image processing algorithm. But it's really the plumbing. And the simple pipeline handler started because we had two separate implementations to add support in LibCamera to create a pipeline handler for the PinePhone indeed, and also for an ST SoC. They came pretty much at the same time with the mailing list, and the hardware is fairly simple there. You have a smart sensor that includes an ISP, and on the SoC side, at least what needed to be supported, it's just a CSI to receiver. I think on the ST platform, there may have been a scaler as well in the pipeline, but it's a very simple. There's no ISP that is being used on the SoC side. And those two implementations that have the two pipeline handlers for those two different platforms were developed separately and were really mostly the same. So that's when we thought that we could try to share the code there and have one implementation that would cover pretty much any platform that doesn't have an ISP. It doesn't mean that if your platform doesn't have an ISP, it necessarily has to be supported by the simple pipeline handler. You could have a specific pipeline handler for the platform if it requires so. But we thought that it would be possible to create code that only relies on generic kernel APIs, on the device topology that is exposed by the kernel drivers, to be able to do automatic configuration of the camera pipeline. So that's really how it started. The goal was to get something that could work out of the box. And to some extent, adding a new platform, adding support for a new platform, if the hardware is simple and doesn't have an SoC, can be as simple as adding a single line in the source file where you just add a string that identifies the the platform so that the simple pipeline handler can handle the kernel drivers automatically. It's not always the case. We had some discussion on the libcamera mailing list a while ago, and that's something I need to get back to. But the current implementation doesn't support scaling on the sensor side, which means that it always configures the sensor for the largest resolution, the highest resolution, and then scales, if possible, on the SoC side, which means that we're certainly missing features there. There's a couple of patches that were submitted on the list to fix that, but they also broke support for other platforms that are currently supported, and unfortunately didn't have the time to look at it in details at that point. But that's something I would like to resume working on to make sure that we also support the features that the sensor itself provides, and so have a wider range of platforms that could be supported there. But even though, for instance, the simple pipeline handler today supports or could support the DRM 5. One of the features that Dorota mentioned in the SoC there is that it doesn't have an ISP as such. It cannot do image processing and debayering, but it has a statistics engine. And that's something that can be useful, even if you have to implement ISP support using a GPU, for instance. The hardware statistics engine can be useful to compute information that can be consumed by the GPU after that, and the algorithms that are implemented there, without having to spend CPU or GPU time to compute those. And this is something that for which I expect that we could possibly have a dedicated pipeline handler, because there are specific features to that platform that need to be taken into account. As I mentioned, we don't support today in the simple pipeline handler any ISP. So it means that to make it really usable, you need to have a sensor that integrates an ISP. But I think that, and we'll get back to discussions about a GPU implementation of an ISP, this is something that I foresee as being a generic component that could be used by the simple pipeline handler as is, or even pipeline handlers for platforms that have some harder processing capabilities. It's not uncommon, especially for the lower end platforms, to have some sort of hardware ISP that can perform image processing, but not everything, and have some of the algorithms, some of the processing running on the GPU, or possibly even on a separate DSP. So having a hybrid hardware pipeline with different hardware components that need to work together is something that we'll need to support eventually. And that's also something that I would like to work on libcamera. So having GPU support as a generic component that could be used by different backends and different platforms.
Okay, thank you. I would be interested in knowing from Dorota, Martin, and Ben. We try to interact with the simple pipeline handler, and I looking at the development on the mailing list, I was under the impression that there was expectation for it to work mostly out of the box, and the expectation that instead you should write your own pipeline handler was kind of a showstopper, basically. This is for your impression on this one, but also about the fact that support for the pipeline handler shouldn't be meant to be something in charge of who makes the device. It should be something that should come from the vendors. And on this, I would like to ask also camera people opinions on how is this gonna going, or where this is going. So Benjamin, Dorota, do you have, I know you try to look into the simple pipeline. Have you considered writing your own one, or going directly to change the hardware interface and use that in the application? Still more appealing for you?
So in terms of having it working with the simple pipeline, there's some kernel patches that probably have landed in Megi's PinePhone kernel now that do make the PinePhone work with the simple pipeline. So any application that uses libcamera, and once those patches land, it should just work. For megapixels, the simple pipeline has too many limitations, and I haven't looked at doing a dedicated pipeline because megapixels already does all that stuff, and that would just be a lot of extra work for very little current benefit that could be used on, the PinePhone Pro or other projects instead.
Sure.
You mentioned limitations there, the simple pipeline handler. That's something we don't have to discuss it now, but maybe the mailing is on IC later. But I would be interested if maybe you had a list of few bullet points of what you think are the annoying limitations that you run into. So not something that I expect you to fix, but if we are aware of that, that's something that we can possibly address in the future.
Sure. I would like to ask you to note it down and move this point for later discussion, probably in the Q&A. Moving forward, we briefly mentioned the Python Pro, which is, in my view, is kind of a game changer because it's the first design that we have in this kind of devices, which fully qualifies a modern design. So it has an ISP which is capable of many different functions. So Ben, I would like to ask, what are the camera plans for the Python Pro? And it happens that the Rockchip RK399, which is the SoC that this phone uses, it's one of the platforms that libcamera support natively. And after Ben's opinion on what are the current development plan, I would like to ask Kieran, first thing, what does it mean to have a processor supported natively, and what are the feature set which could currently be expected from libcamera running on this kind of SoCs?
So in terms of the status of the PinePhone Pro, the drivers don't work. For the rear-facing camera, we do have a driver in mainline. It doesn't work, and we don't know why. I've spent multiple weeks trying to get this thing to turn on and work, and it powers, but we don't get any data out of it.
Sorry, Ben, that's the sensor driver, right? Not the ISP.
Yes, that is the sensor driver. The ISP does have drivers, and presumably they work.
Yeah, it's mainline supported, so that should be working.
Yeah, the front-facing camera doesn't have a driver at all. There is a driver that looks like it might work for the OV8856, but we don't know because that also just doesn't want to power on.
Okay. Kieran, instead, as I mentioned, the Rockchip 3399, it's natively supported by libcamera. What does it mean in terms of development effort, which can be saved for application developers? And what are the feature set which is currently supported on those kind of platforms?
So for the 3399, I'd say it hasn't been one of our primary targets, but it was one of our early targets that we started with when we were bringing it up. So it did get a dedicated pipeline handler from the beginning. We haven't invested as much time on the algorithms to handle the auto white balance and the auto exposure, but there are patches on the list that make that much more usable now, which are somewhat directly derived from the Raspberry Pi's implementation. They're waiting a review cycle before they get integrated, I think. So, I mean, I would say that for a Rockchip ISP platform, that by using libcamera, you would get all of the image quality in a much more usable state directly out of the box. But of course, there is still lots more that we can do. Also wanted to touch on the fact that I heard there's the 8865 sensor on the PinePhone Pro. I think that's one of the ones that I know Dan has been playing with. So,
so on the PinePhone Pro, it has an 8858, but the driver in mainline that might work is the 8856.
Okay.
Okay, too many different serial numbers.
Also investigate.
So Ben, the current plan for the camera support, apart from the kernel driver implementation, what about the application side? Have you been considering moving megapixels to porting that to new platforms? Have you been considering using a different design, which maybe relies on libcamera support for those kinds of platforms? Do you have any plans there that you would like to share?
Sure. So the idea is to bring the same support for the PinePhone Pro as already exists for the PinePhone. That should be fairly simple. A lot of the work that's gone into that Qualcomm device I mentioned earlier is the same work that would be needed for the PinePhone Pro. So most of the stuff is already working, and we just really need, I just really need to get the drivers working, and then I can start focusing on megapixels.
On the Qualcomm device, is there a system in place that handles auto exposure and auto white balance already to handle getting the sensor to run with a
I don't know that, sorry.
limit?
Well, I would propose to move that to a different point as well, because I would have the same question. I know that for the current Python, the autofocus is implemented in example by the sensor. If you're moving to a different sensor or even to a row sensor, how does it work that in your application? Because you lose that functionality because you have moved to a different sensor. But I would be more than happy to keep discussing that, but I'm afraid about time again. So if nobody has any other comments on that part, I would like to introduce a different point in the discussion, which is about the application themselves. So I briefly mentioned in the presentation that in the last years, the desktop camera applications and the mobile or embedded camera application kind of diverged. Because the first one assumed to work with simpler or UVC cameras, while the second ones are left a little bit behind. I invited David, Dan, and Hans to give a presentation about cameras application for different use cases, starting from a set of vendor-specific application like the Raspberry Pi application. So David, I know you have also prepared some slides for that. I don't know if you are capable of sharing those, but if you want to spare a few words on the Raspberry Pi camera stack and what are the lib camera apps and Pi camera 2 for Raspberry Pi.
Yeah, hi. Can you hear me all right, everyone?
Sure.
Yeah, great. I should just say that my colleague Nosh is trying to join here, but he's not having much luck at the moment. He's clicking on the join button or whatever, but it doesn't seem to be doing anything for him. So I don't quite know if he'll manage to join us, but we'll see what happens there. Yeah, so I've got one or two slides just to share so that I can talk about things. I guess I click on this toggle screen share, right?
Yep.
And that might do something, or it might do something bad. I don't know. Let's give it a try. Entire screen. Okay, let's go with entire screen. Why not? So yeah, so just a few little slides. So I'll just talk through them quickly. Talking about applications. Well, I guess just a few words. Why is Raspberry Pi dealing with libcamera? You know, given that we've gone all these years without it. I just listed a few of the reasons there, and kind of the main reason for using libcamera is kind of that it just exists. I guess. Can people?
I'm sorry, David. I have to interrupt you, but I think your slides are not visible. The screen is blank for me and for Kieran as well. I don't know if that's the same for.
Maybe it's
the rest.
You got anything come up there? No.
Nope.
Okay. Well, this is great, isn't it? Let me. It gives me okay. It says an element is sharing my screen. I can stop sharing, but it doesn't seem to be sharing at all, does it? Let's just try that again. Maybe if I share a window. Okay.
Yes, I can see your desktop.
Okay, so you can see my matrix window. So can you? Has that changed?
Not for me.
Okay, maybe. Let's try one more time. Otherwise, I'll just have to talk, I guess. Maybe it's because I'm.
So I'm sorry if you feel like talking about that. I'm sure that slides could be posted later for download. If you feel like just talking about that, that will be better.
Yeah, I don't seem to be able to get. Yeah, it only offers me the Chrome window. It doesn't offer me the other one. Anyway, hold on. I'll just make one more try here. Okay.
Yeah, why you were trying that?
Okay, do you have any...
better? Yeah, fine.
Okay, well, I'll just show it in the browser
Yeah,
from Google Drive, and that'll do.
Yeah.
Okay, so why is Raspberry Pi bothering with libcamera? It's kind of the question, because for years we've had this. I guess the architecture has been that we have this kind of GPU thing alongside the actual ARM cores. We have this GPU thing which handles all the, well, it's not only the graphics and the video encoders and decoders and all that stuff, but the ISP is there as well, and the camera system. And so we've just used the Broadcom camera stack, because Broadcom is the company that makes the SoC. And we just kind of talked to it as a bit of a black box, and we sort of have had little to do with it. But sort of going forward, that's not really where we want to be, for all kinds of reasons. And I've listed some of them there. Basically, we kind of have a need to take control of the camera stack for our own purposes, I guess is what it boils down to. Because that means that we can add new features, we can fix bugs, we can actually create an open ecosystem for people to use. And at the end of it all, I guess, is the thing that we just don't really understand what the hell the Broadcom camera system is doing anymore, really. So we're kind of stuck if we carry on with that. So that's why we've moved. So we've cut down the functionality in that GPU to an absolute bare minimum. So we end up we've transferred everything over to the ARM cores, and libcamera just kind of happened to be there at the right time, really, to give us a framework to plug into. As regards what we give to our users now, of course, users generally don't want to, they certainly don't want to program v4L2 controls, but even libcamera APIs are beyond what most of our users are capable of. Well, some of them anyway. And in fact, even C++ APIs or whatever is not what most people want. So again, historically, we've had certain applications that run under the Broadcom legacy stack. And so we've spent some time just reproducing those. In some respects, they're not terribly interesting. They do a random collection of things, of video captures and image captures and streaming applications and stuff like that. It's a bit of a random set, but so we have the need to reproduce that so that people can carry on pretty much as they were. I mean, a few lessons that we had from that was that, we found the libcamera API is still quite low level for most people, I think. It is quite hard to use. You spend a lot of time worrying about formats and devices and buffer counts and memory mapping things and all that sort of stuff. So again, people have to be quite brave, I think, to tackle that for themselves. So we found the need to put a bit of framework on top of that just to make that a little bit easier to use. So just one example of that. When we write camera applications now, they kind of look like this, basically. There's just a little, there's a bit of stuff on top that hides all the boilerplate. So you just run a little loop and you get camera frames, and that's kind of how it works. But as I say, even that isn't really what our users want, because a lot of our users have been using basically a Python library to talk to the cameras on the Raspberry Pi. The Python library that we've had for many years now is called PyCamera. And it's actually a little bit unlucky for us because we didn't write it. It got written by a third party. Only people kind of assume that Raspberry Pi is somehow responsible for it, but we never were. But so there's this thing out there that people like to use. And of course, now that we're sweeping away the Broadcom camera stack, their beloved Python library has bitten the dust. So they're quite unhappy. So what we need to do is we need to write something again on top of the new libcamera based stack that we have that gives them the same kind of functionality. And so we've imaginatively given it the name PyCamera 2. So just a little example of what it's all about. This is actually what most of our users want. They don't want applications that do particular captures or applications that, or they don't want ready-made camera applications. So they're quite different from like the mobile phone users. They don't want ready-made camera applications where they push a button and it takes a picture. They actually want to program stuff, but they want to program it quite straightforwardly. And so these are some of those examples that we need to enable for them. So
one question for you, David. The Python binding should sit on top of yourself or your application, or are you planning to exploit the forthcoming bindings, Python bindings for libcamera, and build on top of that?
Yeah. So what we've done is we've taken the kind of prototype Python bindings that you have in libcamera, and again we've put another layer on top of that, which is what we call PyCamera 2. And this is these are examples of what PyCamera 2 looks like, and this stuff all actually runs right now. So the example on the just to look at the one on the right there, that's how you do face tracking. Essentially, you just start a camera stream. You configure the camera and you start it, and then you just import OpenCV and you use that because the images transfer directly. So it gives a really easy way for people to actually do with the camera whatever it is that they want. So very often people want to do some kind of image analysis. Often they want to feed them to their favorite neural network framework.
Thank you, Dave, but I'm afraid that if that's your last point, I would have to interrupt you because we have 10 minutes left, and I would like to give Arthur the possibility to introduce the stuff. If you have a last point to make.
Yeah, so I guess the one last point to make is that certainly our users, they're perhaps a bit different, but we need to give them an API where they can basically do whatever they want.
So we are still going to go ahead with the raid. Not right now. We're going to switch over to the lightning talks now. But I will turn on the camera when we go do that at 12 noon, 12:02, 12:05. So just hang tight. And again, I apologize for not being on cam often. Everything kind of went nuts today. So my apologies. And I'm supposed to be here.
Where you apply a certain set of cuts, so that these are, let's say, requirements on objects that are reconstructed, and then with only a couple of events, you could, for instance, claim that there is some new physics signal, but if the data are available in the open, let's say, anyone could come and say, look, I found, let's say, a second Higgs boson or something like that, or the graviton or some new particle, and then it would be on our side, so on the side of the collaboration, to basically disprove these claims, right? Whereas, let's say, if we I mean, the way things work internally is that it really takes a long time for an analysis to become public, because there are so many review stages internally that have to be passed. So until basically everyone's happy, and then the whole collaboration signs the paper that is sent to the journal. So that there's of course a certain risk involved, but I don't think it's that realistic. I mean, it's at least so far nobody has claimed anything, because it's actually also quite a lot of work to do that.
Yeah, thanks, Clemens. I have a question for Janina now, and it's something that maybe we asked a little bit Clemens as well. Did you encounter challenges, or which were your biggest challenges in this process that you led? I don't mean only tech challenges, of course, but mostly about cultural challenges and people, like, yeah.
Yeah, I think that with this particular project, and that's perhaps why we choose this to share with you here today, We have this combination of researchers that believe that openness in software and data are important, and it is a product that we have to do. That what we do, especially with public funds, belongs to the people. So it's a kind of obligation that we have to make our tools be accessible and be useful for the people beyond the research inside the institution. And at the same time, people who have the decision power. So I was part of the board of directors, so I can make decisions about tools and money and what we are going to do during a couple of years as a research, and put this topic on the table and get resources to do this. So you have the upper line and the bottom line, all in with focus on all in the same, all thinking the same. So I think that when you have these things aligned, it is easy to achieve, because if this is something that the higher rate on the institutions send to the bottom, probably going to take a lot of time until people actually wants to do it. And if you push, it's also take a lot of time. So, but the hard part is to people to understand that you're not losing anything if you share your code and your data, that you actually are going to get more opportunities. And most important, what you do, your work is going to be used. What else do you want as a researcher? That's something you build is useful for other people. So, so related with Paul, that is asking me how the package download the data. That is why we don't have an API, because some of the developer still doesn't understand that we need to put that openly, and anyone can and has to download the data and use it. And we shouldn't be doing things to people not do that. So internally, we still have some discussions, but I think that when you open it, I mean, if you can open a door, you can open a window. So we open the window with our package.
Thanks, Janina. I see there's another question for Clemens from Paul, which is, are source code for other instruments also open sourced?
Yes, yeah, in principle, that's also the case. For instance, the Atlas experiment, which is on the other side of the ring, so the LHC, that is also public. It's just not hosted on GitHub.com, but it's hosted on CERN's own GitLab installation. So you can find that on I think gitlab.cern.ch, and but I don't know the exact URL. But in principle, also all the other software is also publicly available.
Thanks, Clemens. I have another question, which is maybe both for Patricia and Janina, although in getting probably different answers. Did you have, or do you have, a dissemination plan for your tool?
Who wants to start? I can try and start. With like, if something's developed under project funding, sustainability is always a bit of an issue, and which is coming to the end of this project. But the team is based at the University of Bremen, and they have committed to take it forward. They're also now working with some institution in Germany, and they've brought some folks in from the big German research data infrastructure grants that have just started up, and potentially some follow-up European Commission grants. So there's going to be quite a bit more work as part of that. And I guess those, depending on which projects they fit into, they will shape the dissemination plan. We're kind of just getting to the end of spreading the word for this project, and I guess now it's a bit seeing, like, now that people have heard about it, what other ideas do they have, and how can we take that on board in some of the next projects.
Yeah, in our case, we did some workshop on how to use the package internally. And as I mentioned in the top, we have strong links with communities related to our ladies and metadocencia and carpentry. So we're probably going to do some meetups on how to use the package, so we can go beyond people who is academic and who do science. And we also probably are going to do not only present the work, but some kind of workshop on other conference like Latinar and HAYO, that's in Argentina. So people also in industry can know about the package and how to use it. Whether data is really important, is the data that people must consume on the from our web page, because crops and livestock depends on that, and we depend on what happened in the sky. So this is something that has a lot of demand, and when people knows about the tools, immediately start to use it. So because it is a huge need of this kind of data.
Thanks, Janina. I have a question for Clemens. So I'm curious to know, since you open the CMS data, the LHC data, did you see any extraordinary, I mean, not extraordinary as a second Higgs boson, of course, but did you see like something coming in from like not the collaboration, but outside because of opening those data?
Yes, yeah. We actually had quite a few, I mean, actual physics analyses that have been performed. And also, I mean, one thing that has been really important, we actually received lots of feedback. So there have been papers, publications that were actually addressing, what are the difficulties if someone else is using the data, and what is the first step actually to get started, and so on. But yeah, so we have some papers that actually perform full physics studies, and then there are others that, for instance, focus a bit more on computing related topics and things like that. But yeah, but there have been some let's say actual new physics results as well.
Great. We have the last 45 seconds. I don't know if you want to add anything. Any of you? Otherwise,
Thanks for organizing this and for giving us the space to share our work. Thank you so much.
Yes, thank you.
Indeed. Thanks from me as well.
Yeah, thanks to all the three of you. It was great to have you here. Thanks for taking the time on a Saturday. Again, I know, I mean, it's supposed to be weekend, but it's great to have you here. We're having a social moment in like a few seconds in a Jitsi room. We share the link. So if you want to join us, thank you all again. Thanks for joining the Open Research Tools and Technology Dev Room. I hope to see you all
And that is today's stream. Again, sorry for not being on cam. You can probably see it with my hair's even more crazier than normal. I didn't realize that today was going to be like this action-packed. But that was day 1 of FOSDEM. I hope everyone enjoyed what they saw. This was a neat experiment. Again, I don't plan on being anywhere near this busy tomorrow. And I also this was also a learning experience for me about like the timing of all the talks and how to load everything and stuff. So tomorrow should go a lot smoother. Tomorrow is going to start at 4 a.m. again, but we're going to go probably closer to 1 p.m. instead of 12 noon, simply because of the closing ceremony. Tomorrow is going to be more like there was some security talks today, like stuff that was based on security, both in mainly blue team security, since we're looking at DevSec type stuff. Tomorrow is the security track is going to be turned on, so it's almost going to be all about security. There's going to be an update on the seamless kernel, which I'm excited for. There's then going to be a really, really interesting talk. It's probably like, honestly, my most hyped talk after the Log4j talk, about a decentralized internet and how the Mari people are using it. And it's always so fascinating to see minority groups really adapt, really dive into technology and kind of use technology the way, it was supposed to be used in the hacker way instead of the boring AWS, metaverse type of bullshit way. Then we're going to look at a policy tool called SecPaver. And then we're going to look into a workshop about securing and hardening a container host, which is something that I have no idea how to even do that. Like, I have containerized portions of the Linux operating system, but I've never actually, I think at most I've run like the generic command line to do that, but I haven't I have a feeling this is going to be a lot more in depth and advanced than that. So I'm really excited. Let's see. Oh, and thank you, End Time Wizard, for following us on DLive. I always appreciate that DLive is still going on and kicking. Let me just look here, see if there's anything else, because I already have the channel we're going to raid. It's interesting to see what's streaming around noontime. It's kind of fascinating. So, that's in German. Let me just do a quick reload. What was that? So then we're actually gonna so then we're going to talk about Rust. So today was Go, and it annoyed me. Now tomorrow's also gonna be about Rust, but it's about sort of the safety features built into the language of Rust. Then we're gonna look at a fun coding section for a while, and then we're gonna take a break from all of the security to some degree, but it does kind of involve security. This is the other hype talk for me of the con, which is about PlayStation 3 emulation, because it's really, if you've seen Modern Vintage Gamers videos, it's really broken through, has come a long way. Then we're going to look at something called, I'm going to pronounce this wrong, Trocior, which is a Kubernetes key management service. Then about security programming. Secure communication with TLS, which, if you've ever seen NCommander's YouTube channel, you always hear about TLS. So after that talk, I'll finally know what the hell he's talking about. And then we're ending it with, of course, the thing you always end it, which is you can't just make a sandwich. You have to use sudo, and about all the security stuff involved with the sudo command, which I've heard about, but I've never seen details of. I've never seen anyone actually do a deep dive on it, so that's fascinating. And then we're going to watch the closing ceremonies together, and hopefully someone will donate a few bucks. Unfortunately, no one has donated anything for this stream, but that might change. Oh, people are just popping up online. That might change on the next stream. So I am excited for tomorrow. I'm going to take extra time out today to work out all of the scheduling kinks, and hopefully things like pipes and stuff doesn't burst anymore in the apartment. So I can all focus on this. My planning on being on the camera pretty much the entire, everyone's getting online now, pretty much the entire time. So that's going to be exciting. What happened to my, just trying to make sure that the person I was going to raid is still raidable. There he is. There he is. Is there anyone else above him? Let's see. You know what? Let's see. What is this happening? All right, well, what we're going to do is we're going to go raid this interesting thing, and it's actually going to be related to two channels that we saw. So that's going to be fun. But if you're on Twitch, we're going to go raid this stream. And again, thank you for watching this charity stream. Again, doing this we've never done this early in the morning / this late at night. We've never done it during twilight hours. So 3 a.m. to noon, thankfully on a weekend, because we could never do this on a weekday, has been a huge learning experience here and a real big test of my endurance. That's going to be really fun. But thank you for watching. Stay tuned if you are on Twitch, because we are going to attempt to raid this channel, provided that we can actually raid it, because the module just failed to load. If you like the content that you've seen, you can like, click, share, and subscribe on our channel on Twitch, DLive, and YouTube. We already got some followers on DLive. It's always, again, nice to see DLive people be active. Or DLive. I call it DLive because I'm a heathen. If you want to follow us on YouTube, you can please hit that bell and turn on all notifications, because YouTube is a poorly optimized piece of shit. Talk about bad closed source programming from a company that's supposed to be open source. But yeah, and tomorrow also, because I'm going to literally work on it in 4 hours from now, the PeerTube live streaming should be working again. So we'll finally be able to do the full FOSDEM experience. So I will see everyone at 4 a.m. in the morning tomorrow, and hopefully we'll get some donations in. And then last but not least, again, just as a reminder, tomorrow, from now until tomorrow at 1 p.m., and actually probably bits of Master of Unlocking, that will be our last big push I sound like Clive Barker right now. I'm so tired. Despite the energy drink, I am just dead tired right now. But this will be our last push to raising money, as you can see with the bar above, the Children's Miracle Network Hospitals, which is a great charity where all the money that gets donated to them, they send off in even amounts to various pediatric centers and children's hospitals across the United States and Canada. And we're trying to start off the new year because our 2021 to 22 just completely sucked ass. So what we're trying to do is make sure it doesn't suck ass to a bunch of kids who are sick with COVID and other type of illnesses during this time. And I'm an American, so I know exactly how bad our healthcare system is. Right now, we are still at $308.50. Our goal is $600, but that's just a goal. All the money that's being donated, including Fee One's Dead, $69 nice dollars, is all going to go to these kids in need, no matter what. So any amount, even if you donate $1 or $5, that's how we got to the $300+ in the first place. That'll go a long way. If you want to do donations now, or do it all the way up until Master of Unlocking tomorrow, once again on Twitch, there's a widget right below, and stay tuned on Twitch. We're going to raid this awesome group. Their whole thing's going to start off at 12:30, so there's a bit of a preview screen. Basically, I'll put it this way: if you like my show Crypto Barons and you like JavaScript, you're going to really like what you see here. It's very FOSDEM. We also have the QR code so you can scan on your phone. And then finally, last time, we're sharing the link in chat. So whether you're on Twitch, DLive, or YouTube, you can click that link. You can donate. When I show back up on the stream, it will show who's donated between this stream and the next stream. And I'll shout you out just like you do with the follows, but even more. So I basically worship you the entire stream. It's going to be great. So yeah, that was our first day of FOSDEM. It was really cool stuff, especially with going through the Log4j stuff. It's also hilarious and kind of sad to see that cameras are to mobile FOSS development software, like porting Linux kernels over on phones, the same way the desktop Linux kernel is to printers. That's just giant Achilles heel for multiple insane reasons, and that's just absolutely crazy. Also, a lot of new tools are being made, new languages, new processes. Very, very fascinating stuff tomorrow. I'm very much looking forward to the Marori thing and the PlayStation 3 stuff. So that's going to be cool. Anyhow, that's it for the stream. Say hi to the people we've raided at FOSDEM. Hack the Planet, Dare You Jersey, represent, remember, eat no matter how much Monster you drink. 3 a.m. in the morning Eastern Standard Time is really fucking annoying, even for an insomniac hacker like me. So anyhow, peace. Enjoy the outro music.